will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hi, and today we're gonna to make our field dynamic. And there is first step. We need to realize algorithm. How can we reveal our cell? Okay, and there is a bunch of examples. So in case when we have empty cell, I clicked somewhere near here, it means that we should open all cell with status empty. When we click to the cell with digit, it's just reveal only one cell with this digit. Okay, in case when we click to the bomb, game over, and we won't be proceed with our game. So let's make this algorithm into our code. Okay, and as far as you remember, previously we've done increment neighbors function. Okay, and it was inside cells manipulator. And also we have cells manipulator test.ts. Okay, because we're gonna to develop this functionality using TDD, let's start from the test cases. First of all, let's rename our statuses. Empty to A, bomb to the B, and let's add one more status. We need to add hidden, because right now we just need to manipulate with the status as well, and mark it as hidden. Okay, and then let's add several test cases. Okay, and this should be something like this. Open cell action, simple cases with loose, and open cell with the bomb. Because it's very simple case. We need to detect cell with bomb and then just raise an error, like example. Okay, let's create one more function, open cell. Okay, and then let's think what should be type signature for our function open cell. Okay, and we can look to the increment neighbors, and we have coordinates, field, and we should return field. So probably there is the same type signature for the open cell, except a parameter field, because we should have two kind of fields. One field, it's just for the user, it's kind of player field. That should consist with hidden statuses and revealed cells, and real instance of game field, because without information about game we cannot to open some kind of cells, because we cannot to find a way to make it, because it's just will be player field with hidden statuses. Okay, and let's return by default just player field. Looks like we've done it. Okay, and let's right now proceed working with our test case. I wanted to create simplest possible scenario. Okay, let's just import open cell, and then here we go. There is our simplest test case, and we expect that we trying to open cell by the coordinates 1 1, and there is just a player field, this bunch of hidden statuses. As far as you remember, we just mark hidden as H, and in this case, when we click to the coordinates 1 1, it means that we should click somewhere here, and there is just a bomb. In this case, let's throw an error, game over, and just let's run this test in watch mode, and there should be an error, because our test case right now cannot be satisfied by this code, and as you can see we just have one failed test case. Okay, let's continue working with open cell. Okay, first of all, let's just import cell state from the field. yeah, cell state, or better to group it as like this, yeah, cell then cell state, and then just use the destructurization for the open cell, yeah, because we're gonna to use this kind of statuses. Okay, empty, hidden, and bomb. Okay, then let's just detect onto the game field our cell by the coordinates. Okay, and there we go. Right now we just take coordinates, yeah, just destruct coordinates, and then just take game cell by from the game field by these coordinates, yeah. So next we need to check, is it bomb or not? Okay, here we go. Yeah, right now we just check that our game cell is bomb, and in case where it's just a bomb, we throw a new error, game over. Yeah, and it's fully satisfied our test case. Yeah, as you can see, we passed all test cases. Yeah, and right now everything works as we expected. Okay, but it was just simplest possible scenario. Yeah, let's think about more test cases. Okay, here we go. Right now I've done one more test case, open cell with number, yeah, a group of test cases, and then open cell with state equals 1. Yeah, what do we have into the open cell? Coordinates 1 1, and then it's just the field for the player with all hidden cells, and then game field, yeah. And on the coordinates 1 1 we have digit 1, yeah, and as you can see it's just one bomb that surroundings by these ones, and then just a column of empty cells, yeah. So, and when we click to this coordinate, it should reveal only this cell, yeah, only one number inside, yeah, and everything should be hidden surrounding the cell. Okay, how can we do this? Okay, and probably it should be something like this. Okay, here we go. Right now, when it's not a bomb, yeah, we should set up status for this particular cell to the game cell, yeah. We just set up player field y-x coordinate by the game cell, yeah, that we should reveal, because it's not a bomb, yeah, we absolutely sure in it. Okay, and there is one more test case that we passed, yeah. Okay, let's add one more scenario, yeah. Right now I have one scenario when we open cell with state equals 1, yeah. Let's make one more, yeah, when we're trying to open cell with state, like example, okay, 3, yeah. Okay, and how can we do this? Let's mark this column by bombs, yeah. First column is just bombs, then it should be 2 bombs here, 3 bombs here, and 2 bombs here, yeah, because we have 2 neighbors bombs for these cells, 3 for this and 2 for this, and there is just empty column. So when we click to the coordinate 1 1, yeah, it should be just 3, and we should reveal only 3, yeah. And as far as I can see, our test has passed, yeah. When I put 1, it should be failed, yeah, but when I put 3, it should pass. Okay, let's proceed with one more scenario when we have empty cell, yeah, because it's probably one of the most important case. Let's take a look to the browser again. Okay, and as far as you can see, when we click to the empty cell, we should reveal only open cell and cells with digit, yeah. We shouldn't cross this like borderline where we have digits. We shouldn't pass, yeah, we shouldn't move forward, yeah, we should stop when we reach bomb or cell with digits, yeah. So it means we should reveal only empty cells, yeah. And as far as I can see, there we have one border case when we have empty cell, yeah, that just have one touch, yeah, onto the diagonal, yeah, line, have one touch between this cell and this, and we should reveal this vicinity, yeah, because it should be behavior, yeah, when we open empty cells. Okay, let's continue working with it, and we need to add more test cases. Okay, there we go. Right now I have open empty cell, simple 3x3 case. Okay, and what do we have? We have coordinate 1, 2, yeah, and for the player it's just hidden field. So for the game field we have the same status as open cell with number, yeah. It's just one bomb on the left middle column position, and one column with empty cells. Okay, and when we click to the 1, 2, it should be this cell, yeah, and we should reveal in this case right cell, right column, and also this digits, yeah, middle column with digits 1. Okay, let's continue working with this into the cells manipulator. Okay, and what should we do? First of all, we just should check that this game cell is empty, yeah. When this game cell is empty, we should reveal this cell first of all, yeah, because it's just an empty cell, it's not something unexpectable. We should reveal it. What should we do next? Yeah, and probably we could use get neighbors item and the same approach, yeah. We could take neighbors items, yeah, okay, and then just trying to iterate per every neighbors. Okay, here we go. Right now I have this behavior. We just take neighbors item by the coordinates, then we take these items and trying to iterate per every item, yeah, and just take coordinates. So next we check item in the field, that there is an item, it's not out of limit of our field. Then we destruct coordinates, yeah, and after this we should just take information from the game field. Okay, we just take game cell and player cell by these coordinates from the game field and player field. Okay, what should we do next? And it looks like recursive stuff. We should proceed working by recursive way. Okay, and what is our condition? If our game cell, yeah, is equal to empty, and when player cell is equal to hidden, yeah, we just right now we is not revealed this cell, yeah, we need to call our recursive function, yeah, and we need to put to the player field our open cell, and then just push here our coordinates, then our game cell, or no, should be player field, yeah, it should be player field, and then just game field, yeah. It means then when we have empty cell on the game field and player cell is hidden, we should open by recursive way all possible cells surrounding this item, yeah. Okay, and what should we do next? And for the next condition, it should be something like if we have this cell is not a bomb, we should reveal it, yeah, and probably we could put it by this way, yeah, we should reveal it in case when player cell is less than bomb, yeah. When it's bomb, we shouldn't do it by this way. Sorry, but it shouldn't be player cell, it should be game cell, yeah. because we check onto the game cell. Yeah, it won't be a player cell. Player cell it has no any information about real game status. Okay, and right now we passed our test case. Okay, let's take a look to the test cases and one more. Okay, there we go. Right now I have really production mode scenario. For the player field, we have just hidden cells. For the game cells, we have something like corner left top corner, it's just bombs. Yeah. Then we just provide information how many bombs surrounding the cells. Yeah, and it should be probably not by this way. Yeah, because there should be one bomb. Yeah, and let's just change it. Let's put here 3, yeah, and there should be only 1, and there should be only 1, and then here just 1 and 1. Okay, and there is, yeah, it looks much more better. Yeah, and there should be 1 1, and then there we go 1 1, and there should be probably 3. Yeah, okay. And right now everything has passed, yeah, and we need to check it. Okay, there is our field, yeah, and there is case with, as you can see, behavior where we have vicinity that have common border with the centered cell. Okay, and we wanted to check open cell by the coordinates 2 2. It means it should be this cell, yeah, and then we should reveal all the vicinity except these bombs, yeah, and just like example we have this revealed state, yeah, and you can see it. Yeah, we right now just open this cell and then just revealed all possible cells surrounding this empty vicinity. Yeah. Okay, and right now our test has passed. Okay, everything looks cool. Okay, our game mostly, yeah, most useful function open cell is ready to use. Okay, and see you in the next video where we're gonna to proceed working with game dynamic behavior. Okay, see you in the next video. Bye. Hi, and today I wanted to introduce you idea of modulus. And modulus, it's something that includes logic, like example dynamic behavior. And from our side we can make something like game with hooks, yeah, because we just gonna to develop game based on hooks. I mean use state and stuff like this. Okay, but before, let's make game settings file. And there should be a bunch of types and consts that we are going to use into our game model. And let's make something like game levels, and there should be a bunch of items that provide for us different game levels. And let's make it as const. Yeah, it's just a pattern that create kind of tuple. Yeah, in game levels it's not just a collection, just an array. It's fixed size tuple. Okay, then I wanted to make union just to make a type based on this tuple. Yeah, and for these purposes we have construction like this. It's just type of game levels and then just provide number. It means we take every item from this tuple and make it as union. Yeah, looks a little bit weird, but it's just a TypeScript stuff. Yeah, okay, and there should be information about a particular level, like example size of the field and how many bombs should be inside field. And it's just an aliases size and bombs to make these tuple settings. Yeah, and then settings just provide for us information about level. Okay, and last but not least, it's game settings collection. It's just a record based on level names as keys and settings as values. So actually look into the settings. Right now I have just number, and it's not something that I really expected. Yeah, I just expected some kind of aliases, but in this case let's put just number inside this tuple. Okay, and right now everything that we want is just prepared. Okay, and there is just a basic template for game-based hooks, yeah, and there is index tests that export game-based hooks from game-based hooks. Okay, then into the index file, I wanted to replace this stuff. Yeah, I don't want to keep this static version of the game here anymore. Okay, let's just copy and paste everything to the game-based hooks. Okay, here we go. Right now I have just a bunch of imports of components, then our static field, and we return this static game. Then it means we could import it into the index index.6 here. Yeah. Okay, let's replace everything and just put here something like import and modulus and then just game-based hooks, import game-based hooks, and then just replace stuff here to game-based hooks here. Okay, right now everything looks fine, and from our side it should be absolutely the same as before. Yeah, let's just reload our page, and as you can see, just static version of the game. Yeah, nothing is changed. Yeah. Okay, let's continue walking into the game-based hooks file. Okay, what do I wanted to make first of all? Yeah, and instead of this kind of static field, I wanted to generate dynamic field. Yeah, and just render it into the browser. But previously, let's handle behavior to change our game level. Yeah. Okay, and we have game levels into the game settings. Okay, let's import from the modulus game settings, and we need to import game levels. Okay, and instead this bunch of levels, I just put here game levels. Okay, and as you can see right now, we have something that just doesn't work as well, because from the type perspective it's just different types. Okay, and there is just a probable solution. I'm just converted to the unknown and then to the string array. And in case when I just won't be converted as unknown previously, I just have the same error, yeah, because we cannot assign type as, you know, mutable collection to the read-only collection. So it means that right now we provide information about game levels. Okay, and it should be some kind of dynamic behavior, yeah, and in this case we just should import use state. Okay, and what should we do? We should create a level and set level, and then just call use state. And what should we take as the type for this kind of state? It should be probably level names, yeah, and we should import level names. Okay, and level names, and then we can assign, like example, beginner by default. Okay, and then we should provide this level to default level for the scoreboard. So, and it means when we just open our browser, nothing should be changed, yeah, Okay, and here we go. Right now we just cannot to reassign this level, yeah, when we trying to assign it to some different kind of option, it's just an error. Okay, and what should we do just to make it dynamic? And we have callback on change handler, yeah, and when we change level, just trying to change level, we should call set level and install somewhere here new level. Okay, and there should be a code like this, because it's just a HTML event. It should be some target, and then we should take value from this target. Okay, and then we should assign value to set level as level names, because we are absolutely sure that we provide information about level. And as far as we can go, we should use Typescript, of course, but in some cases it could be some misspelling, some misunderstanding between Typescript and your code, yeah. And in this case, like example, we have value as string, yeah, and probably we could fix this behavior. But from the perspective of select or scoreboard, it just should be a bunch of data, just an array of strings that we should render. And of course we could use from this perspective just an assertion from the Typescript perspective. Okay, let's check this into our browser, and right now when we change this level, we just immediately can see that everything works fine. Okay, so what should we do next? And probably we need to generate a dynamic field instead this kind of static field. Okay, and we have empty field generator into the helpers field. So we need to import this generator, and here we go, empty field generator, and we need to generate field by according to these settings that we provide from the level perspective, yeah. So let's check what do we have into the game settings, and we have game settings collection, and there is just an information that we should provide to the generator. Okay, let's take this kind of object, game settings, and then we just take from this game settings based on the level. We should take size and bumps parameters, yeah, and then we could use it into the empty field generator, yeah. We could call empty field generator, and what do we have as parameters to the empty field generator, and there should be just the size. Let's put here some size, and then let's create variable player field. So, and then we should provide this player field instead of static field. Let's just drop static field, we don't need it anymore. Okay, and let's check what happened into our browser. Okay, and right now it's just an empty field, as you can see, yeah. Okay, but we need to create just a field with hidden items, yeah. And into the empty field generator we have one more parameter, state, and by default cell state empty. We should put here something like, okay, we need of course import cell state, yeah. Let's import cell state, and then just call cell state hidden. And right now it should be something that we really expected, yeah, and it's just a bunch of hidden cells on the field. And when we change a level, yeah, we just dynamically regenerate this field, yeah. And we could look to our code, and as you can see, when we set new level here on the callback on change level, we just provide information about new level, and then we just take from the game settings based on this level size and generate player field, yeah. And per every change of the game level we generate new player field, yeah. So there is a big step that we've taken. Okay, I wanted to stop here, and on the next video we just continue walking with our game, and it just should be dynamic, full dynamic functionality for the minesweeper game. Okay, see you in the next video. Bye.
Hi, and today I wanted to present you user event. And it's very useful API that can simulate user action and user interaction with browser and user event based on fire event. And what difference between user event and fire event? I wanted to show you a bunch of examples. And we have component search. And this component use state and create search search state and set search action using use state. We have on change event that when we have this change event, subscribe on target from HTML input element and just set new search value. Okay, and we have search input component that consists of input and a label for this input. There are two props on change and search. On change is just a callback for the input change, and search it's value for this input. And when we call this on change event, we change state and then provide here new search value. Okay, and right now I wanted to create several test cases. First one, that we render search, and we just expect when we query by text by default search for JavaScript, it's nothing into our component because we have no this text into our template by default. Okay, and then we call user event type and await. So it's a sync method type that provide for us API that emulate every action from the user side. What happened when user type something to the input? It's a K down, K up, then K press event. It's a bunch of events that happen in some sequence mode. So our user event action type provide this kind of emulation. And we search by role on the page text box item and put into this item JavaScript. Okay, and then we expect that onto our page we have search for JavaScript, searches for JavaScript. Okay, and as far as you can see, we have search, and there is a paragraph where we have searches for, and then there should be search item that we typed on the previous step, and it should be JavaScript. Search for JavaScript. Okay, then we can detect what is the difference between user event and fire event. And there is an example, when we create on change mock function, and then we take not a search, and instead of search we render search input. It's input with label. Then we provide here on change mock and call fire event change get by role text box and put here new value JavaScript. And then we detect that on change to have been called only one time. It means when we change something into the input, it change it only one time when we use fire event. Okay, and what is the difference between fire event and user event? And there is the example. How can we detect it? The same behavior, we create mock on change and search input. Then we call user event type and provide here a text box, and then new value into this text box should be JavaScript. And after this user event, our function on change to have been called 10 times. Yeah, per every letter, per every symbol, we have different event. Yeah, different event that emulates user kpress sequence of events. Okay, and there is a very fundamental difference between first one example and second one. Okay, and we're gonna to use user event during our coding session. Okay, I can show you that right now our test case works as we expected. Yeah, everything works fine. Yeah, our test case has passed, and you can find this example in the examples directory. We have testing library user event directory where we have such and such text. Okay, so see you in the next video. Thank you.
Hi, and let's make test cases for this behavior. Game this hooks.test.tsx. And what should we test onto the game these hooks right now? And of course we could test basic render behavior, and then we should test that our dynamic behavior when we change level works fine. Okay, let's make basic test case. Okay, there we go. It's just test case game with hooks, and we just need to test render behavior. And basic test case that render game field, we just should render game field by default without any problem. Okay, what should we do? We should call render and then just provide here game with hooks. Yeah. Okay, it's just a basic test case. And we can check that our snapshot looks as well. Yeah, that it means that our snapshot just matched with previous snapshot. Okay, and what should we do from the probably expect perspective? And we need to find cells on the page. And how can we find cells? Okay, and as far as we remember, into the grid component we have component cells, and for every cell we have prop role, and for every cell we have role cell. So it means that we could call screen get all by role, and we need to set up role cell. Okay, and how many cells should be on the page? And as far as you remember, by default we have beginner level. So, and for the beginner level we have field probably 9 by 9. Yeah, and it means it should be 81 cells. So let's check it. Just to have lengths, and it should be 81. So let's run our test case, and we'll see that everything works fine or not. Okay, and everything looks cool. Yeah, right now we have a test case that works fine, but these green lights means that we have not enough coverage satisfaction. Yeah, and coverage threshold right now is not satisfied. Yeah, because we just test this, we just run one test case, and of course one test case cannot to provide for us 100% coverage. Okay, but test suites works fine. Okay, and was just basic test case. Let's like example just change this number, and as you can see right now we failed test case. Okay, so let's move forward. And what should we do to make next? Yeah, and probably there should be test case when we change level. Yeah, and how can we test behavior like this? And there is one more useful library, a user events. User events, it's kind of part of testing library that works as a real user. Yeah, when we call fire events, it's kind of emulation. Like example, when user just make something from the keyboard. It's a lot of events, K down, K up, yeah, K press, and we could emulate from the fire event just the particular events, yeah, and from the user event we could emulate real user event. So let's make one more test case. Okay, and first of all, let's just render game with hooks. And then we need to run user event, and there we go, we have select options. And then we should call screen get by role. And then we should call combo box, yeah? And from this combo box we should select okay, like example, what we can select, game settings. Okay, let's select intermediate, yeah. And when we select intermediate, that our, as you know, yeah, our field should change, and then we could call expect, and we could take every cell on the page, and there should be, according with intermediate settings, 16 by 16, and there should be 256 items on the page. Oh, sorry, right now we have broken test cases, and there shouldn't be checkbox, it should be combo box. Okay, let's just use autocomplete combo box, yeah. And as far as I can see right now, when we change this combo box, it's just changed a state of the field, yeah. And by default, it should be length 81, yeah. And when we change it, it should be 256, yeah. Okay, and actually I'm not a big fan of snapshot testing. Okay, and we could check by the length of the field, yeah. We shouldn't test every snapshot, yeah. And I won't do it in this test. I won't check it using snapshot. Okay, and based on the same pattern, I could change it to the expert. And expert, it's field with size 22 by 22. So, and there should be test case, yeah, and it should be 484. So when we check this behavior, I mean when we change something on the page and then detect it immediately on our test cases, it means that probably on this stage everything works as we expected. Yeah. So on the next lessons, probably we move to the TDD approach. We first of all just trying to make some test cases, and then move to the functionality and continue develop it on the screencast session. Okay, see you on next video. Bye. Hi, and today I wanted to continue working with game with hooks. And today I wanted to make code that should open our cells. And as far as I remember, we have helper cells manipulator, and there is a function open cell. When we call open cell, we provide coordinates of the clicked cell, player field and game field. And based on the game field, we just change player field. And player field could consist of hidden cells that player cannot see, and the game field is just full information about game field. So, how can we make the same behavior into the game with hooks? And probably we need to generate one more field. Yeah, it's just not empty field generator, it's just a field generator. So right now we need to create one more constant that we can call game field. So then we need to call field generator, and we need to provide size and probability. Okay, we have size, and how can we calculate probability? Yeah, and probably we should call bombs and divide it to size by size, yeah, size squared. And yeah, it's not something that I really expect. It should be something like this, yeah. Okay, so it means we just generate one more field. It's just a game field. So what should we do next? And probably when we click to the cell, we should just handle it. Yeah, we just should handle click behavior. Okay, and as far as I remember, we have grid, and into the grid we have cell, and we have onClick that we just provide to the cell component. And inside cell component, we just handle this onClick behavior. Yeah, we just call onClick and provide here information about coordinates. Yeah. Okay, let's just move a little bit more forward. Okay, you have rest parameters. Yeah, and when our as we can see, yeah, when we have hidden cell, we just provide whole parameters. It's just a rest of parameters. Okay, and we have onClick behavior here, handler. Yeah, we just provide here just a function that call rest onClick and put here coordinates. Yeah, so it means when we call onClick, we have handler that could receive coordinates, and we could call a function. Okay, let's create function onClick. And here should be coordinates, yeah, that we could take from the field. Okay, and then we just need to provide these coordinates to the onClick, yeah, coords, and mark it as coordinates, and then we could call a handler, yeah. And what should be as a handler for this stuff? And for the cells manipulator, we have open cell function, and this function receive coordinates, player field and game field, and then just work with it works with game field and return player field that should be consist of real real areas that we should open according with minesweeper rules. Okay, let's import open cell, and then let's just call open cell right over here. Okay, and as parameters, what do we have? We have as far as I remember, coordinates, then player field, and then game field. Okay, everything looks fine except one thing. Yeah, player field is just a constant. Yeah, we cannot just rerun rendering process based on the player field. What should we do? And probably we need to make one more dynamic state. Okay, we need to create use state based on the empty field generator, and we need to create player field and set player field methods. Okay, and then we don't need this player field anymore. Okay, and we can actually mark this state as field, yeah, just to provide information about data type. Okay, and right now when we call this open cell, we receive new player field, and then we could set up new player field using set player field. And how can we do this? By default, use state and setter just cannot reassign value. Yeah, it's just won't work, by the way, when we have previous state and next state. Yeah, and components decide should we re-render or not based on the comparison between object. Okay, I can show you. When I just put to the set player field directly new player field, it won't re-render our component. Okay, last step, we need just to take this on click and put it to the grid. Yeah? Okay, and let's check into our browser how does it work. Okay, and when I click somewhere, probably right now we have no any re-render, yeah, and it's something that we really expect. Yeah, so let's try to change this behavior, and for this purpose we need to spread new player field. Yeah, and when I open my browser right now and just trying to open something, of course I need to rerun my web server, just 1 sec. Okay, and here we go. Right now I just can click, and as you can see we have behavior as we expected. Yeah, I click and everything works fine, yeah, except behavior with bombs, yeah, and everything looks good except game rules. Yeah, so and when I re-render this behavior, yeah, as you can see right now we should just regenerate our field, yeah, based on the new level. Okay, and right now we should create one more function that we call onChangeLevel. Okay, let's create it. Okay, and right now we have this function onChangeLevel, and let's take this string setLevel from here and put it to the onChangeLevel. Okay, then we need to provide this callback onChangeLevel, and when we change level we should regenerate our player field, yeah, based on the settings. And of course we could take the same behavior, yeah, we could just generate empty field generator based on the size. Okay, right now we need to add a little bit more logic here, because we can actually call it not value, yeah, we can call it level, yeah, level. Okay, and then just map this value as level. Okay, and then we should take new information about game level, yeah, because right now we just set up this new level, yeah, and we need to, based on this information, take new value about size and bombs, yeah. So okay, and right now everything looks as we expected, yeah. We have function change level that when we call change of the level, we just immediately set new level and then take information about current level settings, generate new empty field, and then just put it as player field. It's kind of reset, yeah, action when we change level, so we should reset every open cell. We have on click action, and when we click to the cell it should open our cell. Let's check it into our browser. Okay, and right now I just start from the beginner and just put here some kind of click actions, yeah. And as you can see, when we click to the bomb we have game over, yeah, but we can continue because everything still works as we as we expected, yeah. It's just kind of behaviors that we won't handle right now. Okay, and when we just reset, yeah, everything just regenerates. Okay, and okay, probably we just reach our goal and create on-click handler. Okay, on the next lesson we should cover this functionality by tests, and see you in the next video. Bye. Hi, and let's today debug our code, and first of all we need to add new option to the Webpack config, and there is a bunch of options that we could implement in the Webpack, yeah, and in the section dev tool, we could put eval source map. It's high quality source maps that should be into our code. Okay, let's make this option. And as far as you can see, we have dev tool, eval source map. Let's start our application. And let's check how it looks into the browser. And we need to open our application, and as far as you can see right now, our model is on the screen. So let's try to debug our code, because probably something went wrong. Yeah, our game just have some I don't know, probably it has some misspelling or some bugs that we need to find. Okay, let's find problems, and for these purposes we need to open debugger tab. And in this tab, as you can see, we have like example game with hooks. Yeah, it's our component. Yeah, and you can find all code into the Webpack, and then you can open src, and there is the same, absolutely the same bunch of files, and you can detect your file system in this you know, like file system 3 or some kind of just trees that present for us information about source code. Okay, and let's check what happened into the game with hooks. And we need to put a bunch of breakpoints. Yeah, let's just trying to open something. Okay, and let's just put some you know, just trying to open some cell, and then just continue walking. Okay, and looks like when we click to the area, then we just set new player field, and then we start to generate, as you can see, next render event, next render tick, and there is a logic for this tick, and we as you can see right now, go to the string 28, and then we just call field generator, and there is our issue. Yeah, we just generate game field per just per every render cycle, per every render loop, and it's something that we really cannot expect. Yeah, it means that every render iteration we have new game field, and there is an issue why our open cell logic cannot just works fine. Yeah, so it means that we should prevent generation for the field per every render. Okay, and for these purposes we have use memo into the React. Use memo. Okay, and we could look to the use memo declaration, and you can see what happened. We have function that just generate data that we need to have, and dependencies that should just, when something into the dependencies array changed, we should recreate this data based on the functions that we provide as first argument. Okay, so let's right now just use our use memo hook. Yeah, let's call use memo, and then let's call a function. Okay, and we need to provide dependencies that we have for this data. Yeah, and when we should regenerate our field, and probably when size parameter is changed or bombs, we should regenerate our field. Yeah, so but before these parameters is changed, we shouldn't regenerate our field per every render iteration. Okay, let's check behavior into the browser. Okay, and I need to just drop these breakpoints. Okay, and then let's play into this game. Yeah, and right now I'm immediately trying to open BOM, and everything of course shouldn't work in this case. Okay, there is one more BOM. Okay, and then I can continue. Yeah, okay, everything looks fine for us. Okay, and it looks like cheating version of the game. Yeah, we can open cell until it's until it's real normal cells that we can open. We open it. In case when it's BOM, we just won't be opening it, and everything works something like cheating version of the game. Okay, looks like we've done our debug session, and you always can use debugger, and it's very useful skill in your toolkit. Okay, see you in the next video. Bye.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hi, and today I wanted to move forward with test cases, and right now I have test cases that just render our game field with default parameters and on change game level handler. Yeah, and as far as I remember, we just when we change game level, in this case we just take new values from the field generator and put new player field, yeah, and just reset everything to the new state. Okay, so right now we need to test on click behavior, yeah, when we're trying to open some cell. Let's add more test cases. Okay, right now I have test case to open cell, yeah, just a bunch of test cases, open cell test cases, and particular test case open empty cell on the beginner level. Okay, and what do we need to test? When you're trying to open some kind of cell, example empty cell or cell with BOM, we just call function open cell. Yeah, and then open cell just receive player field and game field, and it's just attempt to open a player cell. So probably we need to have some predefined player cell and game field, yeah, in case when we just gonna to work this random slice of player field and game field, it's something unpredictable. We cannot to handle it by this way. Okay, and probably we need first of all just to mock into the field our function field generator, yeah, that should provide for us expected result per every call. So let's make a mock for the field generator. Okay, and there we go. It's just field generator with static kind of fields, yeah, and field for the beginner level, field for the intermediate level, and field for the expert level. Okay, and in this case we always will have something expected, yeah, and from the test perspective it can be very easy to detect something, yeah. Okay, right now we need to make not only field generator function, also we need to probably mock something more, yeah, or just use the same functions from the field. And for these purposes in Jest we have one more feature. Okay, and there we go. Right now I just export cell state, it's just a link to the original model cell state, and generate field with default state, that also just a link to the original model. Okay, or we can make it a little bit more better. Okay, but let's move forward to our test case. Yeah, right now we need just to call just mock. Okay, and it means when we are trying to call some import statement into our files that involve to our test cases, we immediately just replace it by our mock realization that we have into the helpers __ mocks, yeah, field. So right now we always gonna to have predictable behavior. Let's try to make our test case. Okay, and there we go. Right now we just render game with hooks, and then we click to item with coordinate 0, 0. As far as you remember, we have logic for the game cell, yeah, and we just put to the data test ID our coordinates, yeah. So it means we can easily detect it into our DOM by test ID. Okay, and after this event we should have lengths, right now also I've import from the cell state empty state, yeah, and we just trying to find items by role cell, and like value, like item, I mean content, it calls name from the side of the selectors, React Async library. We need to put this empty value. So, and we can check it into the field, yeah, how many empty fields do we open when we click to the cell with coordinate 0, 0, yeah, and we can easily count it's just 18 items that we should open. So let's run our test case and we will see the result. Okay, and looks like I've detected some problem, yeah, and right now it's the long way to find what problem is, yeah, and probably I can see it. Type error cannot destruct property empty for the cell state, yeah. Okay, why it happens, yeah? We need probably add more information, test information. Let's check original model. What happened in this moment? Okay, probably there is trouble, yeah. When we call original model, it's not immediately put to the cell state something, yeah. It's undefined and then cell state with data, yeah. Okay. Probably one way to fix it, we need to add real data right over here, yeah? Okay, and there we go. And right now everything works fine, yeah? When I put here cell state and generate field with default state, everything works fine. Our test case has passed, yeah, and everything works as we expected, yeah? And we can add one more check, yeah. We just trying to find cell when before our click event, we just trying to find cell with empty state, and there should be length 0. And of course we need to change get all by role to query all by role, because when we are trying to find something that right now it's not in the DOM, yeah, we just immediately face this problem, yeah, and there should be an error, yeah. But in case when we just query all by role, it means that when we have nothing to find, we just return empty array, okay, and we can detect that have this array to have length 0. Okay, and looks like our test case with open empty cell works fine. Okay, let's add one more test case when we click to the non-empty cells area, yeah, and we need to look to the field generator, and probably we can click to the top right corner, yeah, and it should be coordinates probably 0, 8, yeah, because right now we have 0 from the y coordinate perspective and 8 from the x coordinate perspective. Okay, let's add this test case. Okay, and there we go. Right now, when we click to the coordinate to the top right corner, we just detect that we have one cell with item 1 inside, and there should be just one item with this data, yeah. And as you can see, when we click to the right top corner, just only one cell should open, yeah, and into this cell it should be 1. So looks like we've done 2 basic test cases, okay, and we've done what we planned on this lesson. Okay, and see you in the next video. Bye. Hi, and looks like we've done all necessary toolkit, and we need to move forward with our test cases and continue working with game based hooks model. Okay, let's test that when we change our level, that behavior for the cell opening works fine. Let's render our game with hooks, and then we need to check that our field have length that we expected, yeah, and there should be just 81 cells on the field. Okay, then we need to change our combo box, yeah, to the intermediate, just change our level. Okay, and when we change level, it should be 256 cells on the field. Okay, so what should we do next? Let's move to the field mock, and there is right bottom corner where we have just 2 empty cells, and when we click to this cell, it should open both of these empty cells. Okay, let's just click to the coordinate 15, 15, yeah, and then we should expect that there should be 2 empty cells, yeah, just 2 empty cells. Okay, let's wait until our test will be done. Okay, everything works fine. Our test cases has passed. And right now I wanted to probably change it one more time to the expert level and click one more time. Okay, and I've done this kind of selection. We just change our level to the expert, and right now we have 484 cells on the field. Let's find some very convenient cell. Okay, and right bottom corner again, we can click to this item, and then we can receive that only one cell will open. Okay, let's check it. Okay, and I've just clicked to the coordinate 21, 21, and then we detect that only one cell opened with value empty, yeah, with name empty. Okay, and we have several more cells that should open. We should open 2 cells with 1 inside and 1 cell with 2 inside. Because when we open area with empty cells, we should open some border cells that just have, like, if this cell is empty, when we open this empty cell, we should open neighbor cell with the numbers, yeah. So, and let's check that right now on the field. We have cell with 1, it should be 2 cells with 1, and 1 cell with 2, yeah. Because right now on the field, as you can see, we have 1 neighbor cell with 2, and 2 cells with 1. So then our test cases should has passed. Okay, let's wait in. Okay, and okay, looks like everything has passed and our test cases works as we expected. Right now we just tested one more case when we reset our field. Let's look to the our component, to our model, okay, with hooks. And when we change size or numbers of bombs, we just immediately regenerate our field using useMemma, because we have two dependencies in the useMemma. And when we change our level, we use this behavior, yeah, when on change level callback, just called by the scoreboard select item, select element, we should just set level that we detect from this element select, yeah. And then when we set up new level, we just take information from the game settings and take two items, size and bombs, yeah? And into the dependencies array our items is changed, and then we regenerate our field, and so we render new game field, yeah, I mean new player field with information about game field, yeah. And when we call onClick item, we just pass to the open cell player field and game field, yeah. And game field should be new after new rendering. Okay, let's put one more handler, and there should be on reset. When we press the reset button, it should reset our player field, yeah. It should be just player field with all hidden cells, and also we need to regenerate our game field, yeah. So let's make this behavior, and let's make this feature to the TDD, yeah, according to this TDD. And we need to remember what a reset button is. And reset button is just a button, yeah? And when we click to the reset button, we just call this handler on reset, and then we should call our behavior into the game with hooks. Okay, and there is our reset handler. Right now it's just a dummy function, yeah? Let's make this behavior. Okay, and we need to click to the button on the field. Luckily, we have only one button, yeah? And when we click to the button, we should reset our field, yeah? But before we can open something, yeah? Let's just open some kind of item, yeah, and just call click, and we detect that there should be only one, as you can see, yeah, only one cell with value 1, yeah, with name 1. So, and when we click to the 0, 0, it should be 18 empty cells. Okay, let's make this check too. If this check is passed, that means that we can continue working with reset button, yeah? And reset button should revert it, and we shouldn't have anything except just hidden cells on the page. Okay, there is our scenario. When we click to the cell with coordinate 0, 8, it should be just only one cell with 1 inside. When we click to the cell with coordinate 0, 0, it should be 18 cells with empty state. Okay, and when we click to the reset, it should be just 81 hidden cells on the page. And when I uncomment this last assertion, it should broke our test case. Okay, let's wait in. Okay, and as you can see right now, we've done it, yeah, we have broken test case, yeah. So let's move forward, and we need to make on reset handler works as well. Okay, and what our on reset callback should do? Of course, we need to create a new field based on function field generator. Yeah. Okay, let's make new game field. And then we need to create new player field. Just generate a field with default state. Yeah. And then we need to set up new player field, but also we need to set up new game field. Yeah. But as far as you remember, we generate game field from the beginning of the session, yeah, and then just memorize it. Okay, we need to move to the use state. We need to generate a game field using use state. Okay, and there we go. Right now I move this logic of field generation to the use state. And last step, we need to set new game field. Yeah, we set up a player field and we need to set new game field. We need to use spread and put here new game field. Okay, and right now our callback on reset probably works as we expected. We need to test it. We need to put this callback to the scoreboard and wait until our test has passed. Okay, and right now we have one broken test case, yeah? And it looks like we have test case where we trying to, yeah, sort new level and then just trying to call our click handler. Okay, let's move to the code. And when we click to the cell, we should set up new player field. Okay, but probably on the stage when we change our level, when we change level, we should set up new game field and new player field. And probably it's better to call on reset here. And then we just call both of it. We just regenerate our game field as we expected. Let's waiting. But of course it won't work by the way as we expected, because right now we just won't waiting until we re-render our component, and we need to provide this information about game settings. Yeah, so let's take this information, settings, and then put it to the on reset. Okay, and finally I found a way to make it. And right now we have reset handler that receiving tuple that consists of size and bombs. And when we call reset handler on the change level action, we just put here new settings. And when we call reset directly into the component as action, as callback, we just call reset handler and provide here size and bombs. That should we take from the closure, and there is, as you can see, size and bombs from the closure. Okay, and as you can see, finally all our test has passed and everything works as we expected. And our final test case, let's call it, and as you can see, everything has passed. Yeah, every test case has passed. And right now, what do we have? We have on click behavior, we have on change level behavior, and on reset handler. Okay, let's run our application and just check it onto the browser. Okay, and there we go. Right now, when I click to the cell with bomb, nothing has happened. Yeah, but when I click to the cells without any bombs, everything works fine. Yeah. Okay, and looks like we've done it. We've made a lot of changes, and I don't want to make this video longest than 13 or 50 minutes. Okay, and see you in the next video where we continue to develop our game. See you, bye. Hi, and let's make behavior for the game over, and we need to make several stuff here. First of all, we need to set up a new state. Okay, and we have flag is game over, and setter for this flag set is game over. Okay, let's use this flag to the game over. And when game is over, we need to show this kind of pop-up with smile. Yeah. Okay, and let's first of all just make a test cases to detect this behavior. It's very easy to detect when player lose the game. When we lose the game, we just can catch our error from the open cell. When we trying to open cell with bomb inside, we just immediately raise an error, and then we can catch it and set up new state. As far as you remember, we have mock for the game field, and we can detect a bomb and then click to the cell with this coordinate. And this should be 0 from the y coordinate and 7 from the x coordinate. Okay, 0 from the y and 7 from the x coordinate. Okay, let's run test, and then we should make this test works fine. Okay, and everything works as we expected. One test case failed. Let's make this behavior into the game with hooks. Okay, and we should just try to catch an error from the open cell behavior, and then when we find an error, we should immediately just raise this kind of pop-up. And in case, okay, and when we catch an error, we just set is game over to the true, and we should raise this pop-up onto the screen and detect it. But right now, as you can see, we have isWin as predefined state. It's just true. We need one more state. We need to set up isWin or not, and set isWin. By default, of course, it should be false, and when we our game is over, we just should to put this flag into the pop-up state. Okay, and right now let's wait until our test has passed. Okay, it looks like we've done it. Right now our test works fine, but what should happen when we click to this handler? And probably there should be reset behavior. Yeah, when we click to this pop-up, everything should be reverted to the default state. Okay, let's make one more test case just to check this behavior when we click to the game over pop-up. Okay, and everything works as we expected, but I wanted to make this scenario a little bit more clever. We need to add behavior when we, like example, open some cells and detect that our field is not a closed field, like default field with all hidden cells, yeah? And then when we click to this pop-up, we should revert it to the default state, and we expect here that there should be default state for our field. Okay, let's just copy and paste this scenario from the previous test. Okay, and it means that we just detect some changes onto our field, then click to the bomb, and after we press to the game lose pop-up, everything should be reverted to the default state. Okay, our test cases has passed, and right now we detect player lose the game state. But what about win? And probably there is much more different scenario. Yeah, we need to first of all add one more handler that could set up flag to the cell, yeah, and then when every bomb marked as flag, we should just detect that everything except bombs is opened, yeah, and every bomb marked by the flag state. Okay, let's right now just check into our browser behavior for our game. Okay, and let's click to the some cells. Okay, everything works fine, and yeah, loose state, as you can see. And when we press to the reset, yeah, right now I found one more bug, yeah, that we need to throw it away. Yeah, we need to detect that our game just rerun. Okay, let's work on this test case, and we need to add more test scenarios. Okay, and we expect that when we click to this pop-up, everything should be resetted, and our smile, yeah, our pop-up shouldn't be in the document. Okay, let's make this work as we expected. And when we call reset handler, we can set is game over to false, yeah, and probably we can revert as win to the false as well, yeah. So, and let's put this behavior. Okay, and right now we just call set is game over and put here false, and set is win to the false, and it means that our pop-up should disappear and is win flag should be reverted to the false. Okay, let's wait until our test will pass. Okay, everything works as we expected, yeah. 7 test has passed, and right now we can check this behavior in the browser. Okay, let's just press some cells. Okay, we lose, yeah, we cannot to continue actually, yeah, we need to add one more test case. We cannot continue when we lose, yeah. Okay, everything works as, yeah, it's something unexpected, yeah. We need to stop. We need to stop open new cells when our game is lost. And we need to handle it by this way. When our game is over and we lose, we should set up player field as just game field, yeah, game field, yeah. It means that we should open all our field and provide information about bombs in the field. Okay, and we need to test it. We need to add one more test case. So it means when we just lose our game, we should detect that on the field everything according with our mock. Okay, and looks like we've done it. I just detected all states on the field, yeah, from the cell perspectives, and I just received that we have 0 cell that hidden, 27 cells that empty, 30 cells that consist of 1, and 20 cells that consist 12 cells that consist of 2, and 2 cells that consist of 3, yeah. So right now our test cases has passed, but you can ask me what we should do with win state, yeah, because right now we just detect lose game state. Okay, and it should be a little bit more complicated, and we continue working on win game state on the next video. Okay, see you in the next video. Bye. Hi. And let's run our test case game with hooks, and then we just detect how many time we spent for this operation. Okay, and right now we can see the result is 15 seconds. It's pretty close to 16, and it's probably too many times that we need to spend to detect all changes that we need. And even more, when we look through this test, we always need to use selectors, and it's not something convenient for us. And right now onto the game with hooks, we cannot to test just data instead of our rendering side, template side. And one way how can we make our logic separately from the view layer, we can make our custom hook. Let's make our custom game hook that gonna to just close all business logic of this particular component to the separated file. Okay, right now I've done just basic template use game and use game test. So let's move forward, and we need to make the same logic as for game with hooks. And probably we can copy and paste all information that we need. Okay, and then we need to import that required for this use game hook. Okay, and right now it's just a separated hook. Yeah, I'm just copy and paste logic from the game with hooks to this use game hook, and also we need to describe what it should return. Yeah, what we are gonna to use in game with hooks, and probably callbacks. Yeah, as far as I can see, and bunch of data that we need, like example, level is game over, is win, and player field. Yeah, then on click handler and on change level handler and on reset. Okay, let's make this return type declaration. Okay, here we go. It's just a bunch of data from the beginning on the of the interface. Level is game over, is win, settings, and player field. And then 3 callbacks: on click, on change level, and on reset. Right now we need to just probably copy this interface and paste it here. Yeah, and then level, it's something that we have into our file, is game over, is win. And for the settings we should put size and bombs. Okay, and then it should be player field, and on click handler, and also on change and on reset. Looks fine, but on change level right now it's kind of function that receives that we are gonna to put here event from the HTML. Okay, and I wanted to replace it just to the level, mark it as level names. Okay, because it's just a hook. All necessary information that we receive from the DOM, we could use it into the game with hooks. Yeah, here we have this action, yeah, on change level, and there is a place where we put this logic, destruct information from the HTML event and put it to our callback. Okay, and right now everything looks cool. Let's import our use game hook, and then we can easily just replace this code, yeah, to something like this. Yeah, it's just a bunch of data that we receive from use game hook. Okay, and we can drop all necessary imports. Yeah. Okay. And then we need to destruct from the settings bombs. As far as I remember, bombs is second parameter for our settings. Okay, and right now for the change level we just need to change this function a little bit. Okay, everything works, probably should work fine, because we just copy this logic and paste it to our use game hook. Yeah, let's run our test case for game with hooks test. Okay, and I see the green lights. Green lights is good. And we need to make the same test cases right now for use game hook. Yeah, instead of this kind of expensive check that we need to spend something about 15 seconds, we can easily move to the use game test. Yeah, let's make our test cases. Okay, and I just wanted to reproduce this kind of test cases step by step to my use game test. So I'm just copy and paste these test cases. Then I wanna just to comment this code and replace it to something that gonna to be works as well with hooks. Okay, and what should we do? Probably we need to run our current test case in observable mode. Okay, just run and watch current file mode, and then we gonna to make our test. First of all, let's just mock our helpers field, I mean field generator function, just to make predictable behavior. And then I wanted to reproduce these test cases step by step. First of all, instead of render, I wanted to use render hook. And then we need to detect that we have a field with 81 cells, but we can say that our field 9 by 9, and we could detect 9 rows in our array. But first of all, let's distract data from our result current, and then we can call assertions. Okay, and first of all, I wanted to detect that level is game over, is win, and settings on satisfied condition, and it should to be strict equal some object that we provide for this kind of assertion. Yeah. And for is game over, it should be false, and for is win, it should be false. Of course, our game just has started. Yeah, we right now cannot detect some kind of final state. Okay, what about level? And from the level perspective, we have beginner, intermediate, and expert. I wanted to make it a little bit more convenient because we always gonna to use this kind of data. Okay, and I just wanted to use destructurization and destruct all game levels that we have. So then I can easily detect what levels it should be. It should be beginner by default. As far as you remember, we set up beginner as default value for our use state hook. Okay, about game settings, and we need to import game settings, and then we just need to call settings and game settings beginner. And as far as you can see, right now we have green lights are good, yeah, and we can move forward, yeah. So we need to detect that our field is it has size that we expect. And we can take our player field and detect lengths of this array, yeah, and it should have lengths, has lengths 9. So let's move forward to onChange game level handler. Okay, and the same pattern here. We just render our hook, and then we distract data that we need for this test. And as you can see, we just change our levels and detect that size of our field is changed. Okay, let's make the same logic here. Okay, and by default, beginner player field should have length 9. Okay, let's move forward, and we need to detect when we change our level. And for these purposes, we need to use act. As far as I remember, act just provides for us a convenient way to call some functions and wait until our rendering next rendering iteration just reach ending. So, and right now we can detect that when we change level to intermediate, our field should change. And then we just take new information from result current, and then just detect that our intermediate player field it has length 16. And by the same way, I wanted to check this behavior for the expert level. When we change level to the expert, we detect that our player field it should have length 22. Okay, so we just reproduced 2 test cases. Let's move forward to open cell test cases. Okay, here we go again. There is just a render hook, and then we just take result current, player field, and on click, and we detect that player field by default it has length 9. Okay, right now we need to make probably one more manipulation, because when we query all by role, we detect only empty cells. How can we do it with data? And probably we can flood our array, because right now we have 2-dimensional array. I wanted to make 1-dimensional array and then just filter it. And for these purposes, we need to add one more function. Okay, here we go again. Right now I have function flat with filter, and we receive a field and condition that we need to filter. First of all, we just flat our field, just make one-dimensional array, and then filter it by our condition. Okay, and we can use this function right now. Again, one more manipulation. We should import cell state and then just destruct information from the cell state. Okay, and then we can easily use our flat with filter. We just provide here player field and then condition what we are looking for. And from the beginning we shouldn't have any empty cells, yeah, and this player field it has length 0 for the empty cells. Okay, and one more check. When we click to some cell with coordinate 0, 0, we should detect that then it should has 18 cells with empty state. And we need to call act and provide here information about coordinates. Yeah, we call on click with coordinate 0, 0. It's absolutely the same stuff that we have here. Yeah, so then we need to check that our result consists of data that we expected. Okay, and right now we just take information from the result current as new player field, and we detect that we have 18 empty cells. Okay, and by the same way we continue to move forward and make it step by step. Okay, and right now I've already reproduced all scenarios that we need. And as you can see right now, our test cases less than 1 second, yeah, something like 362, yeah. It's something very convenient for us. For from the test cases perspective, it should work fast, because nobody wanted to call test cases when we need to spend 1 minute or 2 minutes just to detect that behavior of our code works as we expected. Okay, and right now what should we do with this game with hooks? And probably we need to drop all scenarios. And what should we test from the perspective of game with hooks? We need to detect that our functions, like example on change level or on click here on the grid, on click here on game over, should calls. Yeah, it should calls. So on the next lesson we continue refactoring and just refactor this game with hooks logic. Okay, see you in the next video. Bye. Hi, and I wanted to show you Stryker report. And right now I see that into the models we have something unexpected in game with hooks. And right now I've already checked what happened. Into the use game hook, we never test how many bombs do we have on the field, yeah, and we need to check it. Because right now Stryker just trying to change this kind of condition and we never test how many bombs on the field. And also we haven't covered set is game over behavior and set is win when we reset our game state. So from my point of view, we need to fix this kind of situation, and I've already done it. From the use game, I've right now add one more item. It's game field, yeah, and I return game field. Then it means that I can easily take it from the test. And right now I've take here we have game field, and then we're trying to find how many bombs are on the field. So also when we reset, just one more sec. Yeah, here we go again. When we have scenario on reset game handler, I've test bombs on the field too. When we reset, we should turn back to the default state from the game field perspective. Okay, And in the grid right now we have nothing to the context menu handler, and we see this item, yeah, when we just trying to change it by undefined, everything has passed, and it's something unexpected from the Stryker perspective. But on the next video we of course fix this behavior. And right now we can see that our test report it doesn't look fine, yeah, but let's wait until I rebuild our report. And one more thing, right now we have mock and field in this mock, and Stryker just trying to mutate our mock realization, and it's something that we really shouldn't do, yeah, because I really don't see the good points to mutate our mock data, yeah, because we won't using any kind of cell on the field for the tests. Okay, and how can we fix it? In the Stryker we have strikerconfig.js, where I've already put it mock, as you can see, with invert behavior, yeah. And this exclamation mark means that we shouldn't mutate mock and snapshots, because I don't see any point to mutate everything in the mock or snapshots. And even more, we never mutate test or spec or stories, because I don't see any point to mutate these kind of files. Okay, and right now I wanted to wait until my test reports are gonna to rebuild. Okay, and right now it looks much more better than previous version, and we still have some minor problems into the field, yeah, but probably everything works as we expected, yeah. And from this side it's timeout or static mutate, because we are gonna to make mocks, yeah. So okay, everything works as we expected. It looks much more better. Let's move to the test cases. Okay, and instead of check every possible state on the field, we need to detect that our callbacks works fine. Okay, let's make these kind of test cases. Okay, here we go. Right now I've done several test cases, render game field by default with default state, and we just trying to expect that our fragment works fine. Then we need to check that cell click works fine, reset, change, and game over reset action works fine, yeah. So let's make our first scenario. Okay, and for the cell click, we need to just click to some cell on the field, and then just detect that our function had been called. And as far as you remember, we have game with hooks, and we just take all necessary logic from use game hooks that we've done before. So how can we test that our click function called this kind of handler, yeah, this kind of on-click callback? And probably we need to mock our use game hook. Okay, here we go. Right now I've just done a bunch of mock functions: mock on click, mock on change level, and mock on reset. And also I mock use game export directive, and there is a bunch of data that we need to have from the use game. Okay, and what should we do next? Right now I have broken test case because our snapshot doesn't look fine. We need to regenerate snapshots. And we just can press U to update our snapshot, and everything works fine now. Okay, and per every test probably we need to reset mock, because our mock functions should be default per every test case. Okay, and we can call before each hook, just call just clear all mocks per every test run. Okay, and right now we can easily detect that our function has been called. When we click to the cell, it means that we should call this mock on click. And then we can detect that our function, that our callback have been called. Next, we just render our game with hooks and then just click to the button reset and detect that our mock on reset has been called. Okay, and the same logic for the combo box. When we change level to intermediate, we should call mock on change level. And when we click to the game lose, as you can see by default, we set up that game is over and we lose. It means that we should render this kind of smile, and we can click to this button and then detect that we've called mock on reset. Okay, and right now we need to make one more step. I wanted to generate test report, coverage report from the Jest and coverage report from the Stryker. Okay, and I was compelled just fix our pattern because from the Stryker perspective, snapshots it didn't mutate it at all, and I fix this pattern for the mocks. Okay, and little bit more changes for the use game. We always have mock. When we test our use game, we need to have predictable behavior and we mock our field. But we cannot test this kind of scenario with field generator. When we generate field, we just need to detect that our probability to have some bunch of bombs on the field should calculate by this formula. We need to divide bombs by size squared. So to just fix this kind of behavior, I've added one more test case, use game check game field, and there is a bunch of test cases, 2 test cases. One just detect how many bombs by default, and one more detect how many bombs when we reset the game itself. So actually we can clear this kind of information because we've tested it on the previous test case. Okay, and for this side we actually can only take game field. We don't need to check again the same information as on the previous test. And when we have dynamic game field right now, we can easily to find that our Stryker mutate everything as we expected. Okay, let's check our test report, and right now, as you can see, when we calculate this probability and trying to mutate it, of course our test cases immediately detect that something unexpected happened. And right now we have much more green report in this comparison to the previous one. Of course we have these minor issues, but from the probability side we cannot fix it. Okay, and even more, right now our test cases works very fast, and one absolutely necessary requirement for the test cases, it should works very fast as possible, because when test cases passed probably during 1 minute or more, it's good case for the CI perspective, but from the user perspective, from the programming side, it's not something expectable. Your test should works as fast as possible. And right now we fix it using our custom hook, and testing just data, not DOM elements, and we just test that our callbacks works fine from the game side perspective. Okay, see you in the next video. Bye. Hi, and today I wanted to start to develop a very important part of our game. It's ending state, when we win our game. So first of all, let's start from small refactoring. Right now I have cells manipulator, and there is function open cell, and also cells manipulator test and open cell action test cases. Let's just split cells manipulator and separate open cell from the cells manipulator. Okay, there is first step. I just create file open cell and then put here function open cell and import everything that depends in this function. Yeah. So next, let's just drop unnecessary imports from cells manipulator. Okay, and last step, we need to create open cell test.ts. Okay, now I've dropped information from cells manipulator test.ts and move everything to the open cell.test.ts. Okay, right now I have open cell and open cell test.ts. Let's run tests that just detect is it some kind of regression or not. Okay, and I found a problem that open cell right now is not in the cells manipulator. We need to change to the open cell. Okay, let's run test again. Okay, right now every test has passed, green lights are good, everything looks cool. Let's move forward. Right now we have no any regression, yeah, and so right now we have open cell function, but we need one more function that set up flag on the field. I mean, part of functionality, when I click to the cell, I just need to set up flag to the cell when I click pressing Alt, of course. Okay, then second click it's just weak flag and then flag is disappearing. Yet 3 possible states: empty, then flag, then big flag, and then empty again. Yeah, like loop of states. Yeah. So let's just add a file, set flag. Set flag.ts, and by the same way let's put here set flag.test.ts. Okay, what should be inside set flag? Okay, and I want to make absolutely the same signature as an open cell. Yeah, we just take coordinates, player field and game field, and then return new field. Yeah, so the same stuff into the cell flag. But what should we do? Yeah, and we need to create this loop of the states. Yeah. So let's first of all just distract data from the coordinates and take y and x coordinate from our coordinates. Then take cell from the player field and take all possible states that we need to have during this function run. Yeah, flag, weak flag, and hidden. Okay, we can use switch case logic. Yeah, just switch using cell and then just detect cases. Yeah, probably in case of flag we should set up, like example, hidden, or of course not hidden, it should be weak flag. Yeah, from the flag we should switch to the weak flag. Okay, for the next state, like example weak flag, we should switch to the hidden state. Yeah, and from the hidden we should switch to the flag. And we need to add one more case. Yeah, it's probably default. Yeah, and probably in case of weak flag and in case of default we should switch to the hidden. Yeah, so right now looks like everything should works fine. Let's return our player field. Okay, and we need to test this kind of function. So here we go. Right now we have test cases with set flag to the cell click, and cell flag to the non-hidden cell should be ignored, of course, and that flag action to simple 3x3 case. Okay, let's cover first scenario. Okay, what should happen when we provide player field and trying to set flag to the coordinate 0, 0. Here is just a number, yeah, and we shouldn't change anything. Okay, and we can expect that our new player field to strict equal, something like this. Yeah, it should be the same stuff. Let's watch current file just to detect our test cases. Okay, and there is an error. Yeah, we just right now have one failed test case because we just trying to set up hidden state. Why is this happen? Yeah, and probably because we just add this default state. By default, we shouldn't change anything at all. Yeah, and right now we have green lights. Green lights is good. Yeah, and we can proceed to working with this test cases, and we can that flag action in simple 3x3 case. We can detect our scenarios when we run this loop. Yeah, so let's find first state. Okay, and when we click to the coordinate 0, 0, when we have hidden cell, it should be flag. Yeah, so let's run click second time. Yeah, after second click, and when we click to the coordinate 0, 0, it should be weak flag. Yeah, so right now our test case has passed. Let's move forward, and of course we need to set up player field after second click. Yeah, so and let's run third click after third click, and we just wait that after third click it should be hidden. Yeah, after third click. Okay, everything works fine as we expected. Yeah, and right now we have one more function, set flag, and we can easily implement it into our function use game. Yeah. Okay, and as far as you remember, we have this handler on context menu. When we call this handler, we can run our function set flag. Yeah, so but we using hook use game, and of course realization should be into this hook. Let's make this handler. So, and here we go. Right now we have on context menu, and what should we do? First of all, we need to import from the helpers set flag. So, and then when we call on context menu, we should provide here set flag, and then coordinates, player field, and game field. Yeah, and it should be something like new player field. Okay, and then we should set up new player field using set player field. And of course we need to add this kind of function. Yeah, on context menu with the same signature as on click. Okay, so then we should return this function on context menu, and we can easily just destruct this function from the use game hook, and then provide this kind of handler to the on context menu. So right now every test has passed. We can easily just run and test our game. Okay, let's run our game. For these purposes we need to run npm start. Okay, here we go. Right now when I click as a right bottom button of my mouse, I can see that first of all it's just a flag, then weak flag, and after that flag just disappearing. Yeah, so I can easily just detect some bombs, yeah, and set up here flags, but I'm not as good as probably other players in the minesweeper. Yeah, okay, but right now some part of our functionality works fine, and we need to move to the test cases. Yeah, because we just skip this part when we add this kind of functionality to the game. First of all, we need to test that our onContext menu handler calls from the UI side. So we need to add mock for the onContext menu. Okay, and then we need to add one more test case when we just click at the right button to our game cell. Okay, and for these purposes, we just take any cell, like example with coordinate 0, 0 by test ID, then just click and provide additional information that we should press second button of the mouse, and then that our more context menu to have been called. So then let's just find that every test has passed. Okay, everything works fine. Okay, we can move forward. Okay, and I just added one more test case context menu handler, and then just render hook and take information from the hook about player fields and on context menu handler. Okay, let's just run on context menu with coordinate 0, 0. Okay, and then we just should take information about new player field. And then let's just flood with filter, and we should find state flag, yeah, in case when as far as you remember, into our field we have by default here just 0, but okay, it doesn't matter at all because we just create this default player field, yeah, and it should be hidden, of course, state. So, and then it should be just one item that marked as flag. Okay, let's run these test cases, and our test cases has passed. Okay, looks like our functionality works fine, and we can move forward with detecting our solved puzzle state when we win our game. Okay, and see you in the next video. Bye.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hi, and today wanted to make function detect win state, yeah? So, and just to detect solvable puzzle, we need to add one more file. So let's take a look to the function detect solved puzzle, and we have this as you can see signature, yeah, and we just detect that on the player field we have absolutely matched information according to this game field. Yeah, I mean, from the bomb's perspective, we should mark every bomb as flag, and we should open every hidden cell that not contain a bomb. So as you can see just right now, I return false and 10. First item in this tuple is just state is we solved puzzle or not, and second one, how many flags do we have on the field, yeah, just to skip this part of aggregation on the field side, yeah, on the game side. We just return immediately how many flag do we have on the field. Okay, so also I've prepared one more test case. Is just a very simple game field. As you can see, it consists of 1, 1, 1, 1, and just only one bomb, and empty cells on the right side. Okay, and player field, it has one flag that marked this bomb, and everything except this cell just already opened. Okay, so our detect solved puzzle should return state true and flag counter 1, because right now we have only one flag and our puzzle is completely solved. Okay, let's run current file in watched mode and then just move to the detect solved puzzle just to make this test works fine. Yeah, so right now I have one failed test case. Okay, Of course, we can prepare actually mock test cases before we move to the solve puzzle, but I wanted to start from the easiest test case. Okay, but let's actually just be sure we add 2 more wrong test cases, yeah, and as you can see right now I have filled this one bomb absolutely the same as the previous one, but on the player field we have hidden a bunch of hidden cells, yeah, and of course we need to detect that right now our puzzle isn't solved. Okay, and as far as you can see, right now we have detect solved puzzle call, and then a solved flag of course should be false, and flag counter should be 0 because we have no any flag on the field. And for the second scenario we have absolutely the same game field, but on the player field we have 1 flag and 1 hidden cell. Of course, in this case puzzles shouldn't be solved, and flag counter should be increasing to 1. Okay, right now I have 2 broken test cases, yeah, where something went wrong, and 1 test case this completely solved puzzle. Okay, what should we do? Okay, first of all, let's make destructurization from the cell state: hidden, bomb, flag, and weak flag, because we need to detect all 4 these states. And also we need to make counters. I mean that we need to detect how many bombs on the field, how many flags on the field, how many bombs we've already detected, and how many hidden cells we have on the field. So on this 4 condition we can easily decide is our puzzle solved or not. So and right now I just iterate per game field keys and game field y keys. I just take coordinates y and x. And as you can see, the Typescript provide for us an error that we need to use compiler option done level iteration. Okay, let's switch on this option. We need to open tsconfig, and then we need to add 1 more option, down level iteration true. What does this option means? It means that when we just using this for off, we just use iterators instead of usual compilation to ECMAScript 5. And for more details we can open doc of the Typescript, and as you can see, ECMAScript 6 added several new iteration primitives for off loop, yeah, and without Typescript code it looks like this, yeah, and without down level iteration is just usual for loop, yeah, instead of for off, of course. And in case when we install this down level iteration, instead of usual for, it's just add information about iterators, and as far as you can see it's just compiled to the iterators. Okay, you can look through this explanation there is just a link to some additional information. Okay, from our perspective, of course, we just add this option and we can use it as usual for off construction. Okay, then we just take game cell and player cell. Yeah, so we just take by the coordinates game cell and then player cell that should match with particular game field cell. Okay, and next, when we detect hidden cell, like example, we should increase hidden cell item, yeah, because we just detect hidden cell, yeah, on the player cell. And then when we find flag or weak flag, we should increase flag counter, yeah. When we face with these states, we should increase flag counter. And I wanted to concentrate your focus to this string. We just create an array that fill with flag and weak flag items, and then we just check using includes player cell. Yeah, we just use this pattern to not to make flag equal player cell or or big flag equal player cell. Yeah, this construction is very useful when you make this kind of logical operators. Okay. And then we need to detect that if we have a bomb, yeah, we should increase bomb counter, yeah. And right now, when game cell is equal bombs, we should increase bomb counter. And last but not least, it's detected bomb counter, yeah. And if we just have player cell is equals to flag, we should increase detected bomb counter, yeah, and we need to make it let, yeah. So, and right now we have everything that we need, yeah. We just increase bomb counter, bombs counter, detected bombs counter, flag counter, and hidden cells. It need to be called counter, yeah. Hidden cells or hidden counter, yeah. Just make this consistent. Okay, let's right now make our logical assumptions. After these loops, we can make constant is puzzle solved, that need to check that we have no any hidden cells on the field, and hidden counter should be equal to 0. So next we should check that bombs counter is equal to detected bombs counter, yeah, because we should detect every bomb on the field, yeah. And both of these conditions should be satisfied, yeah. So, and there is our puzzle counter, and then we need to return how many flags on the field, and we need to return flag counter. Okay, looks like right now our test is immediately green, yeah, and right now our test cases has passed. Okay, let's move forward to our test cases and add several more scenarios. Okay, and I have added several more test cases, 5 by 5 with hidden cells, and as you can see there is a game field with 4 bombs on the field and a bunch of hidden cells in the player field. And when we counter flags, we have 3 flags on the field, and our puzzle, of course, it cannot be solved when we have hidden cells on the field. And for the 5 by 5 solved case, we have 4 flags on the field, as you can see, and this puzzle is completely solved, and a solved flag should be true. Okay, right now we have one more useful function, detect solved puzzles, that we can use in the open cells and open cell and set flag action. Okay, so probably there is a finish and we need to stop here. Okay, see you in the next video where we can implement this logic to our game. Okay, see you, bye. Hi, let's continue working with detect solved puzzle, and let's take a look to the game with hooks. And okay, not game with hooks, use game, of course. And there are 2 places where we have call of the previous player field and take and set up new player field. It's on click and on context menu handlers. When we click to the cell, we call open cell and then put here player field and game field, and then we just set new player field. So what should we change? And probably there is a good places to put this logic to detect solved puzzle. And let's take a look to the open cell action. When we call open cell, we return player field, but we can provide more information. We can return player field, and also before this action we can call detect solved puzzle. Okay, let's call detect solved puzzle, but previously we need to import this function. Import detect solved puzzle. And probably we need to rename this function, this file detect solved puzzle from the lowercase. Yeah, why we should use camel case. So let's just rename detect solved puzzle and detect solved puzzle test. And we need to import detect solved puzzle from the detect solved puzzle lowercase, and the same stuff for the open cell. Okay, right now we take detect solved puzzle. Okay, what is the problem? Import from, just one sec, detect solved puzzle. Okay, so then we need to call here detect solved puzzle and provide their player field and game field. Okay, first of all player field and then just game field. Okay, then we need to create several const. Yeah, is it solved puzzle and also flag counter. Yeah, and then we can return not only player field, we can return is this puzzle solved or not, and also flag counter. Okay, and we can check our open cell test, and actually we need to change these kind of test cases, yeah, because right now we want to return only player field. It can be it should be player field and additional information. Okay, and just not to make this kind of changes very painful, I just wanted to add this information to the end of the returning declaration. Yeah, and first of all we need to return player fields, then this both items is solved and flag counter. Okay, and what should we return? Field, then just boolean and number. Yeah, so right now it's just a tuple of data. Yeah, field, boolean and number. Okay, and we need to change test cases, of course. And even more, when we call this open cell, we should use destructurization. Yeah, player field. Yeah, and then just take information about player field as first item. Okay, then we need to refactor this open cell test cases. It can be very easy. Yeah, we just take this declaration player field and just wrap it as with squared brackets. Yeah. Okay. Okay, and let's call right now our test case just to be sure that everything works as we expected. Okay, all test cases has passed. Everything looks fine. Probably we can add one more test case just to detect is solved and flag counter works as we expected. Okay, and as base we can take this test case information from the text solved puzzle test. Okay, and let's call it by the same way, 5x5 solved case. Okay, let's just take this test case and then replace stuff that we need. Okay, we need to use open cell, yeah, instead of this detect solved puzzle. Okay, and what should we open? Yeah, actually we need to add several more test test const. Okay, and right now we need to add flag. Let's copy and paste flag destructurization here, and then we need to add information about field. Yeah, but actually we can skip it and just use it without any kind of type declaration. Okay, let's right now change it a little bit. And okay, it's not assignable to type field. Okay, right now I have little problems. Let's just move this player field, and okay, it should be first parameter player field and game field as second parameter. Okay, and then just drop this information. Yeah, so what should we take? We should take
actually is solved, and flag counter, because we don't need this first information about player field. It's just redundant stuff for our test case where we want to detect just a win state. Okay, and what do we have? We have this bunch of data, and actually we can put some kind of hidden cell, like example right over here. I can put hidden cell, and then I should click to this hidden cell, and there should be coordinate 0 from the Y perspective, and no, actually from the Y perspective it should be 4. Yeah, and for the X it should be 0. Yeah, it should be 0, 1, 2, 3, 4, and 0 from the X perspective it should be this hidden cell. Okay, and then is solved flag should be true, and flag counter should set up to the 4. Okay, probably we can take this information about player field and then just make it as we expected. Yeah, let's call expect, then provide here player field, and then to strict equal, and instead this array we should replace this one cell. Yeah, it should be 2 right here. Yeah, and for any other cells it should be absolutely the same. Okay, let's run this current file in watch mode, because I have some feelings that we have some problems here. Okay, and let's wait until our test cases will be done. Okay, and right now our test case has passed, everything works fine. Yeah, and we have yeah, everything looks cool. Yeah, and we have this kind of functionality into the open cell. And what should we do next? We should make the same stuff in the set flag. Yeah, we should work with set flag and change it according with our current spec. So we import detect solved puzzle, and then we take information about is solved or not from the detect solved puzzle and flag counter. Then we should change this tuple. Yeah, it should be field, then boolean, and then number. Yeah. So next we should return this kind of stuff. Yeah, field, boolean, and then number. Okay, everything looks fine for me. Let's move to the test cases, and we need to change it as in the previous example. We should add this destructurization per every call of set flag. Yeah, so I can continue to make it without the video probably. Okay, and after refactoring, everything works as we expected. And what should we do next? We need to add one more scenario where we set this flag. Yeah, and it's kind of latest action that lead us to win. And I'm just copy this test case from the open cell and paste it right over here. Okay, and then what should we do? We should call set flag, and by absolutely the same way we should take probably information to the player cell about hidden cell. Okay, every other cell should be opened, and then we should click to the cell by the coordinate 1, 0. Yeah, because it's just 0, then 1, and it's hidden cell. We should click to this cell and set up flag on this particular cell. So, and flag counter should be equal 4 after this action.
puzzle is solved should be true, and player field should be the same as in previous variant. Yeah, so and our test case has passed, everything works as we expected, and looks like we've done it. We've done 2 more action in the set flag and open cell. Right now, last but not least, we should handle it into the use game hook. Right now we have this player field, yeah, and we need to destructure it into the our code, and for the new player field the same behavior, and we need to open 2 more stuff. Okay, we destruct information about is solved puzzle or not in flag counter, and then when our puzzle have been solved, we should check this flag and then set is win to the true, yeah, or set is win is solved, yeah, and then we should change this is game over behavior, set is game over, yeah, to the same logic. Okay, and for the context menu handler, it should be the same stuff. We should check is solved, and when is solved we should set as win, and probably we need to put here true, yeah, because it's just a little bit more easy to read. Okay, and right now everything should work as we expected, and we can check this behavior into the browser. Okay, and right now I've made this kind of cheat, yeah, and I can easily to use this information, yeah, about game field, and then just detect our puzzle is solved or not, yeah, and right now it's just very easy to solve this puzzle, yeah. Here we have bomb, okay, and for any other looks like 7 is it has bomb. Okay, just 1 sec, I need to solve it. Okay, and right now I need to put 1 more flag to detect this solvable puzzle. Okay, everything works as we expected. Right now we have 1 more final state. Yeah, our game is fully functional. We have this final state that we can detect. Okay, and probably right now I want to stop and see you in the next video. Bye. Hi, and today I wanted to make test cases for the win game state. Okay, and what should we put for the win game state? We need to add 1 more test case when player just win the game, not lose, just win, yeah? So let's add 1 more test case. So, and what should we do during this test case? And we can copy these strings from the previous one, and we need to take game field on click and on context menu, and then we should iterate per every item onto the game field, and then just detect is it bomb or not. In case when it's bomb, we should mark it by flag using context menu. When it's not a bomb, we should open the cell. Okay, and there we go. Right now we have this code that just iterate per every item onto the game field, and we take our game cell. So we need to take probably act from here and put there something like either game cell equal to bomb, or probably when it's not equal to bomb or equal to bomb, yeah, when it's equal to bomb we should mark it by the flag using context menu, yeah, and put here something like y-x coordinate. And in case when we have not a bomb, we should click
here using on click. Yeah, so and right now there is our test case. Yeah, we just mark every item that consists of bomb, yeah, cell that have a bomb as a children item, and we should put flag in this cell, and in case when it's not a bomb we should click onto this cell. And after our loops we can check our game status. And for these purposes we take these flags from the result current is game over and is win, and then just we expect that we should switch this flag is win to status true and is game over to status true, because we just solve our puzzle. Right now our use game test.test, it use mock, yeah, instead of real game field we have mock, but with this kind of logic we can actually solve a real one, because we just iterate per game field and then just apply this logic. So we can move this test to use game check game field where we have no any mock data, yeah, but it doesn't matter at all, yeah. In case when it works fine on the mock, it should works on the real one. Okay, and right now our test cases, it has green lights, yeah, green lights is good, and we can move to the use game and probably refactor it a little bit, because right now we just detect this flag is solved and then run these kind of strings, and probably it looks absolutely the same for the on click and for the on context menu. And just not to repeat ourselves, we can make function set game over, and here we have flag is solved. By default it's false, and we when we set game over we just set immediately is game over to true, and then set is win status depend on this flag. Okay, let's run this logic, and we should set game over based on our flags is game over, and the same logic right over here, yeah. And instead of as you can see, here we have game when we click to the bomb open cell raise throw an error, and we catch it, and then we should set up is game over to true, but we can make the same call set game over, and we can provide here false, yeah, and it means that we just when we catch an error we should rerun our test case. And right now probably we have one more problem, yeah. Player wins the game, and actually we detect false, yeah. Okay, it's something unexpected for me. Okay, probably I see an error, yeah. Here we have set game over and we provide is game over, yeah. So, and we should provide flag is solved. Okay, and right now everything works fine. Okay, and looks like we've done it. We've done our logic, yeah, for the game win state. Let's check it into the browser. And right now we have these kind of cheat codes, yeah, and there is a state for our field, and we can immediately detect where is bomb hiding, yeah, and there is a bomb. Yes, it's it has index 7, okay, and we can open everything except this cell. Okay, for the next string we have a bomb on the index 6, and then it should know any bombs. Okay, and for the third one we have no any bombs at all. Okay, and then we have bomb on the coordinate 4, it's somewhere here, and then oh yeah, I lose. Okay, let's solve this kind of puzzle. And when I regenerate our field, as you can see, yeah, we have no any additional hints. Let's fix it.
because right now we have useMemma, and for the array of dependencies have no any dependencies. It means we just generate this code. Yeah, we just call this function only one time, and we can provide here game field as array of dependencies, and when game field is changed, we should regenerate it and then just print on the console this game field information. Okay, let's regenerate it, and as you can see right now, per every generation have new game field. Yeah, okay, and right now I wanted to solve it. Okay, and the last one I have one bomb with index 2 and then have no any bombs at all. Okay, and right now it looks like we've done it. We've solved our puzzle, and right now I can regenerate it, and as far as you can see right now we regenerate our game field, and then we have the same hints, yeah, just to cheat with this kind of game. Okay, looks like we've done most of our logic, and right now we have two more stuff. We have no anything at all for the timer and for the this kind of counter, how many bombs we haven't marked as bomb yeah, on the field. So, and right now we can concentrate on these last two features. Okay, and see you in the next video when we just develop this stuff. Okay, see you. Bye.
Hi, let's consider one more click counter example. And when I click to the increase button, you can see that counter in the title right now increasing synchronously with counter in the document. And when I click decrease, the same behavior. And when I click to the document in any place, you could see that click event happen. Yeah? Increase, decrease, everything works as we expected, and click event right now we can detect it on the console panel. Okay, let's see to the functionality of this component, and to make this work as we expected, we have use effect hook. This hook, it made to make side effects functionality. Like example, right now we put to the document title new value per every render loop. Use effect, it's just a kind of hook that could work when we have render or re-render behavior into the browser side. And what do we have in the use effect as a functionality? First one, it's first parameter, it's a function that works in case when we have render or re-render of our component. And this function make our side effects, like example, change document title or add event listener click to some, like example, in the document, the same behavior. Yeah, in the document we make it, we just add event listener click and put here a callback for this event. And we return new function that works as when we unmount our component. When our component just unmount, we call this function clear, and we could just clear side effects that we don't want to have after unmounting this component. And this array. This array consists of dependencies. When something in this array changed, we just immediately run this function callback in the use effect. It means that we use a shallow equal algorithm when we re-render our component. We compare every item in this array in case when we detect some, when React, of course, not we, React detects some changes, we just rerun this function and rerun our action on render. Or we could put here just an empty array. It means we should run this only one time. And in case when I put empty array, as you can see, I can put here any click and stuff like this, and I have nothing in my title. Yeah, only first mount change this digit, yeah, and change title and put here counter 0, and any other re-render action just have nothing to add to this title. Okay. Let's cover this functionality by test cases. Yeah, and one more feature for this array, in case when we have no any array to the use effect, it means that per every render, anyway, we should rerun this hook. Yeah, in case when we call render, we call this hook immediately. Yeah, so three possible options. One, it's array of dependencies. Second one, it's empty array. It means that we should have only one call of this function in use effect, and no any array. It means that we should call it per every render. Okay, and let's move to the test cases, and we have one more test case. Yeah, should update when increment or decrement, update title when increment or decrement button clicked. Okay, and we create mock handler. We put it as a, we create, of course, mock function using Jest function, and then put it as prop to the click counter. Yeah, and we destructuring unmount methods from the render. It means when we call this method, we just unmount our component. Okay, then we find two button increase and decrease, and we have in line 40 just check that our document title to equal counter 0 by default. So then we click to the increase button, and we detect that our counter should change to 1, and our mock handler to have been called one time. So then second click, and our counter should change to 2 into the title, and our mock function should call 2 times, should have been called 2 times. So then we click to the decrease button, and we detect that our counter decreasing, and it should be third call our mock handler, because we detect every click per document. Yeah, and as far as you remember, we just add event listener to the document, and every click to the document area should detected by this callback document click handler. Okay, then we just make fire event and click to the document and detect that our mock handler increasing to 4. Then we unmount our component and click to the document second time, and we have no any increasing calls for mock handler. Okay, it was API for the use effect, yeah, and we're gonna to work with use effect during next coding sessions. Okay, see you in the next video. Bye.
Hi, and today I want to develop timer functionality. How it should works. When we click to some cell, okay, but not bomb cell, this timer should start, and even when we press probably flag, timer should start increasing, and when we finish to solve our puzzle, timer should stop, and then when we press the reset button, we should reset timer. Okay, let's make this part of functionality. And what pattern should we use to make this timer works as we expected? Into the React we have use effect, and use effect, it's one of the most significant part of the hook functionality. When we have something that consists of side effect, we could use hook use effect.
Let's call useEffect here and then provide a function that should run when useEffect has start. Okay, then it of course dependencies array, dependency list, where we should put everything that should trigger this useEffect. Yeah, it's kinda the same behavior as useMemo. Yeah, when we have this kind of dependencies. Okay, what should we put inside this useEffect? Because we have behavior based time, it should be some kind of interval, yeah, and we should call some kind of functionality from JavaScript, like example set interval, and we should increase this interval per every second. Okay, but what this interval should do? And we need to add one more state. It should be time, yeah, because we should trigger this set time per every second, increasing it. Okay, and per every sec we should call set time and then increase time by 1. Yeah. Okay, and useEffect, this function should return new function that should be called when we have unsubscribed action. When our component unmount, we should we should out our memory, yeah, because in case when we won't do it, our interval continues working, yeah, but we shouldn't have this kind of memory leaks into our program. Okay, and we should call clear interval and put here interval. This part of functionality that we need to have, yeah, we should clear interval when we unmount our component. In any other case, we continue working with this kind of function that continues to increase this variable set using set time, yeah. Okay, but we have no any conditions when we should start with this interval, and probably we need to add one more flag. Is game start or not? Because when player press onto the cell or set up a flag, we should trigger this flag is game start that trigger this timer. Let's make one more state. Is game start, and of course we need setter. Set is game start. Okay, when our game should start? When we click to the cell and when we put flag, and we put flag using this callback on context menu. For both of these callbacks we can put this condition for to the first line of this callback. When our game is not started, yeah, we just invert this condition. When this flag is false, it means that we should trigger our game timer and set is game started to true. It means that player has been starting to playing these games. Okay. So for the context menu, it's absolutely the same behavior. Okay, and right now we can, based on this flag, is game started, run our timer. If our game is started, we should run this timer. Okay, and one more point. When our game is over, we should clear interval 2, yeah, because when we lose or when we win, we wanted to fix our record, yeah, how many times have we spent this round. And when our game is over, we should clear interval just to freeze this value of time into the scoreboard counter. Okay, right now we need to fill
this array of dependencies, and we depend on is game over, is game started, and on the time. When we change any of these variable, it means that we should trigger our use effect again, okay, and check our values. So looks like we've done it, and let's cover our logic by test cases. But before let's finish, we need to add this value time, because we right now should return this value, because time is something that should be rendered into the game. So we return our time, and then we need to take this value and set up it into this scoreboard time value, and we should cast this data to the string instead of number, and then into the scoreboard we should have this timer. Okay. Right now I wanted to cover this logic by test cases, because without test cases I cannot be sure if it works or not before I move to the browser. So, and there is a bunch of test cases that I wanted to create. Timer should start by click to SL, timer should start by mark SL by flag, and timer should reset value on reset when on reset have been called. Okay, let's make first scenario. Okay, and in Jest we have used fake timers function that just mock our timers, and then we can increase or decrease our timers using special kind of functions. Okay, and then first of all let's render our hook. Okay, here we go. Right now we just wait until 5 seconds has passed, and we just trigger our timer 5 times in a row, using this loop. We call act and then trigger our timer. But in case when we haven't pressed anything, it means that we shouldn't move forward our timer. Okay, but in case when I click to some cell and then just trigger our timer the same number of times, then it should increase time to 5. So the same behavior should be for the setting a flag. Okay, here we go again. When we first attempt, right over here, when we trying to advance timer by time 1 second 5 times, that we shouldn't increase our timer. But when we press to the cell, using context menu handler, then we should increase our timer, and after 5 movement of timer we should increase our timer to 5, as far as I can see in line 241. Okay, and when we press to the reset button, our timer should reset with all game state. Okay, and here we go again. Right now I am just, as in previous cases, just render hook and then trying to spend some time after pressing some action onto the field, and then I detect that time must pass. Okay, and when I press reset, our timer should be resetted. But as far as I can see right now, we haven't this part of functionality, and we need to add it into the reset handler. Okay, here we go. I've just added set as game started false and set time 0 when I call reset handler. Okay, and right now I see the green lights. Green lights is good for us, and looks like we've done it. We can test it into the browser right now. Okay, and when I press to some cell, as you can see, our timer start increasing, and then when I lose, our timer just freeze. When I reset, press the reset button, then timer just reset with whole game state. And when I click to the user interface, yeah, into the cells on the field, our timer start increasing. Even if I put the flag, our timer just immediately start to increase. Okay, and using reset button, everything resetted to the default state. Okay, looks like we've done it, and its latest part of our functionality is this counter, yeah, how many bombs on the field right now, that we're gonna to make on the next lesson. Okay, see you in the next video. Bye. Hi, and today let's develop our bomb counter, and also we need to restrict how many flags can you put into the game field. In case when we put more flags than bomb on the game, we should restrict this behavior. We should reject new flag on the field. Okay, so let's make it. And in the function setFlag, we have flag counter that we could use into the useGame hook. What should we do to make this kind of restriction? We could use our function setFlag, and then we need to change the signature of the function setFlag. We need to add 2 more parameters. Okay, and right now I have previous flag counter and bombs. How many bombs do we have on the field? Okay, and we can change the behavior when we trying to set up flag. And in case when our cell is hidden, we need to set up the flag. But before, we wanted to check that our flag counter no more than bombs on the field. Okay, and there is our condition. Previous flag counter should be less than bomb. In this case, we could set up flag to the player field. And the rest of the function, probably we shouldn't change anything. What about our test cases? And right now our test cases looks ugly. We just have changed our signature, and right now we need to add additional parameters. Okay, and there we go. Right now I've added, as far as you remember, into our setFlag function we have previous flag counter and bombs. And previous flag counter in first test case equals 0 and bomb counter equals 3. Yeah. So it means that we could set up flag easily, yeah. And for the first test case, we trying to set up flag to the cell that already opened. Okay, and for the second test case, same stuff. We haven't checked this behavior yet. And actually for the last test case that haven't checked this behavior, we just set up some kind of data that we actually don't check it in this test case. Okay, let's move forward to the fresh test cases. And there are a bunch of test cases that we need to have into our code. Restriction on 3x3 field. Let's start from the easiest one. Okay, and there is our game field, and it's just the simplest possible scenario with 2 bombs. And player field. Player just suggests that there are 2 bombs in the left top corner and on the bottom left corner. And we're trying to set flag to the coordinates 1, 1. But right now have restriction. We provide that right now have 2 flags and 2 bombs on the field. And it means we shouldn't have new flag, and new player field should be absolutely the same as the previous one. Okay, let's make second one. And second one, it's about switching flag from the hard to weak. Yeah, I mean hard, it's flag without opacity. And we have two flags, and then we trying to set flag to the coordinate 0, 0. It's right over here, left top corner. And then we just check that we have weak flag after this manipulation. Okay, and then we could check that we can't add new flag even if flags are weak. Okay, and we have game field as in the previous example and two weak flags. And then we're trying to set up by the coordinates 1, 1 new flag. It means that we wanted to set up flag in the center of the field. And in this case we provide two flags and two bombs. It means that we shouldn't change anything on our player field, and as far as I can see it's absolutely the same player field as before. And we can't set new flag after we can't set the new flag after drop previous, and it's absolutely the same game field and player field with two flags. Then we trying to set flag to the coordinate 0, 0. It means we switch our flag to the weak state. Then we trying to set the flag second time to the coordinate 0, 0. And then we check that our new player field should have only one flag. Is solved should be false, and flag counter it could have one, yeah. So and then we're trying to set flag second time and provide information about player field, game field from the previous example, and then by the coordinate 0, 0 we're trying to set new flag. And as far as you can see into the expect section right now, we check that our puzzle is solved false, flag counter equals 2, and new player field consists of two flags and bunch of hidden cells. Okay, and probably we could make our test cases little bit more clever way. We can use only one variable instead three destructured variables. Okay, and instead of destructuring and expect assertion per every variable, I just using toString equal, just provide data from this array. Okay, and right now I have green lights and our test cases has passed, everything works fine. Let's switch to the use game. And right now our set flag, it requires that we need to add additional parameters. And we could start from the adding new state flag counter that we're going to use for the set flag function call. Okay, then we should provide this information to the set flag. It's flag counter, and then it should be bombs. And our flag counter, as you can see here right now I have much, flag counter and flag counter here. I can call it new flag counter. And then we call function set flag counter and provide here new flag counter. Okay, and it means per every call of the callback on context menu, we set up new flag counter, and then we need to return it, because right now we have nothing in type signature about flag counter. Let's add this information. Flag counter is just a number, and then return it. Okay. Everything looks cool. Let's move forward, but probably we need to add one or two test cases that gonna check this behavior. Okay, and when we render our hook and then call context menu by some random coordinates, our flag counter should increase. And then second test case. There are two loops and first loop it's y coordinate and second loop it's x coordinate, and we iterate for y coordinates to 3 and for the x coordinate to 4, and 3 times 4 it equals 20, and then into the act we provide information about y and x coordinate. And even if we set up more flags than bombs, it should be just 10, because by default we render beginner level, and for the beginner level we have 10 bombs on the field, and it shouldn't be more than 10 flags on the field, even if we're trying to set up something new. Okay, and probably it looks good for me. We can move to the game with hooks, and right now have flag counter as additional parameter, and we need to add, okay, I just closed Jest. We need to add this logic to the bombs, and we need to calculate it as bombs minus flag counter, because we're just trying to detect new bombs, and in case when we put flags we should calculate it by this simple formula, bombs minus flag counter. Okay, let's run our test environment and check that everything works as we expected. Okay, and there we go. Right now I need to start, yeah, and I put 1 flag, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we should prevent additional flags, yeah. So let's try to make weak flag, and then click somewhere. Nothing happens. Okay, everything works fine. Then just drop 1 flag and put new one. Okay, drop second one and put new one. Probably it works fine, yeah, and our flag counter works as we expected, yeah. When we drop some flag, then we increasing this number. When we add flag, we decreasing this number, yeah. And right now this logic works fine. Let's test, yeah, when we drop all flags. Okay, everything looks good for me, and probably we reach our purpose. And okay, see you in the next video. Bye.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Let's make refactoring session for today, and we have in the package JSON script test mutate. Using this script we run Stryker and create a report. Let's run test mutate and then wait until our test cases generates and then has passed. Okay, and Stryker done in 2 minutes and 8 seconds, and I can open report right now in the browser. Okay, and let's analyze it. Let's move to the helpers and detect solved puzzle. Right now I have mutation score, it's not so high. Let's open, and we can see that right now we detect player cell. If player cell equals hidden, then we increase hidden counter. Okay, looks cool, and we detect that our puzzle solved in case when hidden counter equals 0. So it means probably that hidden counter is just boolean flag, yeah. In case when we have only one hidden cell, then our hidden counter won't be 0 anymore, and we don't need to increase our hidden counter, yeah. So we can easily change hidden counter to boolean variable. And let's analyze one more condition. Right now, when Stryker push here false, and even more when Stryker just drop this block, we have no any problems. Yeah, it's really a great catch from the Stryker side. And when we just push here true, no any problem. And probably this block could influence to this part of this condition is puzzle solved when bomb counter equals detected bomb counter. Yeah, and when we change this flag to true, it means that we have no any test case with the opposite value. Yeah, when our bombs counter is not equal to the detected bomb counts. Let's move to our test cases and trying to solve these problems. First of all, let's change this simple case. Our hidden counter should be just boolean variable. Okay, and I've already dropped this variable counter, hidden cells counter, and I've made this field have hidden cells. And when player cell is equal hidden, we just immediately push here true. Yeah, this field have hidden cells, and then our field shouldn't have any hidden cells, because our puzzle solved only in case when our user open or mark as a flag all hidden cells. Okay, and next one, it should be something that we can fix in the test cases. Okay, and let's read this block of code. When our game cell is equals bomb, we increase bombs counter. And when player cell is equals flag, it means that we detect our bomb. Yeah, we mark it as a flag. And probably not only by the flag, it should include weak flag, as this condition above. Let's make variable that our player cell is flag. So, and then we have this flag, and when is player cell flag, we just increase flag counter, and then we detect here, is it flag or not, and then we detect bomb counter, because detected bombs counter, it means that we detect our current bomb. It should mark as a flag. And when game cell equals bomb and is player flag cell flag, we should increase this kind of flag. Okay, and then this condition, okay, and probably it looks a little bit more better. When our bombs counter is equal detected bombs counter, we detect every bomb on the field, and flag counter is the same as the bomb counter. It means that we put so many flags as on the field, and our field have no any hidden cell. It means we solve our puzzle. We detect all bombs and we have no any hidden cells. So then we return is puzzle solved flag and flag counter. How many flags on the field. This is the most significant stuff that detect solved puzzle should do. Okay, let's right now move to the test cases. Okay, and right now I have simple 3x3 case when we just have a game field and player field, and everything should works fine. We should solve our puzzle in this case, because flag is mark our on the bomb cell, and we have no any hidden cells. Okay, then wrong 3x3 hidden cells. We have hidden cells on the player field, and it means that our puzzle is not solved. Then wrong 3x3 hidden cell case. We mark our bomb by the flag, and we still have hidden cells. Okay, and probably we can add one more test case when we have game field and player field absolutely the same as a game field. It's absolutely cannot be realizable from the UI side, but for the test case it could be very useful, because right now we have no any flags, and it means that we won't go here. Yeah, if our game cell is equal bombs, we increase bomb counter, but our player cell flag, yeah, in this case won't be incremented. Yeah, and it means that we should have false scenario without any flags on the field. Okay, and one more very useful synthetic test case when we have wrong flag on the 3x3 case. Right now our game field is absolutely the same as in previous example. And our player field is a field where we have bomb cell as open cell. Okay, it's not possible from the UI side, but we can say that it's absolutely possible for our test case. And we have flag but on the wrong place. Yeah, and right now I have flag counter equals 1. It's absolutely the same as a bomb counter. Yeah, and it means that when we compare our flag counter and bomb counter, it should match, but in case when we're trying to check is solved, it should be false because our bomb counter is not equal detected bomb counter. Yeah, because when we go to this condition, then our second scenario detected bomb counter won't be incremented. Yeah, because right now I have flag on the wrong place and this flag should be false, so it means that our is puzzle solved should be false and our test case has passed. Okay, let's run our test case and see what result it will be. Okay, everything works fine. We have 7 test cases that has passed. Let's run our report again. Okay, and we have done our reports. Let's check to the browser, and it looks like we've done it. Yeah, we cover our all our test cases. Yeah, and everything looks cool. Right now we have no any kind of mutants in our code. Let's move to the next file and open cell. It looks much more better than our previous example, and still we have this parameter game cell not equals bomb. In case when we mutate it as true, always everything has passed. Yeah, and there is a bunch of timeouts. So let's check how we use open cell, and we call open cell in the hook use game, and right now I have a flag counter here, and it's absolutely redundant parameter. Yeah, we have no any functionality based on this flag. Okay, and probably we can drop it from the type signature and then change our test cases to make this works fine. Okay, and let's change this behavior a little bit. When we have game cell equals bomb, then we throw new error that game over. Okay, and one more scenario. When our player cell is equal flag, we shouldn't open any cell. Yeah, it just should return the same field. I mean, in case when our player cell is equals flag, we should return our current player cell, and of course in case when we return the same player field, we shouldn't have any solution and our current click. It's just action that we could skip. Okay, so let's move forward. And next step, when it's not a bomb and when it's not a flag, it means that we should immediately push to the player field our game cell, and we can easily drop it from here. Yeah, because we could push to the player field game cell after both these checks, and then this condition, yeah, game cell is equals empty. When our game cell is empty, it means we could run our recursive way of computing this kind of empty area on the field. Okay, and we can add one more condition. When our player cell is hidden or weak flag, it means that we should run this algorithm. In any other scenario, we shouldn't make it, because when we have open cell with digits, okay, we won't be proceed, yeah, and we need to detect that our player cell in the current step is hidden or weak flag. Okay, and probably we need to move forward. Then we on the line 41 we check that our player cell is hidden, that we checked before, hidden or weak flag, and game cell is not a bomb, and then we should run this algorithm by the recursive mode. Okay, but probably we've checked it before, yeah, in case when we have bomb we just stop, yeah, we won't proceed, yeah, we proceed only in case when game cell is empty and hidden or weak flag, yeah, it's current player cell. So we previously checked it, and we should just drop these conditions, and player field on the current state is equal game cell, yeah, we've done it before. Okay, and looks like we've done it, yeah, we just re-optimized our algorithm and make it a little bit more straightforward. Let's check it, and for these purposes we need just run current test cases. Let's run open cell test. As you can see, our test cases has passed, and we need to run Stryker report. Okay, but I've forgotten about test cases, yeah, and right now we need to add 2 more test cases. When we open cell with the flag, it shouldn't open, yeah, and as you can see, we have player field with flag, player field with the flag, and game field, and then I'm trying to click to the cell 1-1, yeah, it's right over here, and we shouldn't change our player field, and our puzzle of course shouldn't be solved. And when we open cell with the weak flag, it should open, yeah, and in case when we click to this cell with the coordinate 1-1 that mark as weak flag, we should open 1 under this cell. So, and then we can run Stryker. Okay, and right now everything looks fine except this scenario when we just put here or, so then we just have timeout, yeah, but it looks like everything works fine, yeah, and timeout, it's expectable behavior in case when we have or in this place. Okay, and what we need to fix except these scenarios? Okay, and in the models directory we have game with hooks, and here we have game with hooks, and then I can see that we have bombs, and there is a bomb counter, and then Stryker trying to mutate this value, and nothing has changed. Let's fix this situation, and it can be very easy. We need to make we just need to render our game with hooks and then take fragment. So we find on the screen by test ID 00 our field, and click by the second button on that cell. So we just put flag onto this cell and match snapshot. Yeah, it means that we just render our field by default and click by the context menu button, yeah, right mouse button, to the cell with coordinate 00 and detect that our fragment is the same as we expected, yeah. And then second time, but on the right bottom corner, yeah. And as default game with hooks render field 8 by 8, yeah, it's beginner field. So after next click, we detect that our digit should be 2, and we can see it onto the snapshot. So when we click to the field, okay, probably I'm not a big expert in the snapshot world, okay, but we can see it on our test case, yeah. When we are trying to set up several flags, it means that our test case just set up our bombs counter, yeah, by this way. Yeah, we just decrease number of the bombs, yeah, and we immediately can detect it in case when Stryker just trying to mutate this condition. Let's find a way to check it. We need to run Stryker, of course. Okay, everything looks cool. Right now we've detected this behavior, yeah, by the snapshot. So probably we need to move forward with next case, game with hooks, but we spent too much time onto this video. Okay, let's continue to the part 2 of this video where we can fix use game. Bye. Let's make refactoring, and our helpers directory is much more than I've expected, and I see that it's not helpers anymore, it's kind of core of our system. Let's rename it, and let's just rename helpers to core, and then we need to find pattern at helpers. So I believe that when we replace this pattern to core, everything should work fine. And let's replace it and then check it using test. Okay, we've run test cases. We've run test cases in watch mode, and during this refactoring session, it's going to observe our changes. Okay, everything looks fine. Let's move forward. And I see our root hooks and use mouse down. It's just a feature for components level. Okay, let's move hooks to the components. And then we can refactor it using pattern hooks. And we can easily replace it. Yeah, as you can see, we have two to import pass, and we can put here components hooks. Okay, then just replace it, and our test cases it just provide for us information about some potential problems, and we have one failed test case. Okay. Use mouse down test, no such file on directory. Let's check it. Use mouse down. What's the problem? src hooks. Okay, we just moved test case. Let's rerun test cases. Okay, everything looks fine. Cool. Right now we moved hooks, and we also rename helpers to core, and you can see how easy it was, yeah, because in case when we have aliases, it's just very easy to find some pattern and replace it, and it's just a friendly hint for you. Don't need to use imports by relative way, yes, to dot slash and move to some part of file system above, yeah, because in this case you hardly put some binding between your files and position in the file system for your imports. Okay, and the main part of our refactoring, I wanted to refactor this hook use game. Right now I have too many functionality in one place. Use game, it's kinda consists of timer and level and game status. Let's just split it, yeah, let's just split it to different parts. And first of all, I wanted to move use effect and time management to different hook. Okay, and we have time management into the use game. We have use state that manage our time. Yeah, it's state that based on time. And we have use effect that move time forward every second after our game is started. Yeah, so one more part of functionality. When we reset our game, we reset timer. Okay, let's describe something like this in the different hook use time, and that's just a basic template for use time. Okay, and probably our use time it should receive two flags: is game start and is game over, just to make this management by effective way. Okay, and instead set time we should have something like on reset. And on reset, just reset our state to default. So, and we need to return time and on reset, yeah, and here we have set time 0. Okay, looks like we've done basic part of functionality, and second part is use effect. Yeah, right now we have use effect that create this functionality for our time management. And let's make it. Let's just import use effect, and then probably everything that we need. We have is game started, is game over, and as array of dependencies we have is game over and is game started, and one more variable is time. Okay, and probably it's it's everything that we need in this hook. Let's just describe a type that our use time should return. Okay, looks like we've done it, and right now let's make test cases and use time test cases. I see that timer works fine when game is started, time stops when game is over, and we need to check timer full life cycle. Let's create our first test case. Timer works fine when game is started, and we need to call render hook and put here something like this: use time and first flag is game started true and is game over false. And it means when we move timer forward, our time should change. And let's make a helper function that going to move timers by time. We receive time that must pass, and then we call act and call here just advance timer by times. Then all our mocked timers move by 1 second, and we can call this function instead of this code per every test case. Okay, and here we go. We mock our timers, yeah, call just use fake timers. Then we render hook with parameters that we previously discussed. And I expect that when we move timer 5 times, yeah, and time has passed, it's just 5 sec, we move timer by 5 times. As far as you remember, we run this loop, and into this loop we call act and call just advance timers by time and move timers to 1 second forward, and we will make this 5 times. So then we expect that our result current, as far as I remember, we have array that consists of 2 items. First one is just time, and second one on reset function. So our first item that of course it has index 0 to be 5, yeah, because we expect that when we move timer by 5 sec it must be 5. Okay, let's run our test case. Okay, and it looks like we've done it. Right now our test case has passed. Okay, and let's move forward to the next test case. And next test case, timer stops when game is over. And when we render hook with 2 flag is game started true and is game over true, it means that our game is over, and we shouldn't proceed to move our time. And when we call move timers by time, then when we detect that our result current should be 0, yeah, we shouldn't move our timer when our game is over. Okay, and then timer full life cycle. Okay, and that's a very good example for a render hook. Right now we call use timers and wrap it by the function, and we have two parameters into this function that we provide as the next parameter for render hook. And there is just initial props that we provide here, and then a render hook put these props into this first parameter as callback parameters. Okay, and then when we render this hook, we move timers by 5 seconds, and we detect that our result in the time from our hook isn't changed. Why? Because we push here is game started false, is game over false. Our game is not started, yeah, isn't start. Okay, and right now when we call renderer and put here different parameters, is game started true and is game over false, and then move timer by time, we detect that our time moved forward as we expected. So when our game started and game over, then we shouldn't proceed to move forward. And right now we expect that our result current isn't changed. Yeah, we have the same 5 as it was on the previous step. And then we call our result current first parameter is just reset function that we're gonna to call. Okay, and after reset we should detect that our result should be 0. Yeah, so it's full timer full life cycle. Yeah, by default when our game is not started and is not over, we shouldn't move our timer. Yeah, when we put here game started, yeah, it's immediately provide for us information that our timer must go forward, and when we move our timer by 5 seconds we can detect it into the result. And when we reset our timer, everything should be set it up by default. Okay, so right now we have a full cycle for the use time, and let's make changes for use game. Yeah, because right now we can replace this logic from the use time. And we have use game test.ts. Let's run this test case into the watch mode, and then I import use time from the use time hook. Okay, we can replace time logic into this file and then track that our test cases is not broken. Let's replace use state here by use timer, yeah, and put to the use timer default parameters. Okay, and right now we call use time and distract from the use time and reset time. Okay, let's move it probably a little bit below, or okay, let's put it right over here. For the next step, we need to use drop use effect here, because it's not actually necessary. And then our reset time function, yeah, we need to call reset time instead of set time here. Yeah, reset time. Okay, and looks like we've done it. Right now we take some part of functionality and move it to the different hook, and then compose together one hook with the other. On the next video, I want to make this kind of logic with is game over, is win, and is game started, based on the some probably automate, yeah, with states of the game. Okay, see you in the next video. Bye. React Developer Tools. And React Developer Tools, it's a tool that allows us to inspect React 3. And React Developer Tools, it has Profiler tab where we can analyze information about rendering. You can install this add-on in the Firefox or for Chrome. You can easily find it per every browser. Okay, and let's analyze information from the React developer tools. And in the top components, we have full component 3, and we can see what component and what position on the page for this component. And also we have information about props, yeah, and who gonna to render, yeah, who is rendered it, and right now scoreboard rendered our select, yeah, and level and stuff like this. Okay, and very interesting information we can detect using Profiler. And Profiler, it's a tool that can analyze and aggregate information about rendering. Okay, let's run. Let's start profiling and then click to some cell and waiting probably 10 seconds. Okay, and right now I have 4, 5, 6, 7, 8, 9, okay, 10. Let's stop it and then analyze our report. Okay, first rendering, and we have cell component, and it's nothing. Yeah, it looks like we just re-render one cell, then we again re-render one cell, and looks like in this moment we click to the cell and then we re-render full components 3, yeah, and we just re-render top components. Yeah, why we re-render top components? Even in case when we have no any changes in the top components, we still re-render it. And next step, we re-render scoreboard. Yeah, okay, and what components we affected? And we render reset button. Why we render reset button? Yeah, it's just a static button. We have no any updates in the reset. Okay, and looks like per every render we have a lots of re-rendering. Yeah, redundant re-rendering. Like example top. Yeah, it's second re-rendering for the top. Yeah, and during this 10 sec we have no any real updates. Instead of yeah, only in the counter timer we have some updates, and we shouldn't re-render full page component set, yeah, per every click of our tick of our timer. Okay, let's move to the code and then we'll see what we can do with this. Okay, and game with hooks, it's a basic component that render whole application right now. And we have top component, yeah, and top, it consists of just bunch of static props, yeah, that no more than text. Okay, let's open top, and then we'll state that we just receive this data and then render it. What we can do to prevent redundant rendering, and in the React we have mema, yeah, let's just call mema, and we can wrap our component by mema, yeah, and then we have error, yeah, that we need to provide information about display name, and display name, it's a prop, yeah. Let's just set up it. Default display name like top, yeah, because display name, it's very convenient prop for debugger, yeah, and for the error in case when our component, like example, crash and we have some error on the console, we can detect what component, what component are we talking about, yeah. So, and our top component right now wrapped by mema, and mema, it's high order component that just wrap our component and return new component. Right now we have just functional component, yeah, and when we use React mema, it consists of several parameters, yeah. Let's see. Okay, and React mema, it's a high order component, yeah, and by default when we provide just information about a function, we have algorithm shallow equal, yeah, and we shallowly compare objects in the props object, yeah. And what does it mean? And it means that we're gonna to compare object in the top level, yeah, and it's kind of comparison that in case when we face in the props with the object or with the function, we're going to compare it there is an example with the function. We have function factory, and we call factory one time and just write it to the first variable function 1. And second function, it's kind of variable function 2. It's pointer to the second call of the factory. Yeah, and when we create construction like this, we call factory, and it returns for us a new function, yeah, per every call. It's just a unique pointer to some RAM, yeah, and RAM address, yeah. And right now, when we call function 1 with parameter 1, 2, and function 2 is parameter 1, 2, it should be absolutely the same result, because our function, it has the same action, yeah. But in case when you're trying to compare it, function 1 and function 2, we have false, yeah, because it's just different pointer, yeah. In JavaScript, when we're trying to compare an objects, yeah, it's just trying to compare pointers in the RAM address, yeah, and right now we have false in case when we're trying to compare this function. And in case when we compare function 1 and function 1, it's the same function, yeah, because it's the same pointer in the RAM, yeah, and right now we return true. And let's return to the top, and we have just single props, yeah, just scalar props. Children, it's just data, yeah, it's string. And we have legend props, it's just bunch of strings, and algorithm shallow equals. It's absolutely applicable for this case, yeah, and we can easily detect that everything should work as we expected. Let's move to the browser and let's debug again. We start profiling, then click to some cell and wait probably 10 sec. Yeah, again, okay, 5, 6, 7, 8, 9, 10. Stop profiling. And right now we have the same picture as before, and when we have this big re-rendering, our top did not render. Yeah, wow, cool, it looks like we've done it. Our top our top works fine, yeah, and we have no any re-rendering for the top. Yeah, it's very cool. Right now it's behavior that we really expect from this component. Hey, let's move to the different component, like example scoreboard, yeah, and probably we need to re-render only our counter, yeah, I mean only our timer, yeah, but we don't need to re-render, by example, our level drop down or our reset button. And right now we have re-rendering for the reset, yeah. Let's check what we can do with this. And our scoreboard, it's just a bunch of data, yeah, and right now we provide information about time, bombs, levels, and on change level callback. Let's move to this scoreboard and let's prevent re-rendering for the level, yeah, and because right now I don't want to re-rendering it shouldn't be any re-rendering, yeah, because we have no any real changes in the level. Okay, let's move to the level. And what do we have here? We have a bunch of data, yeah, and we can easily implement mema by the same way. Let's just call mema, and then we need to provide information about a default name. Yeah, it should be level. Okay. So what do we have right now? We have children, value is just a bunch of data, that value is just a string, and children, it's an array of string. Yeah, and it means that shallow compare works fine for these cases. Yeah, when we gonna to compare previous items from the array, it's just a scalar data. Yeah, everything should work as we expected. And what about on change? Yeah, and on change, it's something that we don't want it to affect, yeah, re-rendering behavior, yeah. And we have different options. How can we solve this problem? But before optimization, let's check, is it work for us or not? And let's clear data, yeah, and then let's start profiling again, and let's waiting probably 10 sec. 4, 5, 6, 7, 8, 9, 10. Cool. And let's analyze our report, and then I can see that we have no any rendering. Okay, so then where is our scoreboard? Okay, there is our scoreboard. Okay, and then okay, we have re-rendering for our yeah, on this stage we have re-rendering. Okay, it's not cool. Yeah, we still have re-rendering in the scoreboard in this frame. Yeah, and okay, on the next frame it looks like some problem in the template, but it's still some re-rendering. Yeah, you can see that our options re-rendering. Yeah, and it's a kind of behavior that we don't want to have in our application. Okay, and problem in the onChange function. Yeah, what we can do with the onChange. Right now scoreboard take information from the props and put it to the level, and scoreboard receive onChange level right over here. Yeah, it's just a function that we generate right over here in the prop. So what we can do with this function, and for these purposes we have use callback. And use callback, it's very useful function. Use callback, it has the same API as React, Mema or useEffect. We have first parameter and second parameter as array of dependencies. Yeah? And first parameter is just a function, yeah, that we want to call, and second parameter, it's a dependencies, yeah, where we need, when dependencies, it's just defined when we need to regenerate our function. Yeah, and use callback just memorize this function and return it to the variable that we can define. Yeah. And empty array, it means that we shouldn't re-render use callback. Yeah, it's just one generation. Yeah, because we have no any dependencies in the outer function. Yeah, from the scope of the outer function, we have just level, and that's all. We call onChange level function from the use game, and we shouldn't re-render our use callback function. Okay, then we can provide this onChange level handler to the onChange level, and probably it's our fix. Let's check it. Okay, and here we go. Right now I've already done our profiling, and what do we have? We have first rendering, okay, and then okay, our scoreboard. Let's focus on the scoreboard. We have level mema, yeah, and we haven't, yeah, it works fine. Yeah, it works cool. We have no any re-rendering for our level. Yeah, right now we have memoization and everything works as we expected. We have no any re-rendering. Okay, it was very cool. Yeah, we start to optimize our application. Okay, and see you in the next video. Let's analyze our report again, and right now we have behavior for the top that we really expected. Yeah, we have no any redundant re-rendering, and for the scoreboard it's not something that we expect. Reset re-rendering, even in case when we have no any real changes for the reset. Re-rendering for the counter, even in case when we have no any changes for the counter, but we've already fixed for the level. Yeah, and we have no any redundant re-rendering for the level. Okay, and I can see that we still have a lots of changes for the cell. Yeah, per every per every step we just re-rendering whole grid, even in case when we don't need to do this. Okay, let's try to fix it, and for these purposes I want to start from the game with hooks, and then we can see what happened on the scoreboard. Let's open scoreboard component, and then we have counter level that we've already optimized, and reset and counter for the bombs. Yeah, counter, time counter and bombs counter. Okay, let's open reset. And reset receive only one prop on reset, and based on mema, how the component we can optimize it. And as far as you remember, for the reset, we should provide display name, yeah, and it should be reset. And right now, on reset callback, it could generate per every iteration probably new function, yeah, because it's just a prop that we receive, and we provide this on reset callback from the scoreboard props. It's kind of drilling props, and then our scoreboard, yeah, right over here, just define this on reset callback and take it from the use game hook. And our use game, it has on reset right over here, and it's just a function, yeah, that we're gonna to generate per every call of use game, because it's just a const on reset, and here we have functional expression, so it means we create new function per every call of use game. So then it's a classical situation for the use callback. Let's take use callback from the React, and then wrap our own reset handler. And then we need to provide here a dependencies list. And our on reset function depend on reset handler and provide here a parameter size and bombs. So, and probably we need to provide here the same dependencies, size and bombs. Let's take a look what reset handler do. And we receive size and bombs. Then we call field generator and generate field with default state, and set new game field, set new player field, start new game. It calls start new game. It means that we just reset all our statuses for the game, and or all our flags is win and is game over and is game started should be false after this call, and set flag counter and reset time is just reset timer and reset flags on our field. Okay, so it means that we have no any dependencies except these two, because size and bombs we take it from the closure of this function, and we should regenerate our on reset callback only in case when we have changes in the size or bombs. Okay, and I believe that this fix should prevent this redundant behavior and redundant re-rendering from the scoreboard component. Let's move to the grid. And for the grid we have two props, on click and on context menu on the top level. Yeah. And if we open our grid, then our rest of parameters, here we have children, and then we just, as you can see right over here, yeah, we just per every children we just change data to the cell component. We generate a two-dimensional array of components with cells. And then we provide rest of the props that we receive. It's a on click and on context menu props to the cell. Yeah, so it's very very useful for us to make this function yeah, with memoization without any redundant recreation, because it's bunch of props that we depend on in the grid and in the cell in the end of the providing these props to the components. So let's take a look to the on click and to the on context menu. And for the on-click, let's find what do we have from the closures of this function, yeah, because right now parameters we can define it per every call of this function, yeah, and what do we have from the closures perspective? It's very useful for the use callback call, yeah, because in case when we have any changes from the outer scope of this function, we should recreate it, yeah. And first of all, I can see is game started, yeah. Is game started, it's a flag that we have from the use status call, yeah. It's outer scope of this function. And let's call use callback, yeah. And then we just put here a bunch of props that we depend on, yeah. And I believe that is game started, it's the first one that we should provide here. Then we call open cell and put here player field and game field. And player field and game field, it's of course outer scope of the function on click. And can we use these parameters? And probably have better way, because right now player field and game field is just two-dimensional arrays, yeah. And we have a strict process for regeneration for this item, yeah. And we regenerate player field only in case when we call reset handler, and we call reset handler when we click on reset or when we change level, yeah, on the field. So when we call reset handler, we call field generator and generate field with default state. We generate new player field and new game field. And then we call set new game, reset time, and set flag counter. Set new game, as far as you remember, just resets 3 boolean flags: is win, is game started, and is game over. Reset game, reset time, just reset our timer to 0, and set flag counter, just reset flag to the 0. So even only for these cases, when we change these three, yeah, when we call these 3 functions, we regenerate player field and game field. And I believe when we provide here a bunch of these dependencies, everything should work as we expected, yeah. Is game started, when we change is game started, when we change is game over and is win, yeah. When we change level or when we change probably flag counter, it's not something very convenient for us, because flag counter could change when we put a flag to the field, and we really don't have any dependencies, or let me think. Or actually, yeah, when we put flag on the field, new flag on the field, it means that we should provide here a new player field, yeah. And in case when we have flag on the cell, we shouldn't open this cell. So it's very useful parameter for us, yeah, when we detect that our player field has been changed. Okay, so right now our on click, I believe that everything should work as we expected. And for the context menu, it's probably absolutely the same logic, yeah, because we depend on player field, game field, flag counter, bombs, and stuff like this. Okay, I believe that we can wrap it by the same use callback, and everything should work as we expected. Okay, and probably one more function on change level, and I want to wrap it by the use callback, and I don't want to regenerate this function when we run our hook, yeah, because on change level it has no any dependencies from the outer scope, yeah. We have call of set level, yeah, and provide here a new level based on the props based on the arguments of this function, yeah. And I don't want to regenerate this function when we we just have only one creation for the on change level callback, yeah. And for during programming execution, I don't want to regenerate this function again. So let's take a look to the grid again, and we have player field for this grid. Let's move deeply to the grid, and then we provide this rest of the props and cell to our cell component, and we have coordinates, yeah, y and x, yeah, that we provide here for our cell. Let's take a look to the cell component. Okay, and right now probably it's time to make custom are equal. Okay, and that's just a dummy function are equal. And then let's take mema and wrap our cell by the mema, yeah. And then let's provide here display name. So cell display name, okay, it's equal to cell. Okay, and then I want to provide here function are equal at the second parameter for mema. Then what we should do for this are equal, as you can see, I just return export this function are equal, and I can easily provide here a test cases for our are equal function. Let's make small refactoring. We have props per every test case, and it's absolutely the same props. Let's move it to the top level. Okay, and I move props to the top level, and export from the cell are equal function. Okay, let's right now create check are equal test cases. Okay, and I provide here previous props, yeah, in children equals 0, yeah, just an empty cell by default. And when we call previous props with the same previous props, yeah, just spread previous props to make unbinding from the previous object, it should be absolutely the same props. Okay, by default we have coordinates 1, 1. Then I generate a bunch of test cases with false coordinates to it, yeah, and right now I have coordinates 2, 1, 1, 2, 2, 2, 1, 0, yeah, and per every call it should be false, yeah, we have different coordinates. And last but not least, when I have different childrens, I have different props. In case when we have different on-click callbacks, it should be false. And when we have different on context menu props, it should be false. Okay, so let's move to the cell, and right now our equal should be realized based on these test cases. Let's run our test cases. Okay, here we go. Right now we have broken scenario when we're trying to compare coordinates. Let's create into the cell algorithm to compare coordinates. Okay, here we go. Right now we have our equal coordinates variable that based on previous prop coordinates filter, and then we compare step by step next prop coordinates index with current coordinate, yeah, in case when we have no any match per every item on this array including indexes, we have broken scenario, yeah, and our props previous props coordinates filter should return for us empty array, yeah. It means that we shouldn't have any mismatching per both of these arrays, and then we return our equal coordinates. And right now our test cases for coordinates works fine, but then we have problems with children. Okay, let's compare children. Okay, and when we compare our children, it should be the same children. And right now we have problem with on click. Let's fix it. Okay, and then we compare on click and compare on context menu between previous and next props. And right now our test cases has passed. Okay, and looks like we've done it. Right now our equal function should works fine. Okay, and let's check our report again. And looks like it's much more better right now. Let's analyze it. Okay, we have only several re-renderings for the cell, yeah, when we really opened some cells on the field and then we change player field. Okay, and then we have no any redundant re-rendering for the cell during our debug sessions. Yeah, so it's much more better than on the previous run and previous reports. Okay, for the scoreboard we probably have one strange re-rendering, yeah, when we re-render counter, yeah, but I really have no any repetition for this behavior. Yeah, probably with counter it's something strange, and we can analyze it a little bit more forward, yeah, because I have several behavior like this, but for the cell it's absolutely different behavior, yeah, and looks like we've done it. Okay, of course I find a problem because counter have no any call of memo. I believe that when we wrap our counter by memo, everything should works fine, yeah, and I can show you in the report. Okay, let's just write this session, and I click one time, then in 5 sec I click second time. Okay, let's run game again. Click one time, then second time, and then waiting until 10 sec has passed. Okay, let's analyze it. And right now we have lots of re-rendering when we click to the open cell function, yeah, when we're trying to open cell. Then we have no any yeah, and in the branch of scoreboard we have no any re-rendering. For the top we have no any re-rendering, yeah, and looks like on the next steps we have no any redundant re-rendering for the cell 2. Yeah, when we click second time and third time we have real re-rendering for the cell, but we still have no any re-rendering for the top and for the scoreboard. Okay, and looks like we've done it. Yeah, I have a good feeling about it. Yeah, we really optimize our application. Yeah, and only for the real changes we have re-rendering behavior. Yeah, and I'm proud of it, and see you in the next video. Bye.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
And disable mutants. Disable mutants is very useful API to disable some specific mutations. Like example, you can disable something that you really, I don't know, probably absolutely sure that you don't need to make these mutations. And from version 5.4, available since Stryker 5.4, it can possible to put Stryker disable comments, yeah, exclude the mutator in global file, and one more possibility, it's exclude some specific mutations per some specific line of code. And I want to use this approach, and let's take a look to our report. Okay, here we go. Right now I have in components, like example, use mouse down, and I've already done and add use callback that prevent recreation of this function set mouse down true, because I don't have any kind of variables from the closures. And right now Stryker trying to mutate this array of dependencies, and array declaration survived. Let's change this mutation. And we have Stryker version 5.4, and we can use this kind of notation. And we can put these comments, Stryker disable next line array declaration, and then we prevent this check from the Stryker side. Let's continue working with our report. And what do we have except this use mouse down? In the grid we have cell, and for the cell we have string literal mutation, yeah, and still I have no any point to mutate this kind of data. Let's disable it. Okay, and Stryker disable next line string literal right over here, just prevent this mutation for the key. Okay, let's continue. And what problem do we have except our grid? And in the cell like example we have this mutation display name, yeah, and I have no any point to just check it, and probably we can easily prevent this kind of mutation. Okay, here we go. And I want to continue to analyze our report. Let's move forward. Okay, grid, it's okay for the grid, and game 100%, use mouse down, scoreboard, okay, counter. The same stuff, it's just kind of display name. And let's check for the level. Okay, I see again display name, okay, and reset. Okay, display name. Looks like we can easily fix it in the scoreboard. And let's make disable string literal for the counter, for the level, and for the reset button. Okay, and here we go. Let's continue. And for the top, I have top, and there is an example again of display name. Let's fix it. Okay, and then let's continue to working with our report, components, and probably components. Okay, everything fine. Let's move to the core, and for the core field, and for the field I still have this mutation here and this mutation here. Let's prevent both of them, because as far as you remember, we have no any sense to make this mutation, because our algorithm works fine in case when we have less than or equal, or in this place we have no any yeah, real sense when we're trying to mutate to more than or equal, yeah, because in this case just from the probabilistic side it's absolutely the same stuff. Okay, and that's very easy to fix. Yeah, we just put here disable next line comment. Let's move forward. And okay, for the core everything looks cool. Let's move to the modulus, and for the modulus we have game with hooks. Okay, and there we go again, array declaration. And for the use game, we have the same array declaration for on change level and for on reset. Let's move to the code and fix it. Okay, and there we go. Right now I have this fix with disable next line array declaration, and use game we add two more comments. Let's regenerate report and we'll see the result. Okay, and it's very great result, yeah, and right now I have very high score, and we can skip something that we depend on as far as you remember. We yeah, it was very big misunderstanding how can we fix this, and what kind of test can we add for this particular case. For the key element, yeah, right now we can easily fix it, just disable specific rule for the Stryker. Okay, I believe that it's very great feature that we are gonna to use during our next coding sessions. Okay, and see you in the next video. Bye. Let's move forward, and in the modulus we have game with hooks, and use game. It has mutation score 85%, yeah, and it's something bad happened here, yeah, and right now we have no any coverage for the set game over function, yeah, where we should call this set game over, and we call it here, where we detect solved puzzle by the click behavior, and looks like we have no any coverage for this behavior when we open the last cell by the click event. We should detect some solved puzzle behavior, and right now we have no any check for this. Okay, and use mema, right now it looks like there is just a debug code. We just on the first render we put to the log game field. It's just a hint for us, and we can drop line 73 without any consequences. Okay, and set is game started true. Looks like when we reset our game we need to detect that our probably timer or something that depend on this flag works fine. So and last but not least, it's use effect behavior, and there is a bunch of behaviors that we haven't tested. It's like example is game over and clear interval, when we unmount our component. Okay, let's move to the code, and something that we can easily fix is just drop use mema. Okay, and then let's fix on click behavior. Okay, and as I have told, we have on click, and we need a test case when player win the game, in case when we just open our cell, and we have player win the game scenario, but we need to probably fix it, and let's put something like player win the game when with open player win a game when open the last cell, and right now we need to add this scenario, and probably when we detect bomb we should call context menu, and on the other scenario we should call on click. And it won't be work by this way, because we just set up flux, I mean of course ternary operator. We just set up flux and on click, but not some sequent mode. In case when game cell is bomb we open context menu, if in case when not we are trying to click the cell. And on this case we should first of all set all flux. Just use context menu for these purposes, and then when our game cell is not a bomb we should click to this cell, and it means first of all we set all flux that we need, and on the next step we just click to the hidden cells. And probably it will be work as we expected. And then we take is game over and is win from the result current, and is win should be true and is over should be true, because we solve our puzzle in case when we click to the last cell. And one more test case, we should first of all click to the game cell that not a bomb, and then set up flux to the cell that equals bomb. And it means in this case we first of all just click to the cell that not a bomb, and then set up flux to the any other, and then we detect our win state. Our flux is win should be true, our flux is game over should be true. Okay, and by default our function set game over, it receive is solved parameter, but by default is solved is equal false, and we shouldn't provide false here when we catch an error. Okay, let's check our testing report again. Okay, and our test score is much more better. Right now it's 92.98. Okay, and what we haven't covered yet, we should cover use effect, yeah, and probably we can make several test cases to make check on unmount, yeah, when we call this function, and clear interval by this condition. Okay, let's use Jest use fake timers. Okay, and when we click to the cell, it means we should activate game, yeah, and timer should start. Okay, and let's make a constant time must pass, and then call Jest advanced timers by time, yeah, and move timer 5 times, and it means after 5 second, yeah, because we move to the 5 second, our result current time should be 5, yeah, because as far as you remember, use effect just move our timer, yeah, and we have variable time, and every iteration we just increase time by 1, yeah, and it should be equals 5. So, and on the last stage, when we click to the bomb, we should just interrupt our game, and then our timer shouldn't move forward. Let's just try to move timer 5 times again, yeah, because we a constant time must pass equals 5. We move timer to the 5 second, and from the other side we can detect that our time is not working anymore, yeah, and our variable is not incremented, yeah. Okay, and there is a time variable that to be equal 5. Yeah, after first iteration our variable time equals 5, yeah, and on the second check our time should equals 5. It means that we just check behavior before we yeah, move to the game over state, and after it. Okay, let's run our Stryker and detect what score right now do we have. Okay, and it looks very cool, yeah. Right now our use effect have no any mutants. Okay, and what on the rest, yeah, and in the reset handler, when we set is game started to the false, we should check from the other side that our flag yeah, that our flag is game started, it has state false. So let's change our behavior in the use game hook. Is game started is just internal variables that we use in the use game, yeah, in case when we use call use effect and on click and on context menu. And for check we should return this flag is game started boolean, and then put it to the return section. Okay, and on reset game handler we need to add behavior for the context menu. Let's call act and put here call on context menu, and it doesn't matter where we put this flag, probably to the 8.8. And then we can check that is game started, and so flag counter is equals to something that we expect on the other side, yeah, and we expect then when we call reset is game started should be equals false, and flag counter still should be 0, yeah, after reset handler. Okay, let's run Stryker one more time and check that right now we have 100% scores here. Okay, and let's check our report, and right now as you can see we have 100% mutation score, and all files it's approximately 99% of mutation score. It's very good score, probably we cannot to make it higher. Okay, our refactoring session finished here. Okay, and see you in the next video. Bye. Let's make one more step for our refactoring, and we have these three flags: is game over, is win, and is game started. And probably all of this data just describe simple stuff. Yeah, we have some kind of finite state machine, because our game it has several steps. Game is new, yeah, it's just new game, then game in progress, and two possible end. It's lose or win. So let's make this final state machine in the separate hook. Okay, and here we go. Right now I have game statuses and possible options: new game, is in progress, win or lose. And right now we need to make this kind of options in the use status, and based on these possible statuses we need to calculate these three flags. Okay, let's make set game status function. We receive status, that one of possible game statuses, and then we can calculate what we should switch. Yeah. And like example, is game started? It's only when game in progress, yeah, and we can set is game started based on status equals in progress. When we in progress, it means that our game is started. So is win status. Is win or lose, we can based on the game status win or lose. Okay, and it means we can set up is win only when our status equals win. Okay, let's move forward, and last but not least, it's game over, and our game is over when we have statuses win or lose. And in case when our status is win or lose, that means we need to set up status is game over. Okay, and what should we return? And probably we should return is game over, is win, and is game started. And we can describe these flags in the return type, and then we need to return these three options. Okay, and here we go. Right now we have is game started, is win, and is game over, yeah, and return type that describe these possible options. And what should be except these three flags? We need to add togglers, yeah. We need to have an options how can we set up this status. Okay, here we go. Right now we have function set new game, set in progress, set game win, and set game lose. And it's just a function that return nothing, yeah. We just switch status, and that's all. Okay, let's describe in the return type these functions. Okay, here we go. Right now we have this bunch of functions in the return type, and we need to provide this information into return. Okay, and looks like we've done it. Right now I have hook use status. They're just finite state machine based on these game statuses, yeah, and we can switch our status using these functions, and then stat game status just describe every possible status, and then we return information from this hook. It means we can easily make test cases, and there are examples how can we describe these test cases. And check default state. It's quite simple. We need to render our hook, then take the result, and from the result we want to take current data, and then we compare our current data with data that we expect, yeah. Of course, I won't compare functions, yeah, because it doesn't make any sense, yeah. We need to compare just data and compare it with data that we're gonna to expect. Okay, and probably we always gonna to destructuring data from the result current. Let's make helper for this purpose. Okay, and it should be something like this. Let's make it step by step. Sometimes in the JavaScript world it could be very inconvenient for understanding for the first time, of course. And that's the long version of this function. We take result and destructuring data from the result and return this data. As far as you remember, we can destruct information from the function parameters, arguments. And we can destructuring this data from the function arguments and then return it. And in case when we have arrow and then we can put here the result without any return declaration, we need to just wrap it by our round brackets. And right now we have option how can we write this function with destructurization and returning data that we're gonna to expect. Okay, let's call get data from use status return and then take it from here and put the result current. And then we can detect that our test case works fine. Let's run it in watch mode. Looks like we've done it. Our test case has passed. Let's move forward. In case when we check set new game handler, we should of course detect data as in previous example. First of all, we render the same hook. Then from the result we call function set new game, and we can provide it as like this. Yeah, it's just a function that wrap result of the other function, but we can drop this unnecessary yeah, brackets and arrows, and right now have the same result. Yeah, we just call function, yeah, that provide for us set new game property. Okay, and then we expect that after we call this function set new game, our data result should be equal is game started false, is win false, is game over false. Yeah, probably it's something like this. It's completely similarly works as in a previous example. By default, use status return the same data. It's kinda reset. Yeah, new game. It's kinda reset from the previous run. And then when we call set in progress, we receive that is game started flag should be true, but our game is not win and is not over. Yeah. When we set up game win, it means that is win flag should be true, is game over should be true, and our game is not started. Yeah, it's not in a progress right now. Okay, then set game lose. We receive that is game over false and is win. Is game over true and is win false, because we have no any victory in this round. And then let's check full flow yeah, for the game. Okay, and there we go. Right now we set up in progress. By default we have just new game. Yeah. Then when we switch to in progress, is game started flag should be true. Then set game win. It means that is win should be true and is game over should be true, and is game started should be false. And set game lose. It means is game started false, is win false, and is game over true. And when we run new game, it's just default false flags for our use status hook. Okay, everything works as we expected. Let's import use status in the use game, and actually we can run our test cases. Yeah, for the use game, it's kinda it's immediately detect regression in case when we face with it. Yeah. So, and then let's refactor our use game. First of all, let's import use status. And then I want to replace this flags from the use status. Yeah, we have is game started, is win, and is game over. And then instead of set game over, we're gonna to call our function set new game, set in progress, and stuff like this. Okay, let's move forward. And then is game started. Yeah, when our game is started, it means that we need to call set in progress. Okay, in case when we have set game over, yeah, and in case when we solve our puzzle, it means win, and we should set up game win status. And when set game over, it means that we need to call set game lose. And the same stuff for the context menu. Set in progress. Then when we win our game, set game win. And for the reset handler, we should call set new game. Yeah. Okay, set new game. Okay, looks like we've done it, and right now our test cases has passed, and looks like everything works fine, yeah, as we expected. Okay, let's continue refactoring. Okay, and our level, yeah, it's last but not least step into our refactoring. Just calculate settings from the game settings, and when we change level, we just create new settings. Just take new settings from the game settings and call reset handler and provide here just a new settings. Okay. Let's make this logic in the different hook. Okay, here we go, our hook use settings. And we have one parameter default level that equals beginner by default. And then we have use state for the default level. And we take game settings based on this level and return settings. Size and bombs that we take from the game settings. Okay, or we can call it settings, yeah, and return just settings. And we return level, and we have function set level that receive level based on level names, and set new levels and return game settings based on this new level. Okay, looks like we've done it, and our test cases, yeah, we render hook, and by default we have game settings beginner, and our level should be equals beginner, and then when we set level, like example to intermediate, we call act, and then take new settings from the set level, call intermediate, and then our settings for the intermediate should be equals game settings intermediate. And of course our current settings and level should be matched with game settings intermediate, and our level should be equals intermediate. Okay, and then let's move to the use game, and let's run test cases for the use game. Okay. And instead this logic with game settings and use state here, I want to put use settings, and of course we need to import these settings. Import default from the use settings hook use settings. Okay, it looks like we've done it. We just put here only one line of code, and looks like our test cases has passed, yeah, because we call use settings, and we have function set level, and by absolutely the same logic we just set up here level, but we can take information about game settings from this level, yeah, and probably we don't need to call our settings. Okay, let's drop game settings from here, we don't need it anymore. Okay, and it looks like we've done it. We encapsulate the logic of the game settings in the hook use settings, yeah, and right now our hook use game just combined together logic of use settings, of use statuses, and use time. And
parts of functionality just split to different hooks, yeah, and then combined in this hook use game. Okay, looks like we've done it and our test cases has passed, and we continue work with refactoring and optimizations on the next video. Bye. Uniform Resource Identifier is a unique sequence of characters that identifies a logical or physical resource used by web technologies, and is the core part of our web applications. Let's take a look to the URL scheme a little bit more careful, and as you can see we have scheme, yeah, and it could be not only HTTP or HTTPS, it could build up mail to, news, telephone, telnet, URN, or FTP. It's kind of bunch of protocols that could be from the beginning of the URI. Okay, and then user info, probably some authorization or stuff like this. Then host, and host, it's kind of unique identifier for your project. Yeah, it could be like example google.com or stuff like this. Then port, when we resolve our host, we connect to the server to some specific port. It should be OS dependent stuff, yeah, like kind of namespace, yeah. What port should be open when we call this host, and then pass, or it could could call like route, yeah, route in your application. Then query, and a bunch of query parameters could identify some state. And then fragment, and fragment, it's end for our URI, and as you can see we can define by the fragment some specific item on the page, and right now I can click to the menu, like example conception, and you can see here fragment, yeah, or it can call anchor, yeah, anchor on some place on your web page. Okay, it's basic part of our URL. Let's take a look at an example, and you can see cats, yeah, a bunch of cats on my page. It's just the Google Images, and when I like example open some specific cat, then I can send this particular image to my friend, and he can see also the same picture, yeah, and I can copy this URI and paste it. And then I can open absolutely the same cat. Just one sec, let's open this one, then open a new tab, and you can see the same cat, yeah. It means we just can define, just save some state in the URI, and for these purposes we have query parameters. And URI is like core of our web page. In the URI we can save some state that we want to open, yeah, and probably share or save. So what will be interesting from our perspective, and we want in our application change URL and URI, and probably define some state, yeah. So, and for these purposes in the browser we have history API, and history API, it provides for us in a bunch of methods that could move us yeah, backward or forward in the stack of the history, yeah. And I can show you an example, yeah. Let's go forward in some place. Okay, let's open web extension history, and then let's call history, and then back. So when I yeah, call back, you can see that immediately I turn back to my previous page. Or I can call history forward, and then go forward to my history page. Yeah, okay, or back, yeah, without any problem. And when you click to this button, back and forward, it means you call under the hood of your browser just this kind of history API. Okay, and one more useful feature, yeah, when we have like example new state, we can call push state, yeah, and so very useful function, push state. Using push state, we can change URL without any URI, without any reloading. Yeah, and during our introduction, yeah, we can just it's actually the core of all existing routers, React routers, or for any other frameworks. We just push new state, and without any page reloading, we change our URI. Like example, let's push some state, and probably something yeah, like this, some root, yeah. So, and then you can see that we change our URI without any reloading, yeah. And as you can see right now, we have just new state in the stack without page reloading. Also, we have replace state. We can replace state, and it means we won't go back, yeah, in our stack of the history. So one more problem with this stuff: we cannot subscribe to these methods, I mean push state or replace state. We have window on pop state, and when we call like example back or forward, we can easily detect using this subscription, yeah. Let's just move to the solution, yeah, because right now we cannot subscribe to the push state action, yeah. We can subscribe only when we change, yeah, in, I don't know, change something using back or forward, yeah, when we really change the location, yeah, by the different way. I can show you an example, and right now I put into my browser this subscription on pop state, and then call history back, and as you can see, I have alert that we just have new location, yeah. And when I call forward, like example, this subscription immediately call. But in case when I push just new state, yeah, let's just push new state. So I have changes in my URI, but I have no any yeah, on pop state callback on the screen, yeah. So it means that we cannot subscribe directly using history API, this kind of behavior. Okay, and we have one more useful library history. And this library can listen changes, and it has absolutely the same backward compatibility API as HTML5 history API. Yeah, we have push, replace, back, forward, and stuff like this. Okay, and library history, it's a base for every brand new router. Right now we have lots of routers, yeah, but during these coding sessions we're gonna work with React router. Okay, and I can show you an example, very simple example, how can we make a router. And right now on the page we have a list with links, with bunch of links. Link 1, deep link 2, links 3, 4, 5, yeah, and header ID counter and input type text. Let's take a look how yeah, how it works. It works fine, and we can see this template. Let's open it in the new screen. Okay, and I can show you an example. When I click to the link, yeah, we change these links, yeah, I mean URI immediately change without any page reloading. And from the JavaScript side, we just detect and just listen every click event on the page, yeah, and we just put document body element listener click, and then in case when our target is not a link, element A, we just return. And for any other way, it means that we have link, we just prevent default behavior, and then we take attribute from this link, href, and we have this URI that we can push using history push state, and it means we prevent default behavior for any links on the page, and then using history push state just work fine with our links. Okay, and you can see right now that we just change URI without any push page reloading. Okay, so I believe that on this stage we have enough theory about URI and about router and browser router base. So on the next video we're gonna to make it using React router. Okay, see you. And before we move forward with React router, I want to introduce you a bunch of changes. And I've add pages, and inside pages we have minesweeper with hook page, and as you can see I have game with hooks and game layout. And game with hooks, in the game with hooks we have scoreboard and grid, because we have a real state for both of these components, for the scoreboard and for the grid. Scoreboard timer, bombs counter, levels, and reset button. And grid, it's main game area. And about top components, it's out of responsibility of game component, because probably we will have game with hooks and game with context and game with Redux. So right now I just split it, and we have game layout component and game layout component for up top, and game area, and provide to the game area children. So this pattern calls render prop. We have two areas that just define items or define areas for this game layout component. We have children that render in the game area, and we have top component that render as sibling element for the game area. And top area, it's kind of legend, is a game name and what button can be pressed and stuff like this. So in the minesweeper with hooks we just it's page, of course, page minesweeper with hooks. We just compose together game layout, and provide for the top component this prop top. And top, it's kind of children item, and this button calls, I can repeat it, render prop, because top prop, it's just prop that we gonna to be render in the game layout. And game with hooks is a standard children element. So game layout again, we just define top and game area and put inside game area children. So we have page minesweeper with hooks, and probably we need to define some area, with menu and with links that that just opened some pages or stuff like this. I create component up, and then we need to install React router DOM as safe dependency. And then we need to install types for the React router DOM and install it as dev dependencies. Let's make it. Okay, and we define component up, and let's put to the up root element router. Router, it's a kind of provider that defined router for
our application, yeah, and all component that gonna be child component for the router. Just define one common router, yeah, and for these purposes router use context, and about context we are gonna to talking about it on the next sections. Okay, and then let's make navigation. And our navigation is just a list with bunch of links, and you can see that we use link component from React Router DOM, and we define a link to the root, and it calls just home, yeah, just name for our link, and link to game with hooks, and name for our link game with hooks, or probably let's put some spaces here. Okay, here we go. I've used switch component, and switch it works as first match, yeah, and we have bunch of roads. Road pass game is hooks, and road pass root, and switch find first match between URI road and pass, and then just open component minesweeper with hooks or home. And home component is functional component that works like this. Is just header with text minesweeper game forever. Let's run our game, yeah, and then just see the result. And right now we have absolutely the same result, yeah, because from the EDI perspective we need to change index, yeah, and now we won't go to the pages and take minesweeper with hook. We just import application and then just render up on the screen, and let's see what happened, yeah. And right now I have two links, and by default we have just home, yeah, it's just a root road, and minesweeper game forever. And when we open game with hooks, right now I have minesweeper with React hook, and then just go back and forward. But when we try to open this link, we have cannot game with hooks, because right now our Webpack dev server just don't know what happened, and it's trying to open this location in the file system and have none, and then we have this error. What we can do with this? And for the Webpack dev server we have history API fallback, and we need to put section dev server and history API fallback true, or we can use it just via usage via the CLI, yeah. Okay, and I want to put it to the config file. Let's take a look. And we just define section web server and put here history API fallback. Then just rerun our dev server, and we can see the result in the browser, yeah. And right now when I try to open this kind of URI, everything works fine, yeah. We just open minesweeper with React hooks without any problems, yeah. Okay, and right now in case when we open it by ourselves, put some address in the browser or just change it using history API, everything works by the same way. And it's basic introduction to the React router. Okay, see you in the next video. Bye. Let's try to check one more pass. When I add something after game with hook, like example test, I have this kind of error. Loading failed for the script with source, and we have source pass game with hooks, then /bundle.js. We're trying to just load bundle from the different paths according to this road. Let's fix it. And for these purposes we need to add public pass. And public pass is defined pass from which we should load our scripts or resources or stuff like this. Let's reload our Webpack dev server, and then
I want to show you one more useful feature. We can define parameters in the path. Like example, in the game with hooks, we can define parameter username, yeah. And when we put here a colon and then provide here a name for our parameter, it's kind of pattern, yeah, that we wanted to find. And if we don't want to make this parameter as required, we can put here a question mark. Okay, so then we can take this parameter in the component, in like example in the minesweeper with hook page, with hooks page, we can import useParams hook and then call useParams, and in the generic we can define what kind of parameters we probably receive, and username as non-required parameter, and then we put here minesweeper with React hook special for you, and in case when we have username we just put here comma and then username. Okay, so let's just try to check it. And right now I need to open game with hooks, then test, and you can see minesweeper with React hook special for you test, or unique, yeah, minesweeper with React hook special for unique. Okay, and in case when we won't define any parameter, we have minesweeper with React hook special for you. Okay, it looks cool. And one more useful component in React Router, we have redirect component, and redirect component can run real redirect process in our browser. And like example, when I have something strange in my path, I can redirect my user. Let's redirect to the root, and it means when we have some kind of non-existing path, we just redirect our user to the root. Yeah, so let's check this behavior. Okay, here we go. Right now I'm trying to put something like this, and then we just have redirect to the home page, yeah. And in case when we have something like this, yeah, unique, everything works fine, but with non-existing paths we can face with the troubles. And what if we define some query parameters, like example parameter data, or I don't know, some mark, and here's some ID, or probably let's put it like ID, yeah, 1 2 3. How can we take this parameter in the component? So let's take a look. And we can take one more useful hook, use location. And inside use location we can take parameter search. Let's take a look to the search, and you can see what we have. We have just string ID equals 1 2 3. It's just a just a string without any parsing and stuff like this. Okay, it's something controversial for me, and we need to parse it additionally if we use React Router. Okay, let's define one more stuff. It's just use query, and we have URL search params, and then we wrap use location search. So it means we have one more hook, use query. So and then we can create this hook, yeah, query, and then if we want to take some parameters, we can call query dot get and name for our parameter. Okay, and let's take a look to the browser. Okay, and then I can reload my page, and we have this parameter 1 2 3. Okay, so probably we can make this hook in common. Okay, here we go. Right now I have this hook use query, and then we just use the same pattern as before, use location search and URI search params. So use query test looks like this. We just mock React Router DOM, and use location returns some defined search, predefined search. and then we call this use query render hook and provide use query, and then in the result current we receive 1, 2, 3. Okay, I can put more parameters, but it should works fine. I believe in it. Okay, so let's move forward, and we have minesweeper with hooks. So we just take this query. Let's just, instead of log it to the console, make something more useful. So, and as you can see, we just take this ID, yeah, from the use query, we get this ID, and then in case when we have this ID, I want to make output user ID. Let's take a look how it works, and here we go. Right now we have both parameters, username and user ID. Okay, let's put here just ID. Okay, everything works fine. We have user ID. Okay, let's put here just name. Okay, even in this case everything works fine, but I have something strange here, yeah? Just nick 0. Okay, let's probably debug it. Okay, and problem is right over here. When we are trying to convert null to number, is just 0, and in this case we of course trying to make output 0. So because our ID it's 0, it should be false, and we return this 0, and then we draw this nick 0. So let's make a hotfix. And actually I have no any idea why I need this as number. Yeah, it could be string because we just render it. Let's check this hotfix. Okay, and right now everything should works fine. Okay, just one sec, I need to skip this point. Okay, so, and right now everything works fine, yeah, without now ID everything render cool. So then I put here some ID, and we have user ID. Okay, so looks like we've done it, and see you on the next video. Bye. Pure functions. And pure functions, it has lots of benefits. And I can show you an example of pure and impure functions. In JavaScript you have slice function that can return your data in some ranges between indexes in the array where you call it. And when we call XS slice 03, we have result 1, 2, 3. We just return some part of our array between range of indexes 0 and 3, and per every call we have this same result 1, 2, 3 and 1, 2, 3. And we have impure method splice. When we call splice, we change our data in the source array, and when we call splice 03, for the first time we have 1, 2, 3, for the second time 4, 5, and for the last time we have just an empty array. So it means that we can use some benefits of pure functions based on this property. And how can we reach this behavior? And the most significant stuff, it's pure function have no any side effects and have no any variables that are out of the scope of this function. And we have two examples, impure and pure. Impure function based on the variable minimum, just trying to calculate some age limit, yeah, and when we call function check age, we compare age and minimum that out of the scope for this function check age. What does it mean? It means that during our just calculations, and we can change this variable from the other side or other string of the code, and it means that then when we call this function check age, we just won't have the same result that we really expect. And how can we solve this? We need to put this variable minimum in the scope of the function check age, and we shouldn't change this variable. That means we can use const. So when we use const, we just strictly forbid any changes for this variable minimum, and then we close this variable in the area of visibility for the function check age. So to make our functions pure, we should just make a limit for the variables that we can call into this function, and everything that we need should be inside the scope of this function. And that's very important for the pure functions, because the most significant part of our problems that depend on our code is because of side effects. And what is side effects? Side effects, it's like example mutation. Yeah, when we change a variable, as in previous example, when we have this variable minimum, we can change it during the calculations, and then it could change behavior for the function check age. Yeah, and side effects, it's anything that just change behavior, possibly change behavior for our calculations for our program. And you can see a bunch of examples for side effects: changing the file system, inserting a record into database, making HTTP call. Mutations means we change variable, printing to the screen, or login, or querying the DOM. So probably side effects, it's everything that out of the scope this particular function. Yeah, and mutation is the most part of problems for our programs. So every function that just a pure function, we can create stuff like this. For the pure function, that's really pure. You can see a visualization for function, like example to lowercase. For every symbol that in camel case, we just create a table. Yeah, and for the value of per every uppercase symbol, we have value in lowercase. Yeah, and in case when we call this collection to lowercase and provide here a symbol in uppercase, we return symbol in lowercase. The same stuff for the function is prime. In case when we can provide per every value just like table. Yeah, we have value for what we want to check, and from the other side we have a result for this function. So is prime, like example, when we call it with 3, we have true, because 3 is just a prime number. And you can ask me, what is the benefit? Yeah, why we should visualize function like this? Because of memoization. And memoization, it's the most significant part of our programming. We can make some calculations that can be really hard to compute, and we can just memorize some part of this calculation, and based on this saved data we can return it immediately from the memory. And memoization, it's the most fundamental part for optimization of our programs, and we can easily memorize any function that pure, because everything that need for this function should be inside this function, and based on parameters we have the same return data per every call. So memoization, it's the most fundamental part of optimization. and we can visualize function mimoise. And mimoise is just a function that has some variable, that collection of data, and based on the properties that we receive, we just create some cache and then stringify arguments that we provide for function that we want to mimoise, and based on the arguments we just make in the cache just a row of data, and then in case when we have know this information from the cache, we just trying to run this function with this bunch of arguments and save this data into the cache and return data directly from the cache. It's some handmade basic memoization function. So one more benefit, our pure function, it's portable stuff. You can heard something about dependency injection and dependency inversion, and it's not something that we need to implement for pure function. Pure function, just based on the properties and based on the data from the scope, can compute anything. And we have two comparison in pure function and pure function. Everything that we need for the calculation in case of pure function should be in the parameters, in the attributes of the pure function. So it's easily to make this function portable, and we can stringify and then just send it to the WebSocket, and portability is the most powerful trait. Okay, and today we just look quickly to some part of the book, Mostly Adequate Guide to Functional Programming. I strictly recommend this book. It could improve your skills as a programmer, much more further than you can imagine, because base part of functional programming is about common sense, and pure functions is the most fundamental part of the functional programming and functional programming languages. Okay, so see you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Let's analyze our code, and I want to show you an example with OpenCell function. When we call OpenCell and provide here coordinates in player field, then game field, we receive new player field and is solved flag. And what happened inside OpenCell function? In OpenCell, take parameter player field, and then, as you can see, we take information from player field and we mutate data in the player field. Oh, and it's the biggest scene in the pure function world, and in programming world. Mutation, it means that you can find a lot of problems that based on this stuff. When we change this player field, then after a whole calculation loop, we just return player field, and it means that we mutate this player field and return this variable new player field, but it's just a pointer to the same variable player field, because it's just an object, and we mutate this object and return the same link, the same pointer on RAM. And when we call setPlayerField and just spread this data, we make this data we make this unbinding, and when we spread, we just make new collection and new player field. Okay, I want to probably in this case compare between previous player field and next player field, but I'm not sure, because we just spread this data on the top level, and links between erase that inside our player field, it's still the same, and I can't put here player field because I can face with problems that we just compare the same link. Let's make one more useful function. Okay, and we have function copy field that take field and then make a map and spread every row in this new field. It means that we fully unbind our objects in the memory and we just create a full copy of the field. And I can show you an example with test case. Okay, and we just take field generator and generate some basic field and call it previous field. Then we call copy field and put here previous field and create new variable next field. So in case when we compare it by the link, yeah, and when we call to be, it means that we're trying to compare links. It should be not the same links, yeah, it should be different links. It should be a copy of our collection. And when we call previous field to equal next field, we compare a structure and data of this, both of these objects. And in this case it should be true, and in this case it shouldn't be true. Yeah, it's just not to be next field. Okay, so using this function we can prevent this behavior with the same with the same object player field. Okay, and that's my plan. We have function openCell that receive the same bunch of props and return the same data as openCell recursively. And this function just call openCell recursively, and we just copy field player field that we mutate during this coding this function computation. Yeah, and right now I have player field that we mutate and game field that's just the data that we are using. Yeah, so it means that right now I copy this field and then return new player field, so it should prevent this miscommunication, yeah, using computations. And of course we make a referential transparency, and then hotfix for the set flag. And we right now just call copy field and provide here player field and return new player field. And during the execution we change new player field, not a player field, yeah, and then return new player field. So I want to check any regression that we can face. Let's run test cases. And bunch of test cases has been broken. Let's take a look what happened, and let's find a way to fix first test case. Okay, set flag. Okay, and that's the problem. Right now we use this kind of references, yeah, between player field. So we have player field at the first click, and then we provide here the same player field because it's just the same links. And I want to fix it using just variable result. And as you can see in the set flag we have field, boolean, and number. And we're interested for field. So let's just make here something like result, and then call here result 0. Okay, so for the next step we need to provide here a new player field, yeah, not a previous player field, new player field. So it should be result 0 right over here, and then it should be result 2. Okay, then let's call result 2 and provide here a new player field, and then we need to provide new player field for the last call, and then we can call this variable results 3. And here we go. We need to provide here result 3.0. Okay, let's call this test case. Okay, and we still have one broken test case. Let's fix it. And probably it's the same stuff. Yeah, we need to per every call of set flag we need to provide result from the previous call, because we have referential transparency. Okay, let's call it result. Then we have result 1 here, and we need to call result 0 right over here, or yeah. So then on the second call we need to provide here result 1. Okay, and looks like we've done it. Yeah, we fixed this behavior-based referential transparency. Okay, cool. Again, bunch of test cases just broken for use game. Let's take a look what happened here. And I believe that the same stuff should be here. We need to change referential between every test scenario. And probably we don't need to spread this data. We always need to call it from result current on change level, and result current on click, and the same stuff right over here, result current player field. Okay, and the same call for this expect, and for this on change level, so and so on and so far. Okay, and this it just was very easy to fix. Yeah, I just provide here result current per every call act or expect, and looks like we've done it. Right now our test case works fine. You can see it right over here. Yeah, this test case has passed. Let's fix the rest of test cases. And the same for on reset. Yeah, let's call result current per every expect or per every act. And I believe that it should be very easy to fix. Act on click. Okay. And the same here. Player field. And then current on reset. Okay, and for the last step we just take data from the result current, and looks like it's okay. It should be okay. Let's check that we have no broken test case on reset. Okay, on reset works fine. Let's take a look to the player lose the game, and the same fix. Yeah, we just have destructurization right over here, and I believe that we need to drop it. And then let's call result on click here and result player field here. Okay, and then on click here and player field. Okay, and looks like we've done it here. And for the last step it should be the same hotfix. Okay, and for player win a game, we open the last cell. I fix everything and I see something strange. Yeah, I'm unbinding all these references. It doesn't work at all. Yeah, we have still broken test case. Let's take a look to the use game, and looks like right now we have this player field and game field. And I believe that in case when we provide these parameters to the array of dependencies, we should it should works fine with this, because right now we have full referential transparency, and looks like it should works fine. Yeah, and right now we just immediately fix this bug in some particular case. When we regenerate player field, we have no any we just have no any regeneration for this memoized function that we wrap by use callback. So, and it means that we we fix one more bug, yeah, and it's very cool. Let's move for the last test case. Player win the game when set up flag to the last cell. Okay, and after unbinding we have full yeah, full catch, and we have 50 past test cases. Let's run a whole test case scenario and just let's see the result. I want to be sure that our code works fine and everything from the test case perspective works fine. Okay, and we have green lights is good, and looks like we've done it. Yeah, right now our code has full referential transparency, and we find one more and fix one more bug, yeah, with player field and game field. Right now we regenerate this on click function when we regenerate player field or game field. Okay, and for the on context menu we have the same dependencies, yeah, and looks like we've done it. Okay, see you next video. Bye.
Redux data flow, and you can see the diagram where we have action, reducer, and store, and also view. As you can see from view, we have action, yeah, and action then call a reducer that just change some data, yeah, or to be a little bit more precise, just create new data in the store. And then data from the store, we have subscription on the view from the data on the store. We have updates view after changes in the store, and it looks like a loop. Yeah, when we raise some action from the user and we have user on the view side, we call action, and action just handled by the reducer, and reducer produce new data in the store. And that's probably full scenario for the Redux. And reducer is just a pure function that produce new data in the store. And action, it's a kind of object that can handle by the reducer. I can show you an example, and based on the good best practices, yeah, we have Docs architecture. How can we use Redux? And based on this approach, we have architecture like this. We have bunch of actions, and name of the action, you can see that we have prefixes per every action, my app widgets, and then load, create, update, remove, some kind of crude operations. And we have reducer that just handle action type. Yeah, we just based on action type do some reducer stuff. We produce new data. And we have action creators that create object. Yeah, and you can see this object consists of two fields. It's type, and in the type we have type of action, and data, yeah, as a second parameter. So based on this architecture, I can show you a real example with the real application. Okay, here we go. We have increment and decrement actions, and we have reducer that based on the on this action just produce new data in the store. We receive state as a number, yeah, and then we change a state, yeah, and return new state, yeah, and based on action type we change state. In case of increment we return state +1, in case of decrement we just return state -1. When we have no any cases, yeah, any case, a particular case, we just throw new error. Below you can see several actions creator, and Here we have increment, and it's a function that return action, and decrement, it's again function that return an action. Yeah, and type of the action, we just define it based on these actions. Okay, and one more thing, we have initial state. Initial state, it's basic state for our reducer. How can we test this? As you can see, reducer, it's just a pure function. We take state, we receive state in action, and then just return new state. We have no any side effects here. We have no any kind of data that out of the scope for the function reducer. Let's take a look to the counter test. And here we have bunch of test cases. We have this test case where default init with increment action. Yeah, and how can we test this? Into the reducer, we should provide as the first argument, as far as we remember, it's just a state. Yeah, and I've done it as initial state. Yeah, and we have initial state 0, and then action. And just to create an action, I've called action creator increment. Yeah, and this action creator just return object action. Yeah, so it means that we provide here a valid action, then we switch by the action type and return new data based on this action. And in case when we provide initial state 0 and then increment, it means that 0 should be incremented to 1. And as you can see, we provide state 0 and return by the action type increment just state plus 1. Okay, and then init with value decrement action. So we initial value in this case we have 10, then we create action decrement, and we receive that after decrement we should receive 9. Yeah, because 10 minus 1 is just 9. Okay, it's basic example for the reducer and full Redux data flow. Just for the summary, we have reducer as a pure function that receive several parameters. First one, it's initial state or previous state, and second one, it's an action that just produce new state that we can easily check from the other side. Okay, it could be scalar value, it could be object or array, it doesn't matter at all. Reducer, one very important requirement, it should be a pure function. We shouldn't mutate state. Yeah, we shouldn't make any changes by the pointer or link. Yeah, we should return new state. It's the most fundamental requirement. So, and let's check how can we use it in the React application. And we have click counter basic. And we have one more useful hook for the Redux, it's use reducer. Use reducer, it's a kind of hook that just receive reducer and then initial state for this reducer. Then we return state and dispatch. State, it's a kind of state that we receive from the reducer. And dispatch, it's a method that could call an action for this reducer. It's kind of dispatch that provide to the particular reducer this action, and then when we produce new state, we receive this state in this variable state. So, as you can see, we call dispatch decrement and dispatch increment on the particular buttons for this click counter basic. Yeah, button minus and button plus, just decrement and increment, and we just call an action creator that provide for us object for the decrement action and increment action. Okay, I can show you a test cases. We render click counter basic, then we take decrement button and increment button and count. Yeah, as you can see, I just take these items by test ID, and we have test ID per every element on the page. Okay, and then we receive that by default we have text content count 0. Count, comma, 0, and as you can see we have count, comma, and then state. So and by default this state should be 0. Then we click increment button and receive that count should be 1, decrement button, and count should be 0. Yeah, because when we increment we just add 1, and then just decrement we just take minus from the value, from the previous value. Okay, so I can show you this example in the browser, and that's our click counter. We just click plus and our counter gonna to increment, and we click minus, our counter gonna to decrement. Okay, it's basic and fundamental example of the Redux. What benefits do we have in this scheme? We have lots of benefits from the reducer side, because it's just a pure function, yeah, and we can split logical part and just view part. Everything that depend on application state, it could be in the reducer, and everything that depend on view side could be in the particular component. So to be a little bit more precise, yeah, in the counter, as you can see, we have reducer, and we test this logic just using test cases for the reducer and particular actions that reducer should react. Okay, and you can ask me, yeah, why do we have so many logic in this place? Yeah, it's so many code to make some simple stuff, yeah, just increment and decrement. And I can show you one more example. It's Redux Toolkit slice. And slice, it makes this a little bit less verbose. In case when we call this slice, it create for us action creators and reducer, and we can provide initial state, everything that we need, just call create slice. Again, probably I have not said it right. Yeah, we have verbosity in case when we use counter by this way. Yeah, when we create reducer and then action creators and action constant and counter slice, we have just bunch of props. First one, it's a name for our slice. Second one, it's initial state, and then reducers. We just provide here a object in case of key, we have just key value instead of switch case. And for the key we have handler that produce new state, yeah, and when we distract data from the create slice, we have reducer and actions creator. And inside actions creator, as you can see, we have increment action creator and decrement action creator. And for the reducer we have a valid reducer. So let's test our counter slice. And our counter slice, it's absolutely the same test case as we have for the counter that I've done based on just vanilla way to make reducers and action creators. Yeah, and counter slice, it's a new way, it's a modern way to work with Redux. When I have test cases, you can see absolutely the same logic. Reducer is just a pure function. First parameter we can set up initial value, and second parameter we just create an action that reducer should handle and return new state. So it's quite simple and quite straightforward to work with Redux. Redux, it's a way just to split your application to the state part and to the view part. And view part can produce actions that just handled by the reducers and provide new data. Okay, I wanted to move forward with the Redux and create a version of the game based on the Redux fundamental architecture principles. principles stuff. Yeah. So see you in the next video. Let's make one more example with Docs proposal. As far as you remember, we have reducer, actions and action creators in the same file, that just compose together all Redux stuff. Okay, let's move to the project and let's make one more variation of the game. Right now we have game with hooks. Let's make game with Redux, because it should be a very cool example. How can we work with Redux by the same way, with the same functionality, that we previously have done with hooks. Okay, and right now I have game with Redux, and game.ts is just Redux model, and game test.ts it's game test. Let's first of all just describe state, and what state do we have? We have level, time, bombs, is game over, is game started, the same field that we used for game with hooks. And let's make a function get initial state that just initialized default data, and initial state level beginner, game settings for the beginner level, and then we return this data with game field and player field and stuff like this that we've done before for the game with hooks. And then let's make action open cell. And open cell is just a const that provide information about particular action that work on model game with Redux. And let's make action creators, and right now we need to import one more type. And in the Redux we have type any action that describe an action in the system, and type reducer that describe a reducer. So then what do we have? We have function open cell that receive coordinates, and return any action, as a result of work of this function. And here we have type open cell, and we create payload field where we can put any data that we need to some particular action. And here we have payload coordinates. So, and last but not least, it's reducer, and reducer receives state, and we provide here get initial state by default, and action. And action, probably it should be any action, any action type. So then we switch to the action type, and in case when it's like example open cell, we need to provide here logic that should works with this action. And one more thing that I see a little bit different as it was in the original proposal. It's default export. I hate default export. I like named export, and probably we don't need to use default export reducer. And for our case, I have just named export reducer that I can use here and provide here a case that can cover our functionality. Okay, let's move to the test cases. And I have bunch of test cases for the game reducer, and we have base initial state, that I provide as data for our test cases. As far as you remember, we don't need any mocks because we have pure function reducer. We provide data, then action, and receive new data. We have base initial state. So, and let's test, like example, our open cell, with a number. And we have game field and player field. Player field is just hidden cells, and game field, it consists of one bomb and in the left top corner, and 3 cells that provide information about bombs surrounding these cells. So when we call reducer with base initial state and provide open cell with coordinate 1 1, you can see here 1 1 is just a number, and we need to open just only one cell with this particular info. So next, when we provide here base initial state and trying to open cell 0 0, it means that we should
over our game, because right now we're trying to open a game with bomb. It means that bomb should explode and our game should switch to game over status. And is game started false, is win false, is game over true, and player field should be the same as the game field. And in case of player field, we should start this game. In previous example, when we just open a usual cell, we should run our game, and is game started should be true, and player field should open one cell. So it means that we right now have basic test cases, and then check open cell to cell with the flag. When we put here a flag in player field, we provide this basic initial state with is game started true, and this player field that consists of player field that have bunch of hidden cells and one flag. And then we're trying to open cell with the flag. It shouldn't open this cell because we cannot open cell with the flag. Okay, looks like we've done a bunch of test cases. And then let's run these test cases and make it works fine. Just change game.ts reducer and provide here a logic that cover our test cases. Okay, here we go. Right now I have case open cell. In case open cell, we receive payload coordinates. It's just a coordinate that we receive from the action. When we call this open cell action and provide coordinates, we have this object, type open cell and payload coordinates. We just destruct information from the payload and take coordinates. And as far as you remember, we have function open cell. And let's take this function and call it open cell handler, because we have action open cell with the same name. And let's call this function open cell handler. And we should provide to the open cell handler coordinates and player field and game field. Okay, and then we return from the open cell handler new player field and is solved flag, where we can take player field and game field. And probably the answer is in the state. We have right now in the state game field and player field and flag counter and everything that we need. And we receive from the user just coordinates. And everything that we need we can take from the state. We can take player field and game field. So it means we have new player field and is solved flag. Okay, and as far as you remember, we have errors in case when we're trying to open bomb. So we need to wrap it by the block try catch. In case when everything works fine, in try block, we should return new state and we shouldn't mutate previous state. So it means we need to spread previous data from the state and then put here new data. Is game started true? Because when we open cell, it should set up flag is game started to true status. Is game over depend on is solved flag. When we solved our puzzle, game should be over. And is win depend on is solved too. In case when we solve our game, we should end our game and set is win to the is solved flag. And player field is just a new player field. And what should we do when we catch an error? And in case when we catch an error, we should return new state again. And is game started should be false, is game over true, and is win false, because we over our game and we not win. We're just trying to open bomb cell. And player field, it should be equal game field, because we open all bombs on the field for the user. Okay, and it looks like we've done it. Right now we return to state in every case, and looks like our test cases has passed. Okay, we've reached our goal, and see you in the next video. Immer, it's a library that can create immutable data structures.
And we have basic example in the documentation. Base state is just array of objects, and without immer, how can we change this base state and produce new state without any changes of base? We need to make, like example, shallow clone, and we just clone our data, and we have next state, and in the next state we need to spread our previous data and combine it with the desired update. So we can push new data, because in the next state it's just new data, yeah, just new array, and without any problem we could use it. But in case when we want, like example, directly change something in the next state, when we call, like example, object 1 and then dot done is equal true, of course we face with issues, because we just make a shallow copy of the array, and objects inside the array, it's still objects, it's still just the links in the memory, and when we're trying to mutate it by the direct way, we still can mutate data in base state. How can we just make it a little bit more straightforward? And in immer we have produce methods, and in the produce we provide base state and callback that receive draft, and in the draft we can directly mutate the data without any problems, and immer produce next state and how immer works, a current state, and then immer produce a draft where we can make edits, and then immer produce next state without any mutation in current state. So how can we use it in Redux? And Redux Toolkit automatically use immer internally. Without any problems we can make direct updates using mutating syntax, and without any problems immer produce for us new state. I can show you an example, and as far as I remember we have reducer, where we right now have no any Redux toolkit. We have actions creator, and then when we return new state we spread previous state, and then we put data that we need to produce, yeah, based on this action handler. Okay, so how can we make it using create slice? First of all, we need to import create slice from Redux toolkit, and then we can replace everything in here, yeah, instead of actions and action creators and reducer, we can use one called create slice. And what we should put inside create slice? And first parameter, it's a name, and let's call it game. So then initial state, and we have function get initial state that without any problem just produce initial data in our state. So and then reducers, it's our object that consists of bunch of actions that just produce new state. And we have only one handler open cell in our reducer that we've done based on just vanilla JavaScript without any additional libraries. And we can easily make the same logic here. Yeah, let's call this action open cell. And value for this open cell is just a function that receives state and action. And then we should return new state, and just to make it clear, let's return our current state. How can I make type for our action? Because our action can receive any data, and in Redux toolkit we have special type of action, payload action. And right now we just import payload action from the Redux.js toolkit. Okay, and we can provide here a data that we receive, and as far as I remember we receive coordinates. Yeah, let's just make a type using payload action and provide here coordinates. And in the action we have a field. We have the field that just contain data that we receive from the action, and this field calls payload. So we need just a payload from this action. Let's extract this data. Yeah, we have payload. So, and we have the same logic as it was in our basic reducer. And we need to extract data from the state. Okay. So, and then let's just take this logic, copy and paste in our reducer. And instead our coordinates, we have just a payload. So, and then instead of this kind of style where we return use state, we can mutate data in our base state. I mean, something like this. We don't need this spread. We need just to mutate data that we need. So we can drop this return notation, and is game started should based on is solved. When we have no any solution for current puzzle, our game should start. So is game over based on is solve, is win based on is solve, and player field based on new player field that we receive from OpenCell handler. Okay, and the same logic should be below for the error, and we should just is game started should be false, yeah, because we just right now have broken game scenario. Is game over should be true, is win should be false. And player field is just a game field that we show for the user. Okay, and we don't need to return any state. We just mutate data here, and this is it. One more step. We should return just reducer and actions creator. And for these purposes, we need to export reducer and actions from create slice. And looks like we've done it. Right now I can easily replace this reducer and this actions creator and stuff like this. Right now I have we have no any Redux call, and so looks like we've done it. We need to fix our test case. Okay, and we import reducer and actions from the game actions. Okay, then we can, of course, we can import state. So looks like everything works fine. And instead of this call OpenCell, we need to call actions, then dot OpenCell, because inside our actions we have all actions that we create inside Redux. Let's watch current file, and then step by step just fix this test case. Okay, so right now we have two failed test cases. Let's call action OpenCell and actions OpenCell here. Okay, and right now everything has passed. We have everything cool. We have green lights. Green lights are good. Yeah. So today we just refactor our Redux using create slice API and using immer mutations. Yeah. And without any problems, it could be a little bit more straightforward than when we spread our previous data and combine it together with the data that we want to put in the state. Okay, so see you on the next video. Bye. Let's continue working with game with Redux. I see that we can make it by the same way as in game with hooks. Let's paste game with hooks right over here, and instead of use game we need to import reducer and actions from the game model that we made based on create slice API. Okay, let's take from the game, we need to take reducer and actions. Okay, and get initial state, because we need to provide initial state to the user reducer hook. Okay, and then let's rename it to game with Redux. Okay, and by the same way let's rename file. So let's import use reducer and then we need to call use reducer instead use game. So and we need to provide here reducer, and as second parameter we need to provide get initial state. Okay, so and then we return state, and we can use destructurization, but we don't need this bunch of callbacks. Okay, and second parameter it's dispatch. Okay, and what should we do next? We have no any callbacks. Yeah, data, it's okay. We just use destructurization from the state, and we need to make a bunch of callbacks. What we should do? Of course, we can still use hook use callback and provide here dispatch and dispatch actions from the actions creator. Okay, and we have onClick function. What should we do to make this callback works fine? Let's make function onClick. Yeah, and absolutely by the same way we need to use the same signature as we have for this callback. We receive coordinates and return void. So one more thing, we should import coordinates, and we just import coordinates from core field, and on click we just call use callback and provide here coordinates. We don't need this typecasting. Yeah, okay, and looks like this onClick should works fine. We just provide this onClick and we use callback. We just memorize this function and we never recreate this function. Yeah, it's just persistent memorization. Okay, let's by the same way create on reset callback. Okay, for the reset callback we just dispatch action reset, because we have in the reducer action reset. Yeah, so then as you can see everything works fine. We need to fix on context menu. Yeah, and we have action set flag. Okay, let's take a look again to the game. We have open cell, we have set flag and reset and change level. Yeah, okay, so let's use here set flag. Okay, and the same name on context menu as we provided to the grid. We just wrap it by use callback and provide here the same as you can see here. We have signature and we have function that receive coordinates type coordinates, and we can use these coordinates and provide it to the action set flag, and we just dispatch action set flag. Okay, and last but not least, it's on change level handler. Let's call it on change level. Yeah. Okay, and what do we need to make? And by the same way, on change level, it has the same signature. Yeah, as you can see, we just receive event, change event from the HTML select element. So we dispatch change level, and level we just assert it as level names. Yeah, it should be one of possible level names. And every callback we just wrap it by use callback. Okay, I believe that we've done our job. Let's make test cases. And what we can test here, I believe that we just can match fragments and render game field by default fragment, and then when we click we receive new field. Yeah, and we can still use as fragment, and per every action, like example, click to the and set up flag. Yeah, as you know, context menu, second button click. So it should be flag on the field, and reset handler should works fine, but we can make it a little bit more better. We can provide here a click, and then we just reset and match snapshot before and after. Okay, so change level works fine. Okay, when we change level, it means that we should change size of our field, and game over, reset the game state. Yeah, and probably we need to again just match snapshot before some action. and then we can call click, yeah, so, and then reset. So okay, let's put this click before snapshot, then we make snapshot, then reset, and then again match snapshot. Okay, let's run this test case. Okay, in VS Code we have snapshot tool that provide for us useful mechanism to make snapshot testing a little bit more easy. So I can open our snapshots and then we can check our test cases. Let's check render game by default. Okay, and it should be something like default field with 10 bombs, yeah, and then bunch of styles, and we have field with size 10 by 10. Let's just probably wrap something. Okay, it's probably a little bit not so easy. Let's check right now just bombs, yeah, and by default we have 10 bombs, yeah, our bombs counter just equals 10. Okay, everything works probably fine. Let's find next test scenario where cell click works fine. Okay, so it means that when we click to the left top corner, as you remember, yeah, it's just left top corner with coordinate 0, 0, it should open some cells, yeah, and let's take a look to the field, and you can see the result. Yeah, it's just a bunch of open cells, yeah, and looks like we've done everything works fine, yeah. So next test case, context menu handler on a cell works fine. Okay, and again we just set up flag to the left top corner, and it should be 11 in the left top corner. Okay, everything still works fine, yeah. So then reset handler works fine. Let's check how it works. Okay, and probably we should have two cases, yeah. And first one is just we open some cells. Okay, let's take a look, and we open some cells and we have empty cells, yeah, 0, 0, state 0. Okay, everything works as we expected. And second scenario, when we click and then reset, yeah, so we should revert our field to the default state, and it should be 10. Okay, everything works fine. We have 10s in our field. Okay, everything reverted. So, and we have game with Redux, and we change level to the intermediate. As far as I remember, we have 44 bombs for the intermediate field. Let's take a look to this scenario. Okay, and we have 44 bombs, yeah, on the intermediate field. Everything works fine. Okay, and game over, reset the game state. Okay, let's take a look to the several cases, because first of all we just click and open some cells and then just reset game. Okay, so we should have open cells. Okay, 0, 0, 0, open cells, everything works fine, and then when we reset it should be just hidden cells. Okay, and we see a bunch of hidden cells on the beginning on the field. Okay, looks like we've done it, and our snapshot works fine. So let's just create index file that just export game with Redux. Okay, so I just stop test cases. So, and then we need to make one more page, and in this page we just create minesweeper with Redux and header with minesweeper with React plus Redux and use reducer special for you. Okay, and inside we just put game with Redux model. Okay, and for the test case we just match snapshot. So last but not least, we need to add one more road to our app. Okay, and here we go. We have minesweeper with Redux into the pages, and then we import minesweeper with Redux from pages. So next we need to add one more link, and this link to game with Redux, and it names game with Redux, and we need to create one more path to game with Redux. And then we receive that we should render game with Redux. Okay, let's take a look and just run our dev server and check in the browser how is it looks. Okay, and game with hooks.
and then game with Redux. You can see that we have minesweeper with React plus Redux and use a reducer special for you. So I click to some places, yeah, and then just reset, everything works fine. When I change level, everything should works fine, and looks like we've done it, yeah. Right now our game works fine, yeah, and I can track in the profiler about performance. Let's start profiling and then just open something, okay, and let's stop. Okay, and looks like we have no any redundant re-rendering. When we open some cells, looks like just particular cell that we open just change their status, yeah, and we have re-rendering only in case when we have something to change, yeah. So yeah, we have just a bunch of particular data, just particular branches that gonna to update. As you can see, we just update only one cell in this case. It's very cool, yeah. We have no any redundant re-rendering. Okay, and in this case we just open one cell and just change one cell. Okay, it's very cool, and I believe that right now you can see the benefits, yeah, because in case when we just create click counter, it just, I don't know, it can be so so cool application, yeah, but in case when we create something little bit more difficult than click counter, you can see the result. Right now we have straightforward logic, yeah, we use create slice, and in our reducers we have just 4 actions, and this is it, yeah. We have full logic flow in the Redux. We can easily test Redux because it's just a data. We should not mock, yeah, something, because reducer is just a pure function. It's receive state and return new state without any mutations and stuff like this. It's kind of time machine, yeah, previous state and next state. Okay, and from the code side and React side, I mean, of course, from the view side, we just take data from the Redux and call a particular action, and that's all. It's our purpose. Yeah, we just call actions and then receive new data that we provide to the components. We can compare it with game with hooks. And you can see that we take a data from this hook, but this hook, it's not something straightforward. It's much more it's much more logic and code here, yeah, because I don't know how can I optimize it. Probably I have some problems here and I can make something by the different way, but I used composition. I actually split this logic between settings and statuses and time that we actually haven't had implementation yet in Redux game, but still we have much more preferable way to create and support code by style that we implement in game with Redux. Okay, so see you in the next video. Bye.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Let's continue working with our create slice API, and let's add one more action, set flag. And set flag, it has absolutely the same API, yeah, and we can create it like this, set flag. Okay, and then let's return the same state, yeah, just to make everything works fine, yeah, according with the signature of the function. Okay, so right now I want to cover our test cases for the set flag. Okay, and here we go. Right now I have full flow for the set flag, and when we call action set flag and provide here coordinates 1 1, so it means we should set up the flag to the coordinate 1 1. It's right bottom corner. So then when we have this flag state, or I can call it state 1, let's refactor it and call it just state 1. So then we provide state 1 to our reducer and then call action set flag one more time. It means that we instead of this flag we should put here weak flag, yeah, just question mark. So let's refactor this state as state 2. So and then based on state 2, when we call reducer and provide here state 2 where we have just weak flag, we call actions set flag with the coordinates 1 1, and it should be equal the same state as base initial state, but isGameStarted should be true. It means when even if we just reset flag, we still have isGameStarted true status. Okay, and let's make this test scenario works fine just to implement this logic in the set flag action. Let's take a look to the use game hook, and we have on context menu handler that put flag to the field. Okay, and we can use the same bunch of data, yeah, and the same logic into our reducer. First of all, let's import set flag for our game. So, and then we need to call it in set flag action. And for these purposes, let's just copy this call of set flag in use game and put it to the set flag here. So instead of coordinates we have payload, and this bunch of data we can use this data from the state. Let's just call destructurization and get this take this information from the state. Okay, right now we have probably it's everything that we need for the set flag we provide to the parameters of this function, and we need to update data in the reducer. Okay, and let's start from the state and let's call isGameStarted, and this game started should based on isSolved flag, yeah, and it means that our game should start when we have isSolved false. It should be true, yeah, it's just inversion of isSolved flag. So, and when it's true we have false, that means that we just solve puzzle, yeah, and our game is over. Okay, and then state is game over, and it based on isSolved flag 2. Okay, and the same logic for isWin, yeah, we over our game when we solve our puzzle, and we win our game when we solve our puzzle, yeah. Anyway, when we have no solution, we it means that we we just not solve our puzzle and we not over our game. And then flag counter and player field, yeah, we just set up new flag counter and new player field, and we don't need to return a state. Okay, and it looks like we still have problems, yeah, and we have failed test case. Let's debug our test case and we'll see what happened in the example stat flag. Okay, let's restart our test case. And then we have breakpoint in the set flag. Let's make step into. Okay, and then we in the set flag action, and let's probably make one more step. So step into. Okay, so then we just copy our field. Okay, and looks like we have no any updates in the field, and that's the problem. We have previous flag counter equals 0 and we have 0 bombs on the field, yeah. It means that we shouldn't add new flags. So, and probably it's because of our base initial state. We have 0 bombs in case when on the game field we have 1 bomb. So we need to change this data. Yeah, we need to make 1 bomb. Okay, and then probably everything should works fine. Let's just drop this. Okay, everything works fine. We just fix problem in our base initial state, and right now we have set flag action that works as we expected. Yeah, we just call set flag and then mutate data, and our test case just check that our flag just change state as we expected. Okay, and we have more test cases. In case when we have win flow, we should create 2 scenario. First one, we just set up flag on the last step. Yeah, and when we set up flag on the last step, we should solve our puzzle. And like example, we call reducer, provide here base initial state, and then open cell with the coordinate 1, 0, and we have state 1. Then we open 2 more cells, and on the last step we just set flag to the 0, 0 coordinate, yeah, based on state 3, and we have last state 4. That should change our flag is win and is game over, and right now is win true, is game over true, is game started false, and flag counter 1, and player field, as you can see, we have flag in the left top corner, and we open this cells, yeah, with 1 inside this cell. Okay, and open cell on the last step, yeah, when we just first of all set up the flag and then open 3 cells. So, and after this we should have state like this: is game started false, is win true, is game over true, flag counter 1, player field with the same data as it was on the previous test case. Okay. And here we have one useful pattern when we just produce new state from the reducer, and based on this state we produce new state again. Yeah, it's like a kind of time machine. Yeah, previous state and next state. Yeah, and we just make these changes step by step, and just we have 2 scenarios that describe possible win scenario where we should catch a win state. Okay, so, and we have what rest of the cases that we need to add for our create slice, and probably we need to add reset game and change game level. Let's create action reset. And when we call reset, what we should do, and probably this function it should take information about game level, and then based on this information we should provide new state. And how can we make new state? We have get initial state function, yeah, and get initial state just create this basic state based on level beginner, and we need to add probably this as parameter for our function level. So let's make this level like example level names, yeah, type, and then we need to set up this level as beginner by default, and we shouldn't have this constant anymore, yeah, because we just define our level, yeah, so everything should works fine. And then we can call this get initial state and provide here a level from the state. So, and looks like this reset should works fine. So let's add one more action, and this action change level. So, and we receive state, and then we have action, and this action is just payload action. and we provide to the generic, okay, let's return state, yeah, and in the payload action it should be level names. So then what we should return, of course it's just this kind of action should just reset all data and provide new information about game level. So, and looks like in the action we have payload that consists of information about new game level. So we should return get initial state and provide here payload, because we receive new data about level in the payload, and then we provide it to the get initial state. Let's cover these scenarios. Okay, and when we reset game, we should reset game to the default state, yeah, and we provide to the reducer this base initial state. Let's take a look to the base initial state. We have information that this level is just beginner, yeah, but we have strange game field and player field, and strange information about bombs and flag count, probably bombs, yeah, because flag counter should be 0 by default. Okay, and when we call actions reset, yeah, we just receive that in our next state it should be data like this, and I have here a check, just partial check of my state, because I don't want to check exactly game field and player field. It's enough to take information about lengths of these arrays. And we need to take information about level, time, bombs, is game over, is game started, is win settings in flag counter, according with the base settings for the beginner level. And we have 10 bombs on the field, and settings field 9 by 9 and 10 bombs on the field. And we should reset flags that just provide information about state of the game. So I believe that this check just enough to be absolutely sure that we reset our game. So next we just change our level to the intermediate, and then we have the same partial check. We provide to the two equal expect object containing, and here we have bombs 44 for the intermediate level and settings for the intermediate game level, and our game field and player field to have length 16. Okay, looks like we've done everything that we need from the logic side for the reducer and actions. Okay, so on the next video I believe that we can implement this logic to the UI side. So see you. Let's make a quick start to React Redux package. And React Redux, it provides for us a possibility to use global state. And here is an example. And we have app store where we import configure store from Redux.js toolkit, and then we call configure store, and we need to provide information about reducers here. And then we return a store object, and we can also create root state as a type, return type of store get state. Okay, so then we can take this store and take provider from package React Redux, and provider prop store just set up a store for our application, and it's kind of global store that could be used from any component below this provider. And how can we use this? We need to put to the configure store a reducer that we want to use. In this example we have some counter slice and reducer that we import, and then just provide to the reducer field our counter reducer. And then in component that below our provider, I mean like children elements, yeah, it doesn't matter how deep this children is, we can provide for that children a particular data from the Redux. And for these purposes we can use
hook use selector and hook use dispatch. Use selector just provide for us information about just provide for us state from the store. We can provide here a function that just return for us state into the callback that we put as the argument for this use selector, and we can take a particular data from this state. And in this example, we just take in state value account and use dispatch, provide for us a dispatch function, and then we can render this count and provide to the callbacks dispatch, and here we have just action creator increment and action creator decrement. Okay, how can we implement this approach onto the project and what benefit it will be? Okay, first of all, let's create a directory game with use reducer and move our game with use with Redux. Yeah, we need to name it game with use reducer to be a little bit more precise. So, and right now it's just a refactoring. I move inside the directory game with Redux. I've done directory game with use reducer, and there we go. It's just a component game with reducer with the same content as it was before. So then I export game with use reducer from game with use reducer, then refactor in the pages and make minesweeper with use reducer page. So, and last but not least, I've just import minesweeper with use reducer and replace here component to location game with Redux. Let's rename it to game with use reducer. Game with use okay, let's name it by the same way, game with use reducer. Okay, and location game with use reducer. Okay, right now it's pretty clear. So let's make one more directory and let's call it game with React Redux. Okay, so right now we need to add store. Let's create file store.ts, and in the file store.ts I want to make a global store. So first of all, let's import configure store from Redux.js toolkit. Then we need to import our reducer from game with Redux, and probably it's something that we need to export from game with Redux. Okay, right now in index file we just import game with use export game with use reducer. Let's export one more stuff. Yeah, we need to export Redux and actions from game, and I believe that everything reducer of course, yeah. And I believe that right now we can import reducer directly from the modulus game with Redux. Okay, so then we can configure store, and in the reducer I want to make I want to name a part of our store just game, and then provide here reducer. So for our reducer, it should be in our store, it should be game data, yeah. And we provide reducer for the game. It's just reducer from game with Redux. And last but not least, let's export root state type. And for this purpose, we just use return type. It's a utility type, and use type of store get state. Store get state is just a function, and return type just return for us a type for the store. So everything looks cool. So then let's make a folder game with React Redux. And let's first of all just create something quite simple, like example game over component. And how it it look how how it's look in game with use reducer. Game with use reducer just render this kind of component. Let's just copy and paste this data that we should render. So, and we need to import game over component. Let's import this component. Okay, and right now we need to return a bunch of data. Yeah, so what kind of data do we need to take from the Redux? Is game over and is win. And on reset, it's kind of callback that we need to create inside our component game over. So let's import use selector. Okay, and we import use selector and use dispatch, and then game over is just game over component, just not to make a conflict between names. So we need to take a data from the store using use selector. How can we do this? We need to call use selector, and then here should be state. And we can take any data from the state. But just to use power of Typescript, we need to import root state from the store and make a type for this state. And what we should take from the state, and probably is from the game, we should import is game over and is win. And we need to return both of these flags. Okay, is game over and this game is win. So then we can take this data from the use selector, and here we go. Right now we have both of these flag that is game over and is win, and we need to make one more thing. It's on reset handler, and for these purposes we need to call use dispatch. So, and use dispatch return for us dispatch. And then we need to take actions from the game with Redux. And last step, we need to call use callback, because we need to make memoization for our function that gonna to work with on-click callback. Okay, right now it's just quite simple call use callback. We wrap our dispatch that just call actions reset, and it means that we create a memoized callback that we can provide to the game over component. Okay, and then when we create, as you can see, we create this callback, but actually I'm not sure about this use callback, because we just create memoized function and then provide it to the component game over. But okay, let's make it by use callback. It's okay. So last step, it's just create game over test, and I want to wrap our game over by the provider. Take fragment and just render it by default state in the store, and I believe that it should be just empty component, because by default we have is game over true, yeah, so is game over false, yeah, because we haven't started yet, so it means we should render just empty fragment. And we have this document fragment that's just empty state, and everything works as we expected. So, and by the same way, let's create scoreboard component. We need to take the same approach. We just copy scoreboard from game with use reducer and return it here. Okay, and right now we can see what data do we need. And just import root state, and then we need to call use selector. And by the same way, we use destructurization and take from the game all the necessary data, and then destruct it from the other side of use selector. And let's make a fix for the game levels, and we need just to import data from the model's game setting, game level. Okay, and on change level and on reset. And of course, one more useful thing right now, scoreboard, it's just a link for the scoreboard for the component itself. Let's import scoreboard from the component scoreboard as scoreboard component.
let's just copy scoreboard component. So, and then replace here scoreboard to the scoreboard component. Right now everything works fine, and we need to add two more handler, on change level and on reset. And just let's wrap by the same way on change level and on reset, and we need to take dispatch. Yeah, let's just copy dispatch from here and put it here. Okay. And one more last thing, we need to import actions, yeah, because right now we need to add actions from the models game with Redux. Okay, so right now we have use callback that wrap our callbacks, and we just memorize it and strictly forbid any recreation of these callbacks. So then we provide all data that we need to the scoreboard component. Okay, looks like we've done it. Let's make test case. Okay, and by the same way, I just render a snapshot, yeah, and wrap it by provider my scoreboard. Let's take a look to the component, and I believe by default we should render a scoreboard for the beginner level, and it means that we should have 0 time by default, of course, beginner, intermediate, and expert. Okay, cool. So, and we should have 10 bombs, yeah, by default. Everything looks as we expected, and everything cool. Okay, last but not least is just grid component, and I want to skip detailed development because we just take data from the game using use selector, and then take dispatch and create two action on context menu and on click, and then provide this data, I mean player field that we take from the store, and on click and on context menu handler to the grid component. So, and then we need just to create grid component, and just to be sure that our grid renders fine. And then in the index file, let's make game with React Redux and import scoreboard, grid, and game over component. And then we just return this bunch of components, and I believe that it should be result that we really expect. And better let's call it game with React Redux, because I want to make a separate test that just render fragment and match snapshot. So, and in the index we just export game with React Redux. Let's add to the index file in the game with Redux. Let's add export game with React Redux. And let's make a page minesweeper with React Redux. Right now we have minesweeper with use reducer and minesweeper with React Redux. Yeah, that import game with React Redux. So last step, we need to add one more road. In the app we import provider and also minesweeper with React Redux. And then we create one more link, React Redux, game with React Redux. And here we go, we just add to the road provider with store and wrap minesweeper with React Redux by this provider. Let's check in the browser how it works. Okay, and looks like we've done it. Let's just click to some places, then restart, then lose game, then change level, and then change level again, and restart game. And let's record some session. Let's just start profiling and click to some random places. Okay. So then reset, beginner, okay. And let's stop record and then analyze our report. Okay, and looks like everything works fine. Yeah, we just prevent any redundant re-rendering. I have no any re-rendering. Okay, in case when we just replace whole game state, it's probably we just change level. Yeah, everything of course re-rendering. Or in case when we just it's very interesting. Yeah, it looks like we re-render only one cell. Okay, I haven't seen any criminal. Yeah, everything works fine. Yeah, and we have cool re-rendering 3. Okay, looks like we've done it. See you on next video. Let's compare example with React Redux package and use reducer. When we just call use reducer, we can provide here reducer and get initial state. We take data that we need in the game with use reducer component. Yeah? Then we initialize all callbacks that we need and just return a components, and every components take data that this component need and callbacks that this component use. But we still cannot to split this code because our use reducer just initialize here a state, yeah, and we cannot to split it. We just can provide data and callbacks to the component that receive this data or callbacks. Okay, and if we compare this game with React Redux, as far as I remember, we initialize global store, and in the store we have this reducer, yeah, and all data that we need in the game key, yeah, I mean in the key game of the store. So it means that we can split responsibility, or our scoreboard, our game over, and our grid component can just use data that these components need and create their own callbacks. Let's take a look to the example game over component. And as you can see, we just take data that we need from the store, yeah, and subscribe to the is game over and is win flags, and then we create callbacks that we really need. It's just dispatch action reset, and here we have just a template, yeah, and in case when game over, we shouldn't draw anything, and in case when our game is over, we should just render game over component and provide here callback and is win flag. So to the scoreboard, it's absolutely the same story. We just handle data that scoreboard need and create callbacks that scoreboard need. And in this case, we have independent component and single responsibility principle, because scoreboard can handle data that scoreboard need, and it doesn't depend on any other components, yeah, it's just kind of data, yeah, and in this case we have just state of the application, and Redux just handle I mean from the business or from the application state side, and components just take data and just call particular actions. So in this case we have layer of the logic in the Redux, and we have layer of view in the components, and it's very cool from the architecture side. And one more benefit, we have Redux dev tools. It's a kind of tool that provide for us information about updates and about actions that we have in the Redux, and you can install it per every browser, and then you have additional tab in the debug console. You can open Redux, and then you can see how it looks, yeah. When we call some action, we can inspect action, and we will see how this action change data. And here we have difference between state. Is game started false, then true, and we initialize player field, yeah. We just update player field, and we have bunch of new data in the player field, as you can see, yeah. Just open some bunch of cells, yeah, that we draw on the screen, and you can see whole state, and there is game, and there is just snapshot, yeah, just a particular state of the game on this stage. And in it, yeah, you can see what happened. Yeah, we can see on the top level is game started flag changed. Yeah, and then of course player field changed that we can see in the div. And one more useful tab, it's test, and we can see a test case that Redux right now just provide for us. Yeah, we have previous state and action that we create, and then next state that we can compare. And Redux developer tools, it provides for us very cool test cases that you don't need to write by yourself. Yeah, you just can copy this test case and paste into your test cases. Okay, and you can look at the particular action. Yeah, action game open cell and then data, and it's very easy to debug this kind of information. You have previous state, next state, and you can easily find what happened when you move between states. Let's just reset data, and we'll see that action type game reset. It has this difference. This game started false, then we just reset player field and we reset game field. Okay, and right now everything works as we expected. So it was just a bunch of benefits that you have when you work with Redux, and okay, thank you. I want to show you this diagram again, Redux data flow. And here we have view, action, reducer, and store. And my question is where we can run a side effect. And right now action is just some object that deliver data and initialize some changes in reducer. Reducer is just a pure function that produce new state that we put in the store, and store just update view. Yeah, where in the theme we can run a side effect. And I can show you a basic example with component app. In this component app, we have a button make an API request. Yeah, and when we click to this button make an API request, we call this callback make request. It's just a sync function that can run any actions. Let's start from the reducer. And reducer, it's of course pure function. In case when we have action loading, we return new state with flag is loading true. When we have success action, we just set up is loading false, and data we receive from the action, and error undefined. And in case when we receive error, we just set up flag is loading to false and data undefined, and error action dot error. So okay. And what we have from the action side, we have API request, API success, and API error. It's just an action creators that create action with data or error, or in case when we have API request, we just return type loading. Okay, so then what we should do in the make request function, and probably on the first line of this function, we should dispatch action API request that just switch, that just toggle state is loading. And when we try to render these components based on this flag is loading, we just draw this data. Yeah, it's just an element div with loading. So let's try to make an API request. And you can see that right now we get new data from the store. Yeah, we just have new state, and in state we have flag is loading that just render this data. And what we should do next, and when we want to take a data, we have function get to do's from API. And in the API we have array with a bunch of data, yeah, just to do list, yeah, with bunch of object And then when we call get to dos, we just delay this function to 1.5 sec, and this function to do is just a sync function that resolve after time that we provide as a parameter for this function. So, and after 1.5 sec we return to dos that we receive from this object to dos. Yeah, just basic imitation of back. So what we should do next, and probably we need to call get to dos. Yeah, so let's create data const and then await a data from get sec get to dos. Okay, so we should receive data right now from this function get to dos, and it means that we should dispatch API success in case when we receive this data. We should dispatch API success and provide here data that we received from get to dos. Okay, let's reload our application and then let's try to make an API request. And everything works fine. We just receive to dos and draw this data. You can see the result. Right now I have dispatch API request, then side effect, then we dispatch new action with this data that we received from the API get to dos. But what happened in case when we have some error? Let's just try to throw new error, yeah, in the get to dos. Let's make an API request. And right now we have something went wrong, yeah, because we just throw an error and everything is broken, yeah. Let's just use try catch block, and in case when we catch an error, we just handle this error by second action, API error, and let's dispatch API error and provide here error that we receive from our API. Let's just reload our page and then make an API request. Okay, and something went wrong. Cool, yeah, we have just, it works as we expected. Yeah, we just have a data from the error that we render right over here. Okay, everything cool. Let's right now just comment this this line and let's make an API request again. Okay, and we have to dos. Everything works as we expected, and there is a basic example. How can we manage side effects? We need something in the middle, yeah, because right now we dispatch one action, then make some side effect, and then dispatch one more action, yeah. So it means we need to have probably one more conceptual theme in the Redux. And in the Redux we have middlewares. Yeah, in middlewares it's something in the middle between action and reducer that change data in the store. When we run an action, we can call middleware, yeah, and then middleware run some side effect. And when we receive a data, we just dispatch new action, and this action change data in the reducer and we render it in the view. And one of the well-known middleware, it's a Sunc. Yeah, it's Sunc, and Sunc it's a domain in computer science that means some kind of delayed calculation. Yeah, and Sunc it's just a specific action, yeah, and you can see an example of this Sunc function that provide here a dispatch and get state, yeah, and we can call dispatch at any moment when we run this Sunc function, and we can take anything from the state using get state. So here it should be our side effects, and we can make action creator that create this Sunc action. Now in fetch to do by ID, it's receive argument ID, and then we return a sync function that gonna to make these side effects. And there is just a Sunc action, yeah, Sunc function, and this is just Sunc action creator. Okay, I can show you an example. Let's take a look to the scoreboard component, and we receive time, but we have no real updates of time, because when we update time it's just a kind of scheduled job that should be per every sec just update our timer, and it needs to be done by Redux middleware. And I believe that we can make pure things first. Let's create a action creator that just update time. Let's create action creator update time. Okay, and this function, it's quite simple. We have to update time. We should call state time and just set up new value of the time. Let's just increment time, just set up state time +1. Okay, and let's make test cases. Okay, and there we go. Right now we have check update time test cases, and first test case update time from 0, and we provide base initial state and then put as a second parameter actions update time. And then I want to just partially check our final state, and for these purposes, as far as I remember, we just call to equal and then provide expect object containing, and in the object containing we provide time. So, and that's only one prop that we want to check in the final state. And by the same way, I update time from 10, and from 10 it should be 11 as a result, and we just partially check using to equal expect object containing, and time should be equals 11. Okay, and we have green lights are good, and right now we need to move forward, and I want to make, I think, actions that should initialize this job. And let's make here a separate action creator that just gonna to run our timer. Let's call it run timer. And what type should be for this type of function? And that's just action creator, and for this function we should return a right type of this action. Let's just import thunk action, and thunk action, it's a type that receive return state and then extra arguments type and just an action that we want to call. So in our case, we can run thunk action and provide here a bunch of arguments. We shouldn't return any something, and as the first argument it's just void. So as second argument we can import root state. In the store we have this root state that just calculate return type for our get state function. So we need to import root state right over here, and let's provide here root state. Okay, and then let's provide unknown because we have no any extra arguments. Okay, and as just last parameter we can provide any action, so because it doesn't matter at all for us. So then what should be in the body of this function? And you can see the result of thunk action, and this thunk action create a function that have first parameter dispatch and second parameter get state and third parameter extra argument, and return type of this function that we initialize as first parameter of this thunk action. Okay, so here we can put any side effect that we want to make. And I believe when our game is started, we should run our timer. Okay, and we can put here first condition. If is game started, we should do something. We should run our timer. And we can make one more function, like example recursive update that gonna to update per every probably per every sec or state. So, and is game started, we should call this recursive update. Okay, let's call dispatch and provide here recursive update call. So in this case, when our game is started, we just dispatch new action recursive update. Okay, so and then all magical stuff, it should be inside recursive update. Okay, and probably we can use
set timeout, yeah, and per every sec we should call recursive update again based on the data that we have in the store. And is game started flag just provide for us information? Should we run our timer forward or not? And if is game started flag true, we should dispatch action update time, and we have this action that gonna to update time, and then dispatch recursive update again, yeah, until game is game started flag true, we gonna to proceed to update time. So it looks like it should works, yeah, it should works, and I believe in it. But one more thing, yeah, when we run our timer, probably we need to check one more variable, time. Yeah, we need to run this recursive update only in case when time is equals 0, yeah, because when our time is not 0, it means that our timer is already increasing, yeah, and we shouldn't run this recursive update again. Okay, and let's check a bunch of test cases that we've done for this function. Okay, and we have first function run timer, and as far as I remember, we just need to call this function and we return a async function. So, and we provide data that we need to have for this async. And mock dispatch is just mock a function. So then second parameter, it's just emulation of get state, and we return a state that we need for this particular test. And in case when game started true and time equals 0, we should call our dispatch. Okay, let's check it again. When our time is 0 and is game started, we should call dispatch and provide here recursive update. And it's enough to check that mock dispatch to have been called. So second check, we just changed data, yeah, and is game started true, is time equals 0, our mock dispatch not to have been called, yeah, because when our time is more than 0, we shouldn't call dispatch again. Okay, and check action run timer with state is game started false, time equals 10. Okay, and by the same way, we shouldn't call this function and mock dispatch not to have been called. Yeah, only one scenario, when time equals 0 and when game is started true, we should dispatch this action. Okay, and second bunch of test cases, it's a check for the recursive update function. And for the recursive update, we by the same way, we can mock dispatch, and we use fake timers, yeah, because I don't want to wait until our set timeout gonna to done its job. And in this case, we just need to use fake timers, and then we call recursive update and provide here a data that we need, and is game started should be true. And in case when we advance timer by time 1 sec, it means that our mock dispatch to have been called 2 times, because when we have this game started, we call dispatch 2 times, yeah, in line 105 and in line 106, yeah, we have 2 dispatch. Okay, so then in case when we provide this game started false, that our mock dispatch, it shouldn't been it's not to have been called, yeah, because we don't need to call it again. Okay, so right now looks like we've done this part of the job from the Redux and test side. Let's make changes in the component. And we should run our timer when we click to the cell or when we put a flag to the cell. Yeah, so, and it means that we should dispatch this async action in the grid component. We need to import run timer, and then when we call our click callback, we should
push here dispatch. Okay, then we need to change it a little bit. Yeah, we should call dispatch and put here runtime action creator. So, and then by the same logic for the on context menu, we should run action creator runtime again. Okay, and right now have on click and on context menu that gonna to call runtime. Let's check in the browser that everything works fine. So let's check first scenario where we put a flag. So, and then our timer gonna to increasing. Yeah, I can put much more flags. Yeah, and we still have the same logic. Yeah, our timer gonna to increase and call update time. Yeah, per every sec. Let's reset. And then let's probably one more time. Let's click and open some cell. Okay, I'm not so lucky. Yeah. Okay, let's click 3 times. Okay, and we see the same result. Our timer gonna to increase. So looks like we've done it based on Redux stuff, and we right now absolutely sure how can we make side effect management in the Redux infrastructure. Okay. Let's make one more Stryker refactoring, and right now you can see the report, and in the up to 6 we have zero coverage. Yeah, we have no anything to check here except probably snapshots. Let's make 2 snapshots, snapshot for up and snapshot for home. So, and for this purpose we need just to add uptest.tsx and add 2 more fragment, up and fragment home. Yeah, and both of these fragments should fix this trouble. Okay, let's move forward with our report. And probably in the models we have lowest Stryker score, and in game with hooks we have use game, and probably there is just as you can see it's just kind of bug, and Stryker shouldn't mutate this because we disable next line array declaration, but we still have this mutation. Okay, it's fine, nothing serious. Let's move to the game with Redux. So, and I see trouble here. When we mutate this flag is game over, everything still survived. Yeah, and probably we can fix it in case when we just lose our game. Yeah, because right now we never activate this option when is game over. Okay, let's make this possible, and for this purpose I believe that when we activate is game over, yeah, we must just lose our game. Yeah, and I have one more test case, yeah, where we just click to the item with the coordinate 88, and as far as I remember we have mock for this field. So, and it means that when we click on the bomb, yeah, and as far as we remember 9 it means bomb, we should explode. So, and in this case we just lose our game, and then we can find this negative smile, yeah, this sad smile, and then click to this button, and it means that we should reset our game to use this kind of button. As far as I remember, on the scoreboard we have component reset, yeah, and by the same way we have component game over, and this component render 2 smiles. When we win our game it's just smile with sunglasses, and sad smile when we lose our game. So it means that we should click to this button and we activate on click callback, and this on click callback just activate reset. So, and we just reset our game based on this test case. Okay, let's move forward, and we have game with React Redux, and there is a bunch of test cases probably that we can fix. Okay, and there we go. Right now we have game over, and probably we have no any test case for the game over, and even more we have no any callback call to the on reset. Okay, so then grid. On the grid we have no coverage for on click and on context menu. Okay, and then for the scoreboard we have no coverage for the callbacks, and also probably there is a problem when we just instead of minus just put here plus, means that we still works fine. So probably we need to add a little bit more realistic data to these bombs and flag counter parameters. Let's start from the scoreboard, and for the scoreboard we have no any coverage for these callbacks, and also this trouble with bombs minus flag counter. When we replace it to plus instead of minus, everything still works fine. Okay, let's add several test cases. Okay, and here we go. Right now I've just mocked React Redux and use selector and use dispatch. And then when we gonna to check scoreboard, I just mock return value for the use dispatch and for the use selector. And as you can see, I just import use selector and use dispatch, then mock it. And after this manipulation, just mock return value per use dispatch and per use selector. Okay. Level, as you can see, for the use selector, we have level, time, bombs, and flag counter. We have level beginner, time 0, bomb 10, flag counter 3. So in this case, when we replace minus to plus, right over here, instead of minus in bombs minus flag counter, if you put plus, it's just change behavior. For the rendering, digits will be different, and we can just use this simple case. Then we render our scoreboard and provide store that we import in line 7. So, and then we change select option. We just change in the combo box our level to intermediate and match snapshot on the intermediate, and then click button. Click button, and it must be reset button because we have just only one button on the scoreboard. Okay, let's take a look to the scoreboard component, and as far as I remember, we have just reset button, and that's only one real button on the page. Okay, so when we in the test case just click to the reset button, we reset our scoreboard to the default, and then our mock dispatch to have been called, because when we use here just one sec, when we use here dispatch, it means when we reset or when we change level, our mock dispatch should have been called in both cases. Okay, and probably we can make it a little bit more strict, because when we change level, it's just the first call for the dispatch, and then second call when we reset, and our mock dispatch to have been called 2 times in this case. So as you can see, everything has passed. Okay, everything works cool. And for the grid, we have no any coverage for the on click and for the on context menu. We can easily fix this. And for these purposes, we need to add test coverage to the on click and to the on context menu. Okay, then we just render our grid and match fragment, just to be sure that everything renders fine. So then we click to the coordinates 0, 0, and then we match snapshot. So, and then we click right mouse button, and then we expect that we have still match snapshot. It means that we click left button and right button, and then we just sure that everything works fine. Okay, and then last but not least, game over. And game over component, it have no any coverage for the selector, and also we have no any coverage for the dispatch action, and then we have no any coverage for the is game over. Okay, let's move to the test case. And We can easily mock selector and dispatch by the same way, just mock React Redux. And then when we is game over true and is win false, yeah, as you can see, we just mock these values, and then when is win false and is game over true, it means that we lose our game, and we should render this sad smile. So, and when we click to the sad smile, it means that our mock dispatch to have been called. And by the same way, when is game over true and is win true, it means that we win our game, and we can click to this sunglasses smile, so in our mock dispatch to have been called. Okay, let's check our report. Again, right now it's much more better, but we still have probably some minor issues in game with Redux, game with React Redux on the scoreboard. Okay, probably it's not something that we should care about, yeah, and in case when we just replace this dispatch, it's probably some minor issues, and I have no any purpose to fix every Stryker call. Okay, and for the game over, it's the same. We just object literal check, and we have survived test case. Okay, I have no any point to fix this issue too. Okay, so, and probably we've done it right now. Our test score, yeah, from the Stryker side, it's absolutely perfect, 98/89. Okay, so see you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.